Hi, good evening, everyone. Today we are going ahead and we are starting with chapter 1 of Anderson and Sweeney, जिसमें I am going to go ahead and discuss chapter 1 का section 1.2 today. 1.2 basically goes ahead and talks about data, right? It talks about what is a data, it talks about what is an element, it talks about what is a variable. Okay, so we are going to go ahead and we are going to take this in detail. And my aim will be कि हम रोज का एक सेक्शन लेकर हम इसको डिटेल में कवर करें so that we do well for our final exam. हम अपने फाइनल एग्जाम में अच्छा परफॉर्म कर पाए, right? So today I want to go ahead and I want to talk about what is the meaning of data and how do we go ahead and how do we use data. सेक्शन 1.2 है जो आज हम डिस्कस करने लगे हैं। ठीक है बेटा, चलिए लेट्स स्टार्ट। सो सेक्शन 1.2 डेटा। देखिए, सी फर्स्ट ऑफ ऑल डेटा, ये आपने सुना होगा, डेटा इज द न्यू ऑयल। मतलब जितना इम्पोर्टेंट ऑयल है इकोनॉमी के लिए, किसी भी इकोनॉमी को रन करने के लिए जितना इम्पोर्टेंट तेल है उतना ही इम्पोर्टेंट डेटा है। दैट इज द इम्पोर्टेंस ऑफ डेटा। तो ये डेटा है क्या? ये डेटा बेसिकली है फैक्ट्स, फिगर्स। ठीक है, जो भी फैक्ट एंड फिगर होते हैं, जैसे अगर मैं आपको बोल दूं कि मेरे पास 30 इयर्स का इकोनॉमी का जीडीपी है या लास्ट 5 इयर्स के किसी इकोनॉमी का मेरे पास आउटपुट प्रोडक्शन है स्टील का, दिस इज ऑल डेटा। ये फिगर्स हैं, ये फैक्ट्स हैं। एंड वेन एवर वी हैव दिस डेटा, जब भी मेरे पास ये डेटा होता है, फर्स्ट थिंग इज वी हैव टू कलेक्ट द डेटा। किसी भी डेटा को हमें कलेक्ट करना होता है। जब हम किसी डेटा को कलेक्ट कर लेते हैं उसके बाद उसी डेटा को हमें एनालाइज करना होता है। जब हम किसी डेटा को एनालाइज करते हैं उसके बाद जो भी हमारा एनालिसिस होता है, जैसे मैंने एक डेटा का मीन, मीडियन, मोड कुछ निकाला, आई फाउंड आउट मीन मीडियन मोड ऑफ अ डेटा, दैट मीन्स आई एनालाइज्ड द डेटा। तो जब मैं किसी डेटा को एनालाइज कर लेती हूँ उसके बाद आई हैव टू समराइज दैट एनालिसिस। आई हैव टू समराइज इट, मुझे उसकी समरी देनी होती है। And once I summarize it, suppose मैंने इसका mean median mode निकाल लिया, I have summarized it, then I will go ahead and I will do a presentation of it. मैं उसको किस तरीके से प्रेजेंट करूंगी, चाहे मैं हिस्टोग्राम में प्रेजेंट करूं, चाहे मैं बार ग्राफ के थ्रू करूं, चाहे मैं पाई चार्ट में करूं, आई विल प्रेजेंट द डेटा। एंड वंस आई हैव प्रेजेंटेड द डेटा, जब मैंने एक बार अपने डेटा को प्रेजेंट कर लिया उसके बाद आई विल लीव इट फॉर इंटरप्रिटेशन। जैसे अगर मैंने इस डेटा को प्रेजेंट किया, सो सपोज मैंने दिखा दिया कि किसी इकोनॉमी में 30% जीडीपी कंट्रीब्यूशन एग्रीकल्चर का है, 25% इंडस्ट्री का है, 10% सर्विसेज का है। आई एम शोइंग द contribution of different sectors, so I can then interpret this, right? So this is basically your data का पूरा तरीका कि हम डेटा के साथ कैसे हैंडल करते हैं। Now once we go ahead and once we handle this data, जब हम इस डेटा को हैंडल करना जान जाते हैं, the next thing which we want to go ahead and which we want to do is, what is this data called? All the data. So first of all, what did we study till now, beta? We said that any data, जब हम किसी भी डेटा की बात करते हैं, this is basically facts and figures. Any data is basically facts and figures. These facts and figures, they are collected. After we collect the facts and figure, these facts and figures, they are analyzed. Then we summarize them. They are presented and then interpreted. This is how we work with data. राइट. नाउ द डेटा दैट वी कलेक्ट फॉर अ पर्टिकुलर स्टडी, अगर किसी एक पर्टिकुलर स्टडी के लिए, जैसे अगर मैंने डेटा कलेक्ट किया टू अंडरस्टैंड whether there is wage difference between male and female, whether there is a marks, average marks differ between the six sections of a class A, B, C, D, E, F, between six classes of a school. So whenever we go ahead and whenever we collect the data for a particular study, एक चीज पढ़ाई करने के लिए, एक चीज पढ़ने के लिए अगर मैं डेटा को कलेक्ट कर रही हूँ, whenever we collect data for a particular study, जब हम ऐसा करते हैं तो उसको हम बोल देते हैं डेटा सेट. So whenever we collect data for a particular study, अगर कुछ पढ़ने के लिए मैंने डेटा कलेक्ट किया है, this is called as data set. उसको हम डेटा सेट बोल देते हैं. Right? Now, we have something which is known as elements. Elements क्या है? Elements are entities on which data is collected. Element are entities on which data is collected. ठीक है. तो अब एक और एग्जाम्पल लेके देख लेते हैं. लेट अस गो अहेड एंड ट्राई टू अंडरस्टैंड अनदर एग्जाम्पल. सो suppose if I go ahead and if I tell you that here is my country name, ठीक है, यहां पे हम इनसे रिलेटेड WTO स्टेटस, GDP और कुछ चीजें कलेक्ट कर रहे हैं. कंट्री नेम है इंडिया, कंट्री नेम हो गया USA, ब्राजील, पाकिस्तान, साउथ अफ्रीका, जो भी है, यू हैव कंट्री नेम्स. ठीक है. अगेन ट्राई टू अंडरस्टैंड दिस इन डिटेल कि हम यहाँ पे क्या बोल रहे हैं. व्हाट आर वी गोइंग अहेड एंड व्हाट आर वी सेइंग. हम बोल रहे हैं दैट if I go ahead and if I look into this, so now these are my elements. What is my element? क्या है मेरा एलिमेंट? My element is the entity for on which data is collected. Element is the entity on which data is collected. So here I am collecting data on 60 nations. So that's my entity on which data is collected. So this becomes an element. Element is the entity on which data is collected. ठीक है. So basically element with nation or element name that is shown here, ये India is an element, USA is an element, Brazil is an element. These are elements. Element is the entity on which data is collected. ठीक है. Now, what is a variable? Variable is the characteristic of interest for the element. तो वेरिएबल क्या है? वेरिएबल हो जाता है कि इस इंडिया के लिए मुझे क्या क्या जानना है. What is my characteristic of interest? I want to understand about WTO status. I want to understand about GDP. I want to understand about some other thing. What is my variable of interest? What is the characteristic of interest? किस चीज के बारे में जानना है? That becomes a variable. A variable can have multiple values. Like values of the element. A variable can have multiple values. जैसे WTO का status can be a member or a non-member. So the variable can have different values. Member, non-member, member, non-member, ऐसे. It can have different values. So basically, when we talk about any variable, it can have different values. तभी तो उसको variable बोलते हैं. It varies. So a variable can have different values with it. ठीक बात है. Is it clear? अब हम बोल रहे हैं that what is a observation. The value taken. जैसे इंडिया की ऑब्जर्वेशन हो गई कि WTO का स्टेटस है मेंबर. द वैल्यू ऑब्जर्व्ड. जैसे जीडीपी कैन टेक डिफरेंट वैल्यूज, तो जीडीपी इज अ वेरिएबल, बट द वैल्यू टेकन, जीडीपी का जो वैल्यू इंडिया के लिए आएगा, द वैल्यू ऑफ द वेरिएबल, राइट, मेजरमेंट ऑफ दैट वैल्यू, जो भी मेजरमेंट आ रही है, दैट इज बेसिकली एन ऑब्जर्वेशन. So measurement collected on each variable for each element. हर एलिमेंट और हर वेरिएबल के लिए जो वैल्यूज निकल के आ रही हैं, वो ऑब्जर्वेशन है. दैट इज ऑब्जर्वेशन. इज इट क्लियर? कुछ डाउट इसमें? एनी वन, एनी डाउट? ठीक है. नाउ वी टॉक अबाउट द स्केल ऑफ मेजरमेंट. द स्केल ऑफ मेजरमेंट. सो जब भी हम स्केल की बात करते हैं, देर आर फोर मेन स्केल्स ऑफ मेजरमेंट. चार मेन स्केल होते हैं मेजर करने के. नॉमिनल, ऑर्डिनल, इंटरवल एंड रेशियो. ठीक है. सो द फर्स्ट स्केल ऑफ मेजरमेंट दैट वी हैव, दैट इज कॉल्ड एज नॉमिनल स्केल. Nominal scale of measurement is when the data for a variable of label or name is used to identify an attribute. मतलब जैसे मैंने आपको बोला कि WTO का स्टेटस है मेंबर वर्सेस नॉन मेंबर. सो आई एम आइडेंटिफाइंग इंडिविजुअल कि क्या वो मेंबर है या नॉन मेंबर है. बट मेंबर या नॉन मेंबर होना नॉन न्यूमेरिकल वैल्यू है. ठीक है. मैं बोल सकती हूँ कि अगर मेंबर है तो वैल्यू 1 दे दो, नॉन मेंबर है तो वैल्यू 2 दे दो, बट इस 1 और 2 का कोई इंप्लीकेशन नहीं है. ना मेंबर और नॉन मेंबर के बीच में रैंकिंग पॉसिबल है. आई कैनॉट रैंक द वैल्यूज अंडर द वेरिएबल. मैं रैंकिंग नहीं दे सकती हूँ. आई के नॉट गो हेड एंड आई के नॉट से कि मेंबर नॉन मेंबर के ऊपर है या नॉन मेंबर मेंबर के ऊपर है. ऐसा तो नहीं बोल सकते. सो दैट इज अ नॉमिनल स्केल वेयर you are giving qualitative values but you cannot give quantifiable values for them. उनको आप quantify नहीं कर सकते हो. The second one that we have, वो हो जाता है बेसिकली ऑर्डिनल स्केल. स्केल ऑफ मेजरमेंट इज ऑर्डिनल अगर वो नॉमिनल तो है ही है. इट हैज प्रॉपर्टीज ऑफ नॉमिनल प्लस रैंकिंग इज पॉसिबल. मतलब हियर वी वर, यहां हम नहीं बोल सकते थे कि मेंबर इज बेटर देन नॉन मेंबर या नॉन मेंबर इज बेटर देन मेंबर. वी कैन नॉट से दिस. ऐसा हम नहीं बोल सकते. बट इन ऑर्डिनल स्केल वी कैन गो अहेड एंड वी कैन से दैट. यहां पे हम बोल सकते हैं. सो वी कैन से कि अगर किसी का क्लास में ए आया है और किसी का बी आया है, देन द स्टूडेंट विद ए विल हैव स्कोर्ड मोर मार्क्स. अगर किसी का क्रेडिट रेटिंग ए है एंड समवन्स क्रेडिट रेटिंग इज एफ, देन दिस क्रेडिट रेटिंग विल हैव मोर सिबिल स्कोर. So we can go ahead and we can give ranking. Ranking is possible. तो उसको हम ऑर्डिनल स्केल बोल सकते हैं. थर्ड, इंटरवल स्केल. इंटरवल स्केल विल हैव ऑल प्रॉपर्टीज ऑफ ऑर्डिनल. ये ऑर्डिनल का सारा प्रॉपर्टीज कैरी करता है. प्लस when we talk about interval scale, we can express the values in terms of fixed यूनिट ऑफ मेजरमेंट, फिक्स्ड यूनिट ऑफ मेजरमेंट, राइट। मतलब ये तो मुझे पता है कि एक स्टूडेंट जिसके 650 मार्क्स आ रहे हैं, ही इज मोर देन अ स्टूडेंट हु हैज गॉट 550, बट ये भी पता है दैट ही हैज गॉट 100 मोर मार्क्स, सो आई कैन ऑल्सो टेल हाउ मच मोर। यहां पे आई नो कि अ स्टूडेंट हु हैज स्कोर्ड ए इज बेटर देन बी, बट बाय हाउ मच, ये अननोन है। बट बाय हाउ मच अननोन है, बट हियर आई नो कि इट इज बाय 100 स्कोर। सो बाय हाउ मच आई कैन एक्सप्रेस, मैं ये बता सकती हूं कि कितने से ज्यादा है। आई कैन गो ahead and I can tell that, right? And the last one is ratio scale. The scale of measurement for a variable is ratio scale if it has all properties of interval scale. इंटरवल स्केल का सारा प्रॉपर्टीज होगा, प्लस देर इज अ मीनिंग ऑफ द रेशियो ऑल्सो, उनके रेशियो का कुछ मीनिंग है, right? So that means in this case, we want to see that a zero value should be included to indicate that nothing exists for that variable except the 0 point. यहां पे जीरो वैल्यू का मीनिंग है, राइट। सो आई गिव यू एन एग्जाम्पल। सो जैसे अगर हम ले लेते हैं एक प्रोडक्ट है, प्रोडक्ट ए, अगर इस प्रोडक्ट की वैल्यू जीरो है तो इसका मतलब कुछ है कि इट इज फ्री ऑफ कॉस्ट, राइट। अगर इस प्रोडक्ट की वैल्यू 20 रुपीज है तो इट मीन्स समथिंग। अब अगर मैं एक प्रोडक्ट बी ले लेती हूं जिसकी जिसका प्राइस 40 रुपीज है, तो एक चीज तो मुझे पता है, वन थिंग आई नो, कि प्रोडक्ट बी इज 20 रुपीज मोर देन प्रोडक्ट ए। तो इस गैप का मीनिंग है दैट प्रोडक्ट बी इज 20 रुपीज मोर देन प्रोडक्ट ए, मतलब इट इज फॉलोइंग द प्रॉपर्टीज ऑफ इंटरवल स्केल। बट ये भी है कि इफ आई फाइंड द रेशियो, तो आई कैन से दैट प्रोडक्ट बी is 2 times more expensive than A. So I can also go ahead and say कि what is the meaning of the ratio? रेशियो का भी कुछ मीनिंग है, रेशियो implies समथिंग, रेशियो का मीनिंग है कुछ। So we can go ahead and we can say that yes, this is therefore a ratio scale. Okay. Now we will talk about categorical versus quantitative data. कैटेगरिकल वर्सेस क्वांटिटेटिव डेटा, थोड़ा समझो। व्हेन वी टॉक अबाउट कैटेगरिकल डेटा, कैटेगरिकल डेटा इज एनी डेटा विच कैन बी नॉमिनल या ऑर्डिनल। देखो, यहां पे तो मुझे डिफरेंस निकालना जरूरी है, सो इट कैन नॉट बी इंटरवल। ओनली यहां एंड यहां कैटेगरीज पॉसिबल है। कैटेगरी मीन्स दिस इज अ क्वालिटेटिव डेटा सेट। कैटेगरीज मींस कि मैं सिर्फ ऐसे बता सकती हूँ कि एक चीज का ग्रेड ए है या बी है, मेल या फीमेल, रिलीजन, रीजन, ये सब कैटेगरिकल डेटा सेट है, ठीक है। whereas when I talk about quantitative data set, जब मैं quantitative data set की बात करती हूँ, तो this is something जहां पे मेरे को numbers चाहिए। it means it can be ratio or it can be interval. So a quantitative data set is obtained using interval or ratio scale of measurement. क्वांटिटेटिव डेटा सेट में नंबर्स के साथ काम किया जाता है, राइट. क्वांटिटेटिव डेटा सेट में यू कैन परफॉर्म सम काइंड ऑफ ऑपरेशंस. आप मीन, मीडियन, मोड, स्टैंडर्ड डिविएशन ये सब निकाल सकते हो. देन इट इज अ क्वांटिटेटिव डेटा सेट. ठीक है. नाउ देर आर टू काइंड ऑफ डेटा सेट्स, थ्री एक्चुअली बेटा. एक हो जाता है क्रॉस सेक्शनल, द अदर इज टाइम सीरीज, द थर्ड इज panel data. Cross sectional, time series and panel data set. Look at the first one. When we go ahead and when we talk about cross sectional data set, then this is the data set which is one variable, second variable, third variable, but same time period. ठीक है. जैसे अगर मैं सिर्फ 2010 के लिए जीडीपी, WTO स्टेटस एंड मेनी अदर थिंग्स निकाल लूं, सो डिफरेंट वेरिएबल बट सेम टाइम पीरियड, देन इट इज क्रॉस सेक्शनल. डेटा कलेक्टेड एट सेम टाइम पीरियड, दैट इज क्रॉस सेक्शनल. ठीक है. अब हम बात करते हैं टाइम सीरीज डेटा की. टाइम सीरीज मींस टाइम पीरियड 1, time period 2, time period 3 and so on for only one variable. For only one variable. मतलब अगर हम यहां पर ये बोल देते हैं that 2010, 2011, 2012 till 2021 तक का I am finding GDP of India. So one variable for different time periods, that is time series data set. एंड वेन वी क्लब द टू, अगर मैं टाइम सीरीज और क्रॉस सेक्शनल को क्लब कर देती हूं, दैट इज पैनल डेटा सेट. अ पैनल डेटा सेट इज एनी डेटा सेट विच इज फॉर मेनी पीरियड एंड मेनी वेरिएबल्स. ठीक है. माने एक पैनल डेटा सेट कौन सा डेटा सेट होगा? सो फॉर एग्जाम्पल इफ आई कलेक्ट द इंफॉर्मेशन ऑफ जीडीपी, WTO स्टेटस एक्सेट्रा एक्सेट्रा फॉर द ईयर 2010 टू 2025, मतलब टाइम भी चेंज हो रहा है और वेरिएबल्स भी बहुत सारे हैं, देन दैट विल बी अ पैनल डेटा सेट. ठीक है. इज इट क्लियर? हाय, गुड इवनिंग एवरीवन. बेटा आज हम बात करने वाले हैं अबाउट डेटा सोर्सेस. About data sources. When we talk about data sources, जो हमारा first source of data होता है, that is called as existing excuse me, existing source. Existing source को हम secondary data भी बोलते हैं. Existing source is also called as secondary data. जैसे for example, अगर मुझे किसी कंपनी का जानना है, दिस इज एन ऑलरेडी अवेलेबल डेटा. हाँ, तो अगर मुझे किसी कंपनी का एम्प्लॉय रिकॉर्ड जानना है तो उसके पास ऑलरेडी है. किसी कंपनी में जानना है कि हर एम्प्लॉय को कितना सैलरी मिलता है, दैट्स ऑलरेडी प्रेजेंट. इफ आई वांट टू नो द सेल्स रिकॉर्ड ऑफ अ कंपनी, इट्स ऑलरेडी प्रेजेंट. अगर मुझे रीजन वाइज सेल्स निकालना है, इट्स ऑलरेडी प्रेजेंट. राइट. सो दिस कैन बी एन एग्जाम्पल ऑफ secondary data or existing data. So so existing sources, already available data, right? This is easily available, cheap, quick. If we have to do some examples, अगर हमें इसके examples करने हैं, the first will be internal company data, right? The second one that we have, वो होगा sales record. The third one will be inventory data. The fourth can be कंज्यूमर प्रोफाइल्स, कि मुझसे जो कस्टमर खरीदते हैं उनका प्रोफाइल कैसा है. सो दिस इज द फर्स्ट एग्जाम्पल ऑफ डेटा, एंड इसको हम इंटरनल डेटा, कंपनी का जो डेटा है वो जब हम निकाल सकते हैं, फेच कर सकते हैं कंपनी के थ्रू, वी कैन जस्ट आस्क कंपनी अबाउट देयर डेटा. दैट इज द एग्जाम्पल. अच्छा, द सेकेंड वन इज, ये इसका मेन हेडिंग हो गया. इसका एग्जाम्पल वन हो गया एम्प्लॉय डेटा, टू हो गया सेल्स रिकॉर्ड, इन्वेंट्री डेटा, कंज्यूमर प्रोफाइल. फिर हम बात करते हैं एक्सटर्नल डेटा की, एक्सटर्नल ऑर्गेनाइजेशन की. जैसे फॉर एग्जाम्पल, मेरे को चाहिए कि मेरे को हर कंट्री का जीडीपी पता चले. हाँ, तो मैं डब्ल्यूटीओ की वेबसाइट पे जा सकती हूँ, मैं आईएमएफ की वेबसाइट पे जा सकती हूँ, पता कर सकती हूँ जीडीपी कितना है, लोन्स कितने चल रहे हैं कंट्रीज के. सो देन दिस इज ऑल्सो एन एग्जिस्टिंग डेटा, बट ये मुझे एक्सटर्नल ऑर्गेनाइजेशंस के थ्रू मिलते हैं. जैसे बिजनेस डेटाबेस. सो आई गिव यू एन एग्जाम्पल. जैसे समटाइम्स लेट्स से, एक एग्जाम्पल के लिए लेट्स से आई एम अ कंपनी, ठीक है, जो डील करता है रेजिडेंशियल फ्लैट्स में. मुझे एक फ्लैट सेल करने हैं और इसके लिए मुझे डेटा चाहिए उन लोगों का जो सपोज 10 लाख प्लस पर मंथ अर्न करते हैं. मेरे बहुत लग्जरी प्रोजेक्ट्स हैं, मुझे उन लोगों का डेटा चाहिए जो इतना पैसा कमाते हैं. सो इफ आई कैन गेट दिस फ्रॉम सम कंपनी, मेरे बिजनेस से रिलेटेड डेटाबेस आई नीड फ्रॉम सम कंपनी, देन दिस विल बी एन एक्सटर्नल ऑर्गेनाइजेशन. क्लियर बात है. द सेकेंड इज इंडस्ट्री एसोसिएशंस. द थर्ड इज रिसर्च एजेंसीज. मैं किसी रिसर्च एजेंसी से अगर डेटा कलेक्ट, उसका कलेक्टेड डेटा लूं विच इज अवेलेबल विद द रिसर्च एजेंसी, ठीक है, तो ये भी ऑलरेडी अवेलेबल डेटा रहेगा. देन यू कैन ऑल्सो हैव गवर्नमेंट डेटा. गवर्नमेंट डेटा में द फर्स्ट एग्जाम्पल इज सेंसस. सेंसस में ऑलरेडी अवेलेबल डेटा रहेगा पॉपुलेशन का, इनकम का. द सेकेंड अवेलेबल डेटा कैन बी फाइनेंशियल डेटा, प्राइजेस, स्टॉक मार्केट डेटा. ये सब एग्जाम्पल्स आई एम गिविंग. देन द नेक्स्ट सोर्स कैन बी इंटरनेट. आज आप गूगल करो और आपको कंपनी की वेबसाइट से उनका डेटा मिल जाएगा अगर आपको कोई रिसर्च करनी है. या आप गूगल करो और आपको फाइनेंशियल डेटा चाहिए और आपको इंटरनेट के थ्रू मिल गया जो भी आपको रिसर्च करनी है, राइट. सो द गुड थिंग हियर इज दैट दिस काइंड ऑफ डेटा, दिस इज फास्ट, this is cheap, but this may not fit your exact requirement. May not fit exact requirement. क्यों? Why it not fit the exact requirement? Suppose बेटा I am doing PhD, और PhD में एज अ रिसर्चर मेरे कुछ स्पेसिफिक क्वेश्चंस हैं. जैसे इफ आई एम गोइंग अहेड एंड इफ आई एम डूइंग PhD इन सपोजिटली, मैं PhD कर रही हूं इन विमेन एम्पावरमेंट, that how the coming up of say the policy of ड्रोन दीदी, जो अभी हमारे एक बजट में ड्रोन दीदी पॉलिसी आई थी, उससे एग्रीकल्चरल सेक्टर की वुमेन का कितना एम्पावरमेंट हुआ है. या इज देयर एनी लिंक बिटवीन फाइनेंशियल इंक्लूजन एंड विमेन एम्पावरमेंट, कि क्या जब हम फाइनेंशियली इंक्लूसिव करते हैं, हर इंडिविजुअल का बैंक अकाउंट खुलवाते हैं, क्या उससे विमेन एम्पावरमेंट, इज इट लिंक्ड और नॉट, क्या उससे विमेन एम्पावरमेंट होती है या नहीं होती है. सो बेसिकली व्हाट आई वांट टू गो एंड डू इज डू अ स्पेसिफिक स्टडी. Now I may have data on financial inclusion कि कितने लोग financially include हुए. I may have data on some data on women empowerment some aspect. But शायद जो मेरे को study करना है वो exact data वो exact चीज मेरे पास available नहीं होगी. Right? So although this is very easy, जो secondary data होता है, existing data होता है, existing source होता है, it is very easy, cheap and quick to access. Right? But it may not always go ahead and fit your exact requirement. What you want, वो उस requirement को fulfill may not do so. Right? So this is the first. Now, the second one that we have that is called as observational study. Observational study. Observational study basically goes ahead and it says that we any researcher, we माने researcher जो research कर रहा है, researcher does not control variables. Researcher only observes variables. So cannot control variables. Just observe them. ठीक है. जैसे क्या मैं कंट्रोल कर सकती हूँ? कैन आई कंट्रोल हाउ अ स्टूडेंट बिहेव्स इन द क्लास? ऑफ कोर्स एज अ टीचर आई कैन स्टिल स्कोल्ड यू गाइस. बेबी थोड़ा तो है टीचर स्टूडेंट का, बट in online mode can I control what you guys are doing? I may observe what you're doing, but can I control that? Can I control कि एक कस्टमर मेरे स्टोर पे आके कैसा बिहेव कर रहा है? नहीं ना. Can I control what you will fill in a particular poll? नहीं ना. So basically these are the things which I cannot control. Right? These are the things which I cannot control. So this is what you cannot control. You can only observe but not control it. ठीक है. So example के लिए you can have consumer behavior in a store, right? CEO, gender versus firm performance. क्या मैं कंट्रोल कर सकती हूँ कि कैसे जेंडर चेंज होने पे अगर परफॉर्मेंस चेंज होता है तो? आई कैन नॉट कंट्रोल दैट ना. सर्वेज, पोल्स, ये सब हम कंट्रोल नहीं कर सकते. Right? So we cannot control these things. We can only observe these things. Right? We can just observe what is happening in a particular situation. हम सिर्फ observe कर सकते हैं. Right? So suppose if I want to investigate कि gender कि CEO का क्या gender है और उससे firm की performance पे क्या फर्क पड़ता है. ठीक है. उससे return on equity पे क्या फर्क पड़ता है. तो what I can do? I can collect the data of many companies. हर कंपनी के मैं सीईओ का जेंडर और उनका रिटर्न ऑन इक्विटी चेक कर सकती हूँ. राइट? सो दिस इज व्हाट आई ऑब्जर्व. आई डोंट हैव कंट्रोल ओवर द जेंडर ऑफ सीईओ. आई डोंट हैव कंट्रोल ओवर द आरओई ऑल्सो. रिटर्न ऑन इक्विटी पे भी मेरा कंट्रोल नहीं है उस कंपनी की. Right? So there is no control that I have. This is just an observation I can make. Are you understanding this thing? So this is an observational data. ये एक observational data है. I don't know what is happening in today's video. It's going on and off. कुछ गड़बड़ हो रही है with Zoom. Anyways. So this is what is your second data. ठीक है. अब हम बात करते हैं आफ्टर ऑब्जर्वेशनल डेटा. इसके बाद थर्ड एस्पेक्ट आ जाता है एक्सपेरिमेंट. तो यहां पर क्या है, ऑब्जर्वेशन में मेरा कोई कंट्रोल नहीं है, मैं सिर्फ देख रही हूं चीजें. मैं उनको लिख सकती हूँ कि मैंने ऐसा देखा वैसा देखा, बट आई कैन नॉट कंट्रोल देम. इन एक्सपेरिमेंट अ रिसर्चर कैन control variables. A researcher can go ahead and control variables. ठीक है, जैसे for example, if I want to see the impact of drinking on driving, तो ये ड्रिंकिंग आई कैन कंट्रोल कि किसको कितना ड्रिंक पिला के ड्राइव करवा के देखना है. आई कैन कंट्रोल दैट. सो बिकॉज आई कैन कंट्रोल कि अच्छा 1 ग्लास के साथ कितना कोई सेंसेस में है, विद 2 ग्लासेस कितना कोई सेंसेस में है, समथिंग लाइक दैट. सो इट मीन्स आई कैन इस्टैब्लिश कॉज एंड इफेक्ट रिलेशनशिप. आई कैन इस्टैब्लिश कि कितना ड्रिंकिंग के साथ कितना ड्राइविंग डिफिकल्ट है. दैट कॉजल इफेक्ट रिलेशनशिप कैन बी इस्टैब्लिश्ड. इज इट क्लियर? सो दिस इज द एक्सपेरिमेंट डेटा. ठीक है. अच्छा, सो देयर इज अ वेरी इंटरेस्टिंग एस्पेक्ट यहाँ पे. It is believed कि largest experimental statistical study ever that was conducted. It was in the year 1954, right? It was a public health service experiment for Salk polio vaccine. ठीक है. नियरली कितने लोगों को हुआ बेटा? 2 million children in the grade 1, 2, 3, they were selected from different parts of US, right? So it is considered one of the largest, uh, experiment statistical survey. ठीक है, statistical study जो हुई थी. ठीक है. अच्छा, now, अच्छा, आई एम ओनली टॉकिंग अबाउट यूएस बाय द वे. हाँ, माने वी आर टॉकिंग अबाउट द फैक्ट कि उस टाइम पे लार्जेस्ट स्टडी एवर ये कंडक्ट की गई थी टू अंडरस्टैंड द कॉज इफेक्ट रिलेशनशिप. कि जब हम डोज देते हैं तो क्या फर्क पड़ता है, 2 डोज देते हैं तो कितना फर्क पड़ता है पोलियो पे, राइट? ओके. नाउ लेट्स टॉक अबाउट अनदर एस्पेक्ट हियर, जिसका मीनिंग है टाइम एंड कॉस्ट कंसिडरेशन से रिलेटेड. टाइम एंड कॉस्ट कंसिडरेशन. टाइम एंड कॉस्ट कंसिडरेशन बोलता है that when we talk about the existing data, this is the most easy to collect. आपने नेट पे टाइप किया और आपको डेटा मिल गया. So it is low cost and it is very fast, right? Now when we talk about the second one, observational data, right? This can be easy to collect. But when we talk about experimental data, this is very difficult to collect. Not only difficult, but very high cost, time consuming. So this is high cost, time consuming data to be collected. समझ में आ रहा है? Now, whenever we have to collect a new data, चाहे वो ऑब्जर्वेशन के लिए हो, जैसे सेंसस, इसमें हम कुछ कॉज इफेक्ट रिलेशनशिप नहीं बताते. हम बताते हैं कि कितने मेल हैं, कितने फीमेल हैं, क्या उनकी अर्निंग है, क्या उनका मंथली एक्सपेंडिचर है, कितना वो मिल्क कंज्यूम करते हैं. वी जस्ट डू दीज थिंग्स, राइट? सो दिस इज ऑब्जर्वेशनल. हम सिर्फ ऑब्जर्व कर रहे हैं. या एक्सपेरिमेंट हो, वी ट्राई टू इस्टेब्लिश अ रिलेशनशिप. But because this is a new data, whenever we will have a new data, जब भी हमें एक न्यू डेटा को निकालना होगा, this will be costly, this will be time consuming. And in this case, will we spend time and cost on पुलिंग आउट द डेटा, क्या हमें टाइम और कॉस्ट लगाना चाहिए उस डेटा को निकालने के लिए? द आंसर इज ओनली इफ बेनिफिट्स exceed cost. Only if the benefits exceed the cost. Only then it is worth taking out new data. सिर्फ हमें तब new data को pull out करना चाहिए. Is it okay? Okay. Now there is something called as data acquisition errors. Data acquisition errors. डेटा एक्विजिशन एरर माने डेटा को एक्वायर करते हुए, while acquiring data, while collecting data, whatever errors you will do, that is called as data acquisition errors. Now, what are the errors we can do? Number one, recording errors. Right? For example, someone told me that my salary is 24,000. But in my mind, something was going on, और जब मैंने लिखा, when I typed 42,000. So this is a recording error. I recorded it incorrectly. Okay. The second one that we have, that is basically misinterpretation. Misinterpretation. Misinterpretation माने क्या? Misinterpretation माने I did not interpret it correctly. ठीक है? जैसे for example, let's say that someone was telling me something about working. मैं women empowerment में काम कर रही हूँ, उसका कुछ तो I am doing a research and I was asking, do you work or do you not work? And then that lady, she started saying कि you know what, मैं जाती तो हूँ काम पे, वहां पे पता है मैं अपना उस बच्चे का पूरा, जिनके घर पे मैं जाती हूँ वहां पे मैं पूरा ख्याल रखती हूँ उस बच्चे का, और फिर वहां से मैं आगे जाती हूँ, बट वो लोग मुझे खाना देते हैं बट पैसे नहीं देते. सम स्टोरी शी मेड अप. नाउ इन दैट स्टोरी I did not understand well whether she's actually working or not. Is she getting money out of it or not? Is it a productive activity or not? And because of interpreting it incorrectly, I wrote an incorrect answer to it. Right? So, uske against, I wrote working when she was not, or I wrote not working when she was. So, when you ask someone some question in the interview, in the survey, in the poll, और उसका वो आंसर कुछ गलत दे दे, then that is misinterpretation. ठीक है? The third is outliers. Outliers is basically, we know outlier क्या होते हैं. So suppose, let's say that say suppose, let me think of an example. Let's say कि ऐसा कुछ है कि supposedly कि you know I'm asking कि यहाँ पे मैंने कुछ रेंज रखी है सैलरी की, and I'm asking, is your salary between 10,000 to 20, 20 to 30, or more than 30K per month? कुछ तो सर्वे आई एम डूइंग. ठीक है? यहां पर क्या होता है कि ये जो मोर देन 30K है, दिस कैन बी एन इंडिविजुअल जिसकी इनकम कैन बी 40,000, जिसकी इनकम कैन बी 60,000, जिसकी इनकम कैन बी 1 lakh. वी डोंट नो व्हाट मोर देन 30,000 इज. राइट? Now, supposedly, what I do is that जब भी, whenever there are unusually large or small values, suppose I go ahead and I uh, put them within a bracket. But what I do is कि whatever will be more than 30,000, I account them at 30,000. Whatever are my outliers, suppose किसी का salary मैंने यहाँ पे लिख दिया less than 10, and less than 10 को suppose I account them as 10. जिनकी भी less than 10 है, I'm accounting them as 10. More than 30, I'm accounting as 30. So when this happens, this is actually making an error. समझ रहे हो? Now try to understand that wrong data is more harmful than no data. जब भी आप इन तीनों चारों चीजों की वजह से गलती करते हो, wrong data is more dangerous. Error often occur with data acquisition. जब भी आप data acquire करोगे error होंगे. इसलिए कभी भी डेटा को ब्लाइंडली फॉलो नहीं करना है. डोंट यूज द डेटा ब्लाइंडली. थिंक अबाउट डेटा, इंटरप्रेट द डेटा, एनालाइज द डेटा, क्लेंस द डेटा, एंड देन यूज द डेटा. क्योंकि वर्किंग विद रॉन्ग डेटा इज मोर डेंजरस देन वर्किंग विद नो डेटा एट ऑल. ठीक है? ओके बेटा, थैंक यू. We'll talk about section 1.4, which is descriptive statistics. Descriptive statistics. Now, what exactly is descriptive statistic? क्या है ये? Descriptive statistic basically is a method to summarize data. We are using a method to summarize data. जब मैं data को summarize करती हूँ using some method, that is descriptive statistics. Now there are different ways in which I can describe my data. First, I can go ahead and I can describe my data through a summary of data in a tabular way. I can use a graphical way. I can use a numerical way. ठीक है? तो मैं अलग अलग तरीके यूज कर सकती हूँ टू डिस्क्राइब माई डेटा. जैसे टैब्यूलर वे में आई कैन गो अहेड एंड आई कैन यूज फ्रीक्वेंसी टेबल्स कि ये ऑब्जर्वेशन है और इसका कॉरेस्पॉन्डिंग फ्रीक्वेंसी क्या क्या है. ग्राफिकल वे में I can go ahead and I can make bar graphs. I can make histograms. Numerical way में I can use measure of central tendency. मतलब मैं mean, median, mode ये सब निकाल सकती हूँ. Right? So there are different ways in which I can go ahead and I can summarize the entire data set. मैं उसको tabular way में summarize कर सकती हूँ, उसको graphical way में summarize कर सकती हूँ, या उसको numerical way में summarize कर सकती हूँ. Right? Now, आई गिव यू एन एग्जाम्पल। इसका एक एग्जाम्पल हो सकता है द डेटा which is concentrated in a particular range। राइट, ऐसा कोई डेटा जो एक पर्टिकुलर रेंज में हो। ठीक है, सो इस केस में व्हाट आई कैन गो अहेड एंड डू इज कि मैं उसका मीन निकाल के बता सकती हूँ कि एग्जैक्टली ये डेटा का एवरेज कितना है, या उसका मिनिमम एंड मैक्सिमम वैल्यू निकाल के बता सकती हूँ कि एग्जैक्टली ये डेटा कहाँ लाई करता है। राइट, सिमिलरली सपोज मैं कंज्यूमर का सर्वे लेती हूँ और उनसे पूछती हूँ कि क्या आपको पॉजिटिव फीडबैक है या नेगेटिव फीडबैक है। सो समवन सेज पॉजिटिव फीडबैक, समवन सेज नेगेटिव, एंड कुछ ऐसे लोग हैं जो इंडिफरेंट है, जिन्हें कोई फर्क नहीं पड़ता। राइट, एंड सपोज देर आर 15 पॉजिटिव फीडबैक, 10 नेगेटिव फीडबैक एंड 5 पीपल जिनको कोई फर्क नहीं पड़ता। आई कैन ऑल्सो कन्वर्ट दिस इन परसेंटेज। तो ये टोटल कितना हो जाता है बेटा, 15 + 5 20 + 10 30। So 15 by 30 into 100, 50%. 10 by 30 into 100, 33%. 5 by 30 into 100, 1 by 6, approximately the remaining 17%. हम इसको परसेंटेज में भी कन्वर्ट कर सकते हैं। वी कैन ऑलवेज मेक अ बार चार्ट आउट ऑफ इट। तो हम बोल सकते हैं कि पॉजिटिव रिव्यूज आर 15, negative reviews are 10, and people who are indifferent, उनके number of reviews are 5. I can also go ahead and do that, है ना। Similarly, मैं suppose if I have different countries and I am given their GDP, ठीक है, तो मैं इसमें रेंज ले सकती हूँ कि ठीक है, if I take GDP on the x-axis in a range 0 to 10,000 per capita GDP, कितना कंट्रीज का है, here I can take frequency। सपोज देर आर 5 कंट्रीज जिनका जीडीपी 0 to 10,000 आता है, जीडीपी पर कैपिटा मतलब जीडीपी पर पर्सन। जीडीपी पर कैपिटा का मीनिंग हो जाता है जीडीपी ऑफ द इकोनॉमी, इनकम ऑफ द इकोनॉमी डिवाइडेड बाय द नंबर ऑफ पीपल इन द इकोनॉमी। सो मैंने जीडीपी पर कैपिटा निकाला है, एंड आई फाइंड आउट कि हाउ मेनी कंट्रीज हैव जीडीपी पर कैपिटा बिटवीन 0 to 10,000। देन हाउ मेनी हैव बिटवीन 10 to 20,000, उसका फ्रीक्वेंसी निकाल लिया। Then how many have between 20 to 30,000? Uska frequency I find out, and so on and so forth. So this will be a histogram that I have made. Is it clear? ये बात समझ में आती है आपको? So when we go ahead and when we give data in this form, जब हम डेटा को ऐसे बताते हैं, ग्राफिकली रिप्रेजेंट कर रहे हैं, डेटा का मीन मीडियन मोड निकाल रहे हैं, डेटा की कुछ पैटर्न्स को आइडेंटिफाई कर रहे हैं, then this is basically going ahead and talking about descriptive data set। इसको हम डिस्क्रिप्टिव डेटा सेट बोलते हैं। वी गो अहेड एंड वी कॉल दिस एज डिस्क्रिप्टिव डेटा सेट। ये बात समझ में आती है? इज दिस पार्ट वेरी क्लियर? ओके, दिस इज इट अबाउट दिस सेक्शन 1.5। today in this section I'm going to talk about statistical inference। स्टैटिस्टिकल इन्फ्रेंस, इसमें आज एक बहुत ही इंटरेस्टिंग बात समझेंगे, पॉपुलेशन वर्सेस सैंपल। Population is a set of all elements of interest। in a particular study। For example, अगर मुझे इंडिया में इनकम जानना है, इफ आई वांट टू नो द इनकम इन इंडिया, एंड आई आस्क ईच एंड एवरी इंडिविजुअल ऑफ कंट्री, so that is population. Sample is a subset of population. So I want to know about the income of people, but मैंने पूरी इंडिया में से 10,000 लोगों को सेलेक्ट किया. I selected 10,000 people and I asked their income. So that is a subset of the population. When I conduct a survey for entire population, मतलब जब मैं हर इंसान से पूछती हूँ, so survey means क्वेश्चन पूछना for entire population, that is called as census. इसको हम सेंसस बोलते हैं. When I conduct survey of a subset of population, मतलब जब मैं सैंपल का सर्वे लेती, that is called as sample survey. So it means if I will ask income for 10,000 people, तो वो sample survey होगा. If I will ask income of everyone in India, तो वो census होगा. That will be census. ठीक है. Now we have something which is known as statistical inference. Statistical inference मतलब when we go ahead and when we use sample to make decision or infer about population. जब मैं population के बारे में सैंपल के बेसिस पे बताती हूँ कोई भी बात, कि उसका एवरेज कितना है, उसकी हाईएस्ट वैल्यू कितनी है, उसकी लोएस्ट वैल्यू कितनी है, दैट इज कॉल्ड एज स्टैटिस्टिकल इन्फ्लुएंस. मतलब सपोज इफ आई सर्वे दीज 10,000 पीपल और इनका एवरेज सैलरी आ गया 40,000, और इसके बेसिस पे मैंने इंटायर इंडिया के बारे में कुछ टिप्पणी दी, कुछ इन्फरेंस दिया, आई गेव सम इन्फरेंस अबाउट द एंटायर पॉपुलेशन बेस्ड ऑन द सैंपल, then that is called as statistical inference. उसी को हम statistical inference बोलते हैं. Is it clear? What is statistical inference? So I'll give you an example. ठीक है. Suppose मेरे पास एक population है and ये population में I have the data of all bulbs manufactured. इनको मैंने कुछ न्यू तरीके से बनाया, यूज्ड सम न्यू फिलामेंट, एंड इनका एवरेज लाइफ मुझे अननोन है कि कितना चलेंगी बल्ब, हाउ मच द बल्ब विल ऑपरेट, आई डोंट नो. बट आउट ऑफ दिस आई टेक अ सैंपल ऑफ 200 बल्ब्स. मैंने इसमें से 200 बल्ब का सैंपल लिया. नाउ फॉर दीज 200 बल्ब आई फाइंड आउट देयर average lifetime and I understand that it is 76 hour per bulb. मुझे पता चलता है कि हर बल्ब 76 आवर्स के लिए चलेगा, राइट. नाउ इफ आई इन्फर समथिंग अबाउट पॉपुलेशन, अगर इस इंफॉर्मेशन के बाद को यूज करके, यूजिंग दिस इंफॉर्मेशन, इफ आई टेल समथिंग अबाउट ऑल बल्ब्स, आई एम यूजिंग द इंफॉर्मेशन ऑफ सैंपल, I am finding some value of the sample and उससे I am telling about the population. उसके basis पे I am telling something about population. Then this is called as statistical inference. इसको हम statistical inference बोलते हैं. So using sample to give conclusion about population. मैं conclusion दे रही हूँ population के बारे में based on the sample. That is basically called as स्टैटिस्टिकल इन्फरेंस। ये बात समझ में? दिस इज बेसिकली कॉल्ड एज स्टैटिस्टिकल इन्फरेंस। ठीक बात है? इज इट क्लियर ऑल ऑफ यू? ओके बेटा, थैंक यू। With 2.1, and इसमें I'm going to talk about summarizing data for categorical variables। आज हम बात करेंगे कि कैटेगरिकल वेरिएबल्स को हम कैसे समराइज कर सकते हैं। हाउ कैन वी समराइज कैटेगरिकल वेरिएबल्स? सबसे पहले, व्हाट इज अ कैटेगरिकल वेरिएबल? कैटेगरिकल वेरिएबल इज नथिंग बट अ क्वालिटेटिव वेरिएबल। व्हाट इज अ क्वालिटेटिव वेरिएबल मैम? क्वालिटेटिव वेरिएबल क्या होता है? क्वालिटेटिव वेरिएबल इज नथिंग जहां पे हम बेसिकली अपने वेरिएबल को किसी न्यूमेरिकल वैल्यू की जगह ऐसे बता पाए जहां पर हमारा डेटा जो है वो नेम हो, लेबल हो, कैटेगरी हो। जैसे फॉर एग्जाम्पल, आई कैन से दैट जेंडर इज अ क्वालिटेटिव वेरिएबल और अ कैटेगरिकल वेरिएबल। Religion is a qualitative variable or a categorical variable. Region is a qualitative variable or a categorical variable. तो ये जो variables होते हैं which are qualitative in nature. अच्छा, sometimes we convert a qualitative variable in numeric values. कभी कभी हम qualitative variable को भी numeric value में बदल सकते हैं। जैसे फॉर एग्जाम्पल मैम कैसे कर सकते हैं? जैसे मैं बोल सकती हूँ कि जेंडर इज 1 इफ मेल, 2 if female, 0 otherwise. So if you are male, you mark 1, female, you mark 2, any other thing you resonate with, आप 0 mark करो. So when we can convert this qualitative variable in quantitative, but it will not be quantitative. इसको maximum हम binary बोल सकते हैं। क्यों मैम? quantitative क्यों नहीं है अगर हमने numbers में लिख दिया? Why is it not quantitative if we have written it in number form? तो ये quantitative क्यों नहीं है मैम? बेटा, it is not quantitative because no mathematical operation can be performed plus number doesn't signify anything. नंबर डजेंट सिग्निफाई एनीथिंग। नंबर कुछ दिखाई नहीं रहा यहाँ पे। अब मैं इसको अगर रिवर्स कर दूं तो इससे कुछ मीनिंग चेंज थोड़ी हो जाएगा। तो नंबर का कोई मीनिंग नहीं है ना। एनी नंबर कैन बी अलॉटेड टू एनी, राइट? नॉर्थ, ईस्ट, वेस्ट, साउथ में मुझे कैटेगराइज करना है। आई कैन गिव नॉर्थ को नंबर 10 या आई कैन गिव नॉर्थ को नंबर 1। डज नॉट मैटर, उस नंबर का कोई मीनिंग ही नहीं है, राइट? सो इट इज स्टिल अ क्वालिटेटिव डेटा सेट, अभी भी एक क्वालिटेटिव डेटा सेट ही है। Now, what I want to go ahead and what I want to do is I want to begin by talking about something which is called as data visualization. अब हम इस बारे में बात करेंगे बेटा कि what is data visualization. Data visualization क्या है? Data visualization is basically a term which is used to describe usage of graphical methods. क्या कर रहे हैं हम? इसमें हम ग्राफ्स बना रहे हैं, ग्राफ डिस्प्लेस बना रहे हैं टू समराइज एंड प्रेजेंट इंफॉर्मेशन अबाउट डेटा सेट। किसी भी डेटा सेट से रिलेटेड किसी भी इंफॉर्मेशन को अगर मुझे समराइज करना है, मुझे समरी देनी है, आई हैव टू प्रेजेंट दैट, मुझे वो किसी को दिखाना है। टुमारो यू विल बी गोइंग एंड वर्किंग एज अ कंसल्टेंट, यू विल बी वर्किंग एज अ डेटा साइंटिस्ट। कल आप किसी कंपनी में नौकरी करोगे तो वहां पर आपको जो भी क्लाइंट डेटा देगा उसको आपको प्रेजेंट करना होगा, उसको विजुअली दिखाना होगा। या यू गो अहेड एंड यू डू अ पीएचडी, तो आप जो रिसर्च करोगे आपको उसको विजुअली अपीलिंग बनाना होगा। या यू बिकम अ टीचर, तो भी आपको प्रेजेंट करना होगा हाउ मेनी स्टूडेंट्स स्कोर्ड हाउ मेनी मार्क्स। सो डेटा विजुअलाइजेशन इज व्हाट? It is a method to describe or summarize and present. You are summarizing and presenting what? Information about data set, किसी भी डेटा सेट से रिलेटेड इंफॉर्मेशन. हाउ? ग्राफिकली. आप किसी भी डेटा सेट से रिलेटेड इंफॉर्मेशन को जब ग्राफिकली दिखाते हो, व्हेन यू प्रेजेंट डेटा ग्राफिकली, तो दैट इज कॉल्ड एज डेटा विजुअलाइजेशन. बेटा, व्हेन यू विल बिकम अ डेटा साइंटिस्ट और अ कंसल्टेंट, तो आप देखोगे कि इस डेटा विजुअलाइजेशन के लिए बहुत सारे टूल्स भी होते हैं. द मोस्ट बेसिक बीइंग एक्सेल, बट देन देयर इज आर, देन देयर इज पाइथन. ये सारे टूल्स हैं, राइट? देन देयर इज many many other tools. हाँ, तो you can also present your data. जैसे Tableau, ये बहुत डिमांड में इन द कंपनीज, राइट? सो व्हेन यू गो अहेड, या मिनी टैब, ठीक है, व्हेन यू गो अहेड एंड व्हेन यू यूज, जब आप डेटा को विजुअलाइज करते हो, ग्राफ्स बनाते हो, दैट इज डेटा विजुअलाइजेशन. ठीक है, चलिए अब हम बात करते हैं व्हाट इज अ फ्रीक्वेंसी डिस्ट्रीब्यूशन. Frequency distribution. But a frequency distribution, basically, it is a tabular summary of data showing number or frequency of observation. I'll explain this. In each of the several non-overlapping categories. In each of the several non-overlapping categories. ठीक है, I will give you an example. बहुत सारे तरीके हैं, ठीक है. जैसे एग्जाम्पल नंबर 1, आई हैव अ डेटा ऑफ 50 स्टूडेंट्स. मेरे पास 50 बच्चों का डेटा है, और उन 50 बच्चों से मैंने पूछा, बेटा, विच ऑफ द सॉफ्ट ड्रिंक डू यू प्रेफर? आप कौन सी सॉफ्ट ड्रिंक पीते हो? द फर्स्ट वन सेट कोका कोला, पेप्सी, डाइट कोक, पेप्सी, कोका कोला, पेप्सी, फैंटा, ऐसे करके स्प्राइट. 50 स्टूडेंट्स गेव मी देयर डेटा. 50 बच्चों ने मुझे बताया कि वो कौन सी सॉफ्ट ड्रिंक पीना पसंद करते हैं. दे वेंट अहेड एंड दे गेव मी देयर डेटा. इस डेटा को आई एम गोइंग टू समराइज दिस. हाउ? बाय मेकिंग अ फ्रीक्वेंसी डिस्ट्रीब्यूशन. मैं इसका एक समरी क्रिएट करूंगी. कैसे? फ्रीक्वेंसी डिस्ट्रीब्यूशन बना के. और ये फ्रीक्वेंसी डिस्ट्रीब्यूशन कैसे बनेगा? हाउ विल आई मेक इट? सो आई एम गोइंग टू गो अहेड एंड आई एम गोइंग टू लिस्ट द नेम and the number of students who have preferred that. किसने कौन सी ड्रिंक को प्रेफर किया? सो कोका कोला कितने स्टूडेंट्स ने बोला कि वो प्रेफर करते हैं? सपोज 10. पेप्सी सपोज 15. माउंटेन ड्यू सपोज 5. स्प्राइट सपोज 10. ऐसे करके आई एम गोइंग टू लिस्ट किस स्टूडेंट ने क्या बताया. When we do this, that means we have gone ahead and we have created a tabular summary. मैंने टेबल में एक समरी दी है. I have created a tabular summary of data. डेटा की tabular summary दी है showing number of observation in each of non-overlapping category. These categories are non-overlapping. कोका कोला, पेप्सी, ड्यू, स्प्राइट, ये non-overlapping categories हैं. एंड आई एम टेलिंग हर एक में कितने लोगों ने कंज्यूम किया. I am telling how much has been consumed by each individual in the different category. So this is called as a frequency distribution. Is this clear? इसको हम बोल देते हैं frequency distribution. Now, from frequency distribution, जब भी हम एक frequency distribution बनाते हैं, उसी से हमारे पास next term आता है, which is called as relative frequency. इसे बोला जाता है relative frequency. मैम, what is relative frequency? Relative frequency is basically frequency divided by the number of observations. फ्रीक्वेंसी डिवाइडेड बाय नंबर ऑफ ऑब्जर्वेशन. अगर आप इसको 100 से मल्टीप्लाई कर दोगे, सो यू विल गेट परसेंटेज फ्रीक्वेंसी डिस्ट्रीब्यूशन. मतलब relative distribution into 100 will give you the answer in percentage. ये आपको आंसर परसेंटेज में दे देगा. Should we do a question on it? इस पे क्वेश्चन कर लेते हैं बेटा. चलिए. You have soft drink and its frequency. बेटा, कोका कोला 19, डाइट कोक 8, स्प्राइट 5, पेप्सी 13 एंड और कोई बताओ, फैंटा 5. टोटल करो, यू विल गेट द आंसर एज 8, 9, 10, 11 and 9, 20 and 33 and 4 and 5. 50 बन रहा है ना? ठीक है. Now we will find a relative frequency. तो relative frequency का, let me just open my calculator. Relative frequency के लिए 19 divided by 50, 0.38. 8 divided by 50, 0.16. 5 divided by 50, 0.10. 13 divided by 50, 0.26. 5 divided by 50, 0.10. ये बात समझ में आती है? So now I have gone ahead and I have given the relative frequency. अब relative frequency को 100 से if I multiply, 38%, 16%, 10%, 26%, 10%, तो ये हो जाती है आपकी percentage frequency. This will be your percentage frequency. Clear? Now the next thing that we have to go ahead and understand, that is basically, sometimes they will also go ahead and ask you how many people purchased Coca-Cola and Pepsi together. तो कुछ नहीं, you add these two, right? How many percentage of the people purchased Diet Coke and Fanta together? 16% plus 10%. ठीक बात है. चलिए. Next, we want to go ahead and we want to talk about a bar chart. अब ये बार चार्ट क्या है? What is a bar chart? A bar chart is a graphical display. फिर से graphical ही है क्योंकि graphical methods में आ रहा है. For depicting categorical data. जो हमारे पास ये कैटेगरिकल डेटा बनाया हमने, इसी को हमें डिपिक्ट करना है. वी हैव टू डिपिक्ट दिस. समराइज्ड इन फ्रीक्वेंसी, रिलेटिव फ्रीक्वेंसी और परसेंटेज फ्रीक्वेंसी. चाहे हम इसके साथ इसको प्लॉट कर दें, इसको प्लॉट कर दें या इसको प्लॉट कर दें. इज इट क्लियर? सो आई विल राइट इट डाउन. देखिए मेरे साथ. अ बार चार्ट इज अ ग्राफिकल display for depicting categorical data summarized in frequency, relative frequency, or percentage frequency distribution. ठीक है, इज इट क्लियर बेटा? चलिए, वी विल गो अहेड एंड वी विल ट्राई टू शो दिस। तो पहले हम फ्रीक्वेंसी के साथ दिखाते हैं, ठीक है। चलिए जी बेटा, वी हैव कोका कोला, देन वी हैव डाइट कोक, देन वी हैव स्प्राइट, देन वी हैव पेप्सी, देन वी हैव फैंटा। ठीक है जी, मैक्सिमम वैल्यू 19 तक जा रही है। सो आई विल प्लॉट विद 20। अच्छा ठीक है, 1 मिनट, हाँ, वील मेक अ बेटर प्लॉट, थोड़ा सा इसको बेटर करते हैं। एंड 2, 4, 6, 8, 10, 12, 14, 16, 18, 20। ठीक है, इज इट क्लियर? जस्ट गिव मी अ मिनट, आई नीड टू पुट दिस ऑन चार्जिंग। चलिए, द फर्स्ट वैल्यू इज फॉर कोका कोला, आई एम टेकिंग 2 का बॉक्स टू रिप्रेजेंट। देर इज नो कंपल्शन यहाँ पे कि कितना हम बॉक्स लेते हैं। एंड देन this represents Coca-Cola and this is 19 frequency था ना। I'll just color it, जितना beautiful we can make we should make it, no compulsion, but that's the whole point ग्राफ बनाने का ना। एक किसी चीज को विजुअली हम प्रेजेंट करते हैं तो सुंदर बनाना चाहिए। अच्छा, so the next thing that we have is 8 and then 5 and then 13. So next is going to be 8, and then 5, and then 13. That means 12 और उसके बीच में। And the last one is for how much? Fanta का 5. So 5. So I will just zoom it out a bit. And 5. ठीक बात है। So Diet Coke, Sprite, Pepsi, Fanta. Diet Coke, Sprite, Pepsi and Fanta. ठीक है, you can also color it. Same color कर लो, represent it by different color, up to you. ठीक है, ओके। एनीवेज, तो ये हमारा हो जाता है बार ग्राफ। दिस इज अवर बार ग्राफ, बार चार्ट। ठीक है, नाउ वी कैन ऑल्सो गो अहेड एंड मेक दिस बार चार्ट को हम वी कैन ऑल्सो रिप्रेजेंट इट इन टर्म्स ऑफ द फ्रीक्वेंसीज, रिलेटिव फ्रीक्वेंसीज। ठीक है, तो कोई प्रॉब्लम नहीं है, रिलेटिव फ्रीक्वेंसी में करोगे तो आपका क्या चेंज आ जाएगा कि दिस विल गो फ्रॉम 0 to 1, because the sum of relative frequency is 1. You notice this? यहाँ पे sum of relative frequency will always be 1. And the sum of percentage frequency will always be 100. ठीक है, तो you can go ahead and you can also show this for relative frequency या percentage frequency, but accordingly आप उसको वो कर सकते हो। बट वेन एवर वी वॉन्ट टू शो थिंग्स इन परसेंटेज टर्म्स, जब हमें परसेंटेज टर्म्स में शो करना होता है, देन वन मोर थिंग विच वी कैन गो अहेड एंड विच वी कैन डू बेसिकली, दैट इज बेसिकली कॉल्ड एज अनदर चार्ट, जिसको हम बोल देते हैं पाई चार्ट। पाई चार्ट इज अनदर मेथड टू शो थिंग्स इन द परसेंटेज टर्म्स। ठीक है, बट मैम अब हम इसको परसेंटेज टर्म्स में कैसे दिखाएंगे? सो लेट मी जस्ट गो अहेड एंड शो यू दैट ऑल्सो। तो जैसे फॉर एग्जाम्पल दिस इज माय सर्कल, ठीक है। नाउ व्हाट वी हैव टू डू इज, आई नो कि कोका कोला जो है दैट इज 38%, ठीक है। बट आई नो दैट फुल एंगल ऑफ माई सर्कल जो होता है दैट इज फुल इज 360 डिग्री। फुल जब हम एक पॉइंट से फुल सर्कल टर्न करते हैं, सो इफ आई टेक द सेंटर ऑफ द सर्कल जिसके बेसिस पे आई मेड इट, इफ आई जस्ट रोटेट थ्रू आउट इट इज 360 डिग्री। सो मैम वी अंडरस्टैंड कि कोका कोला तो 38% एरिया लेना चाहिए, सो 38% ऑफ 360 डिग्री, 38% ऑफ 360 डिग्री। सो इफ आई गो ahead and if I find that, कैसे निकलेगा, बहुत सिंपल है, 0.38 इंटू 360। सो जब आप 0.38 इंटू 360 करोगे दिस विल कम एज 136.8 डिग्री, ठीक है। सिमिलरली 0.16 इंटू 360 डिग्री करोगे यू विल गेट 57.6 डिग्री, ठीक है। सिमिलरली यू कैन गो ahead and find फॉर अदर डिग्रीज, बाकियों का भी निकाल सकते हो, राइट। सो व्हेन वी गो अहेड एंड व्हेन वी डू दिस, तो ये हम लोग पाई चार्ट में कन्वर्ट कर रहे हैं। सो अब 38% हैज टू बी द हाईएस्ट एरिया, सो व्हाट आई विल डू इज कि आई विल स्टार्ट फ्रॉम अ स्ट्रेट लाइन। ध्यान से सुनना, हाँ, इट इज इजी टू अंडरस्टैंड, थोड़ा सा इंटरप्रिटेशन है, यू विल अंडरस्टैंड इट। आई विल स्टार्ट फ्रॉम वन स्ट्रेट लाइन, ये मेरा स्ट्रेट लाइन है। एक बात बताओ बेटा, अगर मैं इसको यहां मेजर करूं, इफ आई पुट लाइक दिस, तो ये 90 डिग्री होता है हमेशा। ऐसे नहीं समझ में आ रहा, सो यू कैन ऑल्सो रिवर्ट इट। टेल मी समथिंग, इफ आई गो ahead and if I do this, so this will be 90 डिग्री। तो ये वाला भी एंगल 90 डिग्री होगा, 90 डिग्री का हाफ। अगर मैं 90 डिग्री का एग्जैक्ट स्प्लिट करूं, इफ आई एग्जैक्टली स्प्लिट इट, तो बेटा ये भी 45 डिग्री हो जाएगा और ये भी 45 डिग्री हो जाएगा। 90 प्लस 45 इज 9 1 10 135, एंड मुझे कितना चाहिए, आई नीड अबाउट 136 डिग्री, मतलब इट विल बी वेरी क्लोज टू दिस, ये वाला लाइन के बहुत क्लोज होगा। सो आई विल ड्रॉ लिटिल मोर बिकॉज आई डोंट हैव अभी वो एंगल प्रोटेक्टर नहीं है मेरे पास, आई डोंट हैव द प्रोटेक्टर विद मी टू मेजर इट, है ना। सो दैट मीन्स ये ऑरेंज लाइन एक परफेक्ट डिपिक्शन रहेगा फॉर 136 डिग्री, दिस इंटायर थिंग, ये जो रहेगा दिस विल बी 136 डिग्री अप्रोक्सीमेटली, अप्रोक्सीमेट इज फाइन। सो आई विल जस्ट शेड दिस एरिया एंड आई विल से कि ये जो एरिया है ना, दिस बेसिकली रिप्रेजेंट्स माई कोका कोला। अब नेक्स्ट देखते हैं। सो नेक्स्ट आई हैव हाउ मच बेटा, नेक्स्ट आई हैव 57 डिग्री। तो अगेन मतलब यू हैव टू डू एन अप्रोक्सीमेशन। तो हमें पता है कि दिस इज ऑल्सो गोइंग टू बी 90 डिग्री, 90 का हाफ विल बी 45 डिग्री, इतना 45 होगा। सो 45 का हाफ जो होता है, अगर मैं 40, ये इतना 45 है, 45 को अगर मैं हाफ हाफ करूंगी दिस विल बी 22 एंड दिस विल बी अप्रोक्सीमेटली 22, राइट। एंड 22 का भी हाफ करूंगी सो दिस विल बी अप्रोक्सीमेटली 11, 45 एंड 11 जो होगा वो अप्रोक्सीमेटली 56 देगा, एंड आई नीड दैट मच ओनली, more or less close to 56 57। so this is how you can go ahead and think in your mind। of course कंप्यूटर इसको easily बना सकता है, but if I have to plot it तो मैं half एरिया कर करके बनाऊंगी। so that means this area that I am plotting, this one, approximately this will be 56 57 degree। no one is asking you to plot exact, we understand कि आपको भी exact नहीं आएगा यहाँ पे, right। so this is approximately your 57 degree, right। and पेप्सी का कितना परसेंटेज था, it was 26% of the market, कोका कोला was 38% of the market, पेप्सी था ना ये, second was पेप्सी होनी ना, sorry, डाइट कोक, डाइट कोक was 57% of the market, this is डाइट कोक, और ये हो जाता है कोका कोला। लाइक दैट यू कैन गो अहेड एंड यू कैन डू इट, ठीक है। अब जैसे फॉर एग्जाम्पल हियर वी नोटिस कि स्प्राइट एंड फैंटा हैव सेम 10% right। so if I find 0.10 into 360, this is 36 डिग्री यहाँ पे, 36 डिग्री यहाँ पे, राइट। सो अकॉर्डिंगली आई हैव टू सी कि इन दोनों को मैं एरिया इक्वल दूं, right? So whatever I give to sprite, I should give same to the last one also. Whatever I give to sprite, I should give same to fant also. मुझे same area देना है, तो same area दे देना। तो जितना यहाँ पे बनाओगे उतना ही यहाँ पे बना देना, right? So I am leaving up to you to go ahead and plot it further. इसकी further plotting I am leaving it to you. Clear है? हम्म, चलिए। So I can assume कि you will be able to color it. This one, ये कितना आ रहा था बेटा? This was coming as 26%. So 0.26 into 360 degree. Just find this value. ठीक है, this was 16%. तो 0.26 into 360 degree कितना आएगा? Can you just find that value? 0.26 into 360 degree, about 93.6 आ रहा है। So this is 90। 90 कैसे बनेगा अब यहाँ से? अगर मैं यहाँ से शुरू करूं तो 90 के लिए ये 90 है ना, तो 90 से थोड़ा ज्यादा। आई यू अंडरस्टैंडिंग? 90 के लिए आई हैव टू सी कि ये एग्जैक्टली इसका वर्टिकल रहे। सो अबाउट दिस वन इज गोइंग टू बी योर दैट एरिया, 26% एरिया। ये 16% है, सॉरी, हाँ ये 16% था, दिस वॉज 16%, ये 26% है। एंड देन इसको एग्जैक्टली हाफ स्प्लिट कर देना क्योंकि इक्वल था, सो दिस इज 10% ईच। सो आई होप यू आर क्लियर हाउ डू वी गो एड एंड हाउ डू वी मेक पाई चार्ट। अब इसी पाई चार्ट को वी कैन ऑल्सो गो अहेड, आई थिंक वी विल नॉट, आई विल नॉट हैव इट हियर इन द शेप, बट वी कैन ऑल्सो रिप्रेजेंट अ पाई चार्ट इन 3D डायग्राम। ठीक है, सो एक पाई चार्ट को अगर मुझे 3D डायग्राम में बनाना है, इट मीन्स दैट नाउ आई हैव टू शो इट लाइक अ डिस्क। मुझे उसको एक डिस्क की तरह दिखाना होगा। सो दिस इज, हाँ, एंड नाउ what I will do is like this. Again, I'm not as good as a computer with the drawing. Computer बहुत अच्छा आपको visualization देगा, but I just want to go ahead and show you ये ऐसा दिखेगा, right? So whatever you will, it should look like a 3D graph. Are you understanding this? तो ये आपका एक पाई चार्ट हो जाएगा in a 3D diagram. Whatever, just do some fourth color here. So I think visually आप imagine कर सकते हो that if you look it from a distance, so this will go ahead and it will show you like a, it will look to you like a 3D graph. Of course, all of them have to be different colored. You can imagine it ना, it's like looking like a 3D graph. ठीक है जी, चलिए। सो दिस इज अबाउट पाई चार्ट। सो पाई चार्ट यूजुअली बहुत कम यूज करते हैं हम, दे आर नॉट द बेस्ट वे टू रिप्रेजेंट परसेंटेज फॉर कंपैरिजन। एंड पाई चार्ट से, पाई चार्ट इज जस्ट विजुअली अपीलिंग, विजुअली अच्छा लगता है, बट यूजुअली फॉर कंपैरिजन बार चार्ट बनाना इज ऑलवेज बेटर। तो यही चीज इफ आई वुड हैव डन इन अ बार चार्ट, यू नो, अब इसको ही अगर मैं परसेंटेज कर देती, if I would have converted this in terms of a percentage, so 5, 10, 15, 20, 25, 30, 35, 40, 45, 50 परसेंटेज के में कन्वर्ट कर देते। परसेंटेज करो तो 100 तक जाओगे तो ज्यादा बेटर है, सो जस्ट ड्रैग इट, ओके। just drag till 100. So then this would have been the first one, jitna bhi ye percentage hota. So once we do it in terms of percentage, we show it in terms of percentage, then the comparison becomes easier between the things. जब हम बार चार्ट में परसेंटेज में करते हैं, सच कंपैरिजन बिकम्स easier. So अगर मुझे इसी को दिखाना होता, suppose if I would have had to show this, and I would have shown like this कि the first one is 38%, then it is 16%, then it is 10%, then it is 26%, and then 10%. So the graph would have made more sense for me to compare. ठीक है, comparison is used. Hi, good evening, everyone. So let us go ahead, and today we will discuss the summarizing data for quantitative variable. Summarizing data for quantitative variables. ध्यान से समझना, हाँ। देखो, when I talk about quantitative variable, ये वो वेरिएबल हैं विच कैन बी क्वांटिफाइड. जैसे फॉर एग्जाम्पल, इफ आई आस्क यू हाउ मच मार्क्स यू हैव ऑब्टेन, तो ये एक क्वांटिटेटिव वेरिएबल है. If I go ahead and if I ask you how many hours you drive in a day, ये एक quantitative variable है. If I ask you your height, your weight, ये quantitative variable है, right? So quantitative variable is which can be quantified, which जहाँ पे number का कुछ meaning है. Right. Now, whenever we talk about quantitative variable, तो यहाँ पे भी the first thing that we need to go ahead and learn is how to make a frequency distribution. इसका frequency distribution कैसे बनाते हैं, ये हमारा पहला चीज है जो हमें सीखना है इसमें. How to go ahead and how to make a frequency distribution. एक frequency distribution के लिए the first thing which we need to go ahead and which we need to understand is the number of classes. How to find the number of classes. ठीक है. Now क्लास बनाने के लिए दे आर, सो व्हाट इज अ क्लास, पहले तो मैम ये बताएंगे कि व्हाट इज अ क्लास, right? So see, whenever we have to make a frequency distribution बनाने के लिए, the first step that we have, step 1, वो step 1 रहता है determining the number of overlapping non-overlapping classes. Determining the number of non-overlapping classes. ठीक है. Non-overlapping classes का क्या मीनिंग है? What is the meaning of non-overlapping classes? जैसे फॉर एग्जाम्पल, आई कैन टेल कि मेरा जो डेटा है, इट फर्स्ट क्लास कैन बी 0 to 10, second can be 10 to 20, third can be 20 to 30, fourth can be 30 to 40. तो आई हैव मेड क्लासेस. ठीक है, यहाँ पे मैंने क्लास बना दी है कि पहले में आई विल गो अहेड एंड आई विल गेट डेटा फ्रॉम 10 to 20, दूसरे में आई विल गो अहेड एंड गेट डेटा फ्रॉम 20 to 30, एंड सो ऑन एंड सो फोर्थ. सो आई हैव गॉन अहेड एंड आई हैव गिवन सम क्लासेस यहाँ पे. ठीक है. अब मैम यहाँ तो ओवरलैप लग रहा है. क्या ओवरलैप लग रहा है कि मैम 10 तो यहाँ पे भी आ रहा है और 10 तो यहाँ पे भी आ रहा है. सो ओके, आई वॉन्ट टू गो अहेड एंड आई वॉन्ट टू ऑल्सो हेल्प यू अंडरस्टैंड दिस थिंग. ठीक है, इस चीज को भी हम समझेंगे कि अगर हम 10 दोनों जगह लिखते हैं तो 10 हम कहाँ इंक्लूड करते हैं. वेयर वी गो अहेड एंड वेयर वी इंक्लूड 10, दैट इज ऑल्सो समथिंग विच वी विल गो अहेड एंड वी विल अंडरस्टैंड. बट इससे पहले फर्स्ट ऑफ ऑल वी वॉन्ट टू गो अहेड एंड वी वॉन्ट टू understand what happens if my class is non-overlapping. अगर मेरी class overlap कर ही नहीं रही है, so supposedly I go ahead and I make the first class as say 10 to 14, the second class as say 15 to 19, the third class as say 20 to 24. So ये अभी के लिए मेरी non-overlapping classes हैं. ये मेरी non-overlapping classes हैं. Right? So I can have this इसका क्या इम्प्लीकेशन, आई विल जस्ट एक्सप्लेन यू। 2 मिनट रुक जाओ, अभी बताएंगे, आई विल टेल यू, बट अभी के लिए यहाँ देख रहे हो, यहाँ एवरीथिंग बिटवीन 10 to 14, यहाँ एवरीथिंग बिटवीन 15 to 19, एवरीथिंग बिटवीन 20 to 24। सो फर्स्ट थिंग दैट वी हैव टू डू इज वी हैव टू डिटरमाइन कि ऐसी कितनी क्लासेस डेटा से बन सकती हैं। बेस्ड ऑन द डेटा, हाउ मेनी क्लासेस कैन आई गो अहेड एंड कैन आई मेक, कितनी क्लासेस बनाना ठीक होगा। सो नाउ देयर इज अ रूल ऑफ थंब हियर, यहाँ पे कुछ चीज है जो हमें ध्यान देनी होंगी बिफोर वी कैन गो अहेड एंड मेक द नंबर ऑफ क्लासेस, राइट। सो वी कैन गो अहेड एंड हैव few number of classes, हम कम classes भी कर सकते हैं, and we can go ahead and we can have many classes also। 4-5 क्लासेस में भी पूरा डेटा एक्सप्लेन कर सकते हैं और 10-15 क्लासेस में भी पूरे डेटा को एक्सप्लेन कर सकते हैं। बट द सो हाउ डू वी गो एंड हाउ डू वी डिसाइड, कैसे हम डिसाइड करेंगे कि कितनी क्लासेस होना ठीक होगा। वेल, फॉर दैट वन वी नीड टू गो एंड वी नीड टू सी द वेरिएशन इन द डेटा, राइट। वी नीड टू गो अहेड एंड वी नीड टू सी कि हमारा डेटा कितना वेरी कर रहा है, एंड ऑल्सो वी नीड टू गो अहेड एंड वी नीड टू सी द टोटल नंबर ऑफ डेटा अवेलेबल टू अस, the total number of data available to us। So based on these two things, इन दो चीजों के basis पे we will go ahead and we will make the number of classes। ठीक है। So what will determine how many classes will be there? It will be based on the information that is given to us, कि हमें कितना information दिया गया है। So I'll give you an example। जैसे मेरे पास एक दिया दिया हुआ है कि how many days it takes to audit, कोई भी ऑडिट करने के लिए कितना डेज लगता है। एंड द डेटा गिवन टू मी इज 12 days, 15 days, 20 days, 22 days, 14 days, 15, 27 days, 21, 18, 19, 18, 22, 33, 16, 18, 17, 23, 28 and 13। दिस डेटा इज गिवन टू मी। ठीक है। अब एक बात बताओ, प्लीज ट्राई टू अंडरस्टैंड समथिंग दैट हियर आई अंडरस्टैंड कि आई हैव टू गो ऑल द वे टिल 33। मतलब मेरा जो लास्ट क्लास होना चाहिए, इट शुड बी सच दैट दिस शुड इंक्लूड 33, right? And I have to start in such a way that my starting point includes 12 and 13, right? Now what I need to do? So I need to start one class from 10 or 11 or 12 because that's the smallest number. 12 is the smallest number. तो मैं 10 से शुरू कर सकती हूँ, and my last should be 33 or 34, right? So I need one class here, one class here, one class here, but I need to start from 10 या 11 या 12 क्योंकि मेरा first number 12 है, and I need to go till 34, 30 या 36 क्योंकि last number 33 है, so 33 include करना है, right? That's the first thing। The second thing is, which is very very important, is मैम अब हम number of classes कैसे determine करें? I can very well have a class which goes from 10 to 20, 21 to 30, 31 to 40 and done। 3 क्लासेस में भी मैं खत्म कर सकती हूँ। आई कैन वेरी वेल हैव अ क्लास जो 5-5 का बन सकता है, 10 to 14, 15 to 19, 20 to 24, ऐसा भी हो सकता है। आई कैन हैव 5-5 का क्लास और आई कैन हैव 10-10 का क्लास। देन दैट डिपेंड्स ऑन द फ्रीक्वेंसी of this। So if I go ahead and if I say 31 to 40, तो 31 to 40 में there will be only one observation। And if I say 21 to 30, so 21 to 30 में 1, 2, 3, 4, 5, 6 observations, right? And if I say from 10 to 20, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13 observations. So that means that I am not able to give a very clear understanding from the data, मैं अपने डेटा को वेल समराइज नहीं कर पा रही हूँ, आई एम नॉट एबल टू वेल समराइज माई डेटा। आई डोंट नो 10 to 20 में क्या डिस्टिंग्विशिंग फैक्टर है, राइट? आई डोंट नो 21 to 30 में whether they are on the top end or bottom end. So in this case, then I can go ahead and I can split it further, because हमारी जो नंबर ऑफ ऑब्जर्वेशन है वो सिर्फ 20 ही है, जिसमें से 13 ऑब्जर्वेशन यहाँ पे लाई कर रही हैं। आई एम नॉट एबल टू गो हेड एंड जस्टिफाई थ्रू दिस 10, 20, 20, 21, 30 का इंटरवल, right? So when we have relatively smaller sample, number of sample हमारा small रहता है, we can choose to develop frequency distribution with more classes. तो हम अपनी classes को बढ़ा सकते हैं, हम ज्यादा classes दे सकते हैं, 10 to 15, 15 to 20 ज्यादा classes दे सकते हैं to explain the data more, ताकि मैं अपने data को और ज्यादा समझा पाऊँ, so that I can explain it more. The second thing which is important here is width of the class. Right, width of the class. So I want to have number of classes, but एक class कितना width का हो, that is what is important, right? As a general guideline, usually you will notice that we will keep same width for all classes. एक general guideline है that, if I have a width of this, से यहाँ पे 11 to 10 to 20 किया, 21 to 30 किया, so usually you will notice that we will keep the same, ये भी 11 ही होना चाहिए, हाँ, we usually keep the same width for all classes, right? जैसे यहाँ पे if I kept 0 to 10, 10 to 20 width is same. ऐसे अगर मैंने 10 to 14 किया तो मैंने 15 to 19 किया, width is same, right? So if you include यहाँ पे 10, 11, 12, 13, 14 5 numbers आ रहे हैं, 15, 16, 17, 18, 19 5 numbers आ रहे हैं, the width is the same, right? So now क्योंकि width हर class का same रहना है as a general rule, so now we go ahead and we have to think कि क्या width रहना चाहिए, right? As a rule, width हम कितनी रख सकते हैं? What is the width that we can go ahead and we can keep? We can go ahead and we can use a rule that the class width can be largest value minus smallest value upon the number of classes. जैसे यहाँ पर the largest value is 33, right? The smallest value is 12. And suppose I want to keep only 5 classes. मुझे 5 क्लास रखना है, right? So largest value, this, that means approximately 4 width रहेगा हर interval का. If I want to go ahead and if I want to keep the the size as if I want 5 classes, अगर मुझे 5 classes रखना है और largest value 33 and smallest 12 है, तो 4 के width में I can wrap it up. Are you understanding it? ठीक है, सो दिस इज हाउ यू कैन गो अहेड एंड यू कैन यूज द फॉर्मूला, ठीक है? आप इसको अपने कन्वीनियंस के अकॉर्डिंग आप इसको अप्रोक्सीमेट को मतलब डेसिमल को अप्रोक्सीमेट कर सकते हो, राइट? सो हियर इफ यू सॉल्व यू विल गेट द आंसर एज 4.2, ठीक है? सो देयरफॉर यू कैन जस्ट राउंड अप एंड यू कैन यूज अ विड्थ ऑफ 5 ईच ऑल्सो एंड यू कैन यूज अ विड्थ ऑफ 4 ईच ऑल्सो, दोनों ही यूज कर सकते हो, यू कैन यूज बोथ. तो अगर 5 ईच करोगे तो कैसा रहेगा? हाउ विल 5 ईच एक्चुअली गो अहेड एंड लुक? सो इफ आई कीप अ विड्थ ऑफ 5 ईच, तो जैसे अभी देखा था 10 to 14, 15 to 19, 20 to 24. And if I keep a width of 4 each, so 11 to 14, 15 to 18, 19 to whatever, just add 23, ठीक है? So what width you keep, कितना width आप रखो, whether you keep a width of 5 या whether you keep a width of 4, ये किस चीज पे डिपेंड करेगा? use your formula, largest value minus smallest value upon number of classes, इस फॉर्मूला को यूज करो एंड फॉर्मूला को यूज करने के बाद you approximate based on your own convenience. Is it clear? ये बात समझ में आती है? So in practice, the number of classes and class width are also decided by trial and error method. हाँ, थोड़ा सा ट्रायल एंड एरर आप यूज कर सकते हो, एंड यू कैन जस्ट गो अहेड एंड थिंक कि मेरे को कितना विड्थ रखना है। ओके, ठीक है। द नेक्स्ट इज क्लास लिमिट, डिसाइडिंग क्लास लिमिट। सो व्हेन वी थिंक अबाउट डिसाइडिंग क्लास लिमिट, जब हम ये सोचते हैं कि हमें क्लास लिमिट क्या रखनी है, क्लास लिमिट मस्ट बी चोजन सो दैट ईच डेटा बिलोंग्स टू ओनली वन क्लास, राइट? सो अभी के लिए यू चूज क्लास लिमिट so that each data belongs to single class, so that each data belongs to a single class. ठीक है, बात समझ में आ रही है? सो फॉर एग्जाम्पल व्हेन आई कीप द क्लास लिमिट स्टार्टिंग एज 10 एंड आई एंड एट 14, सो जब मैंने ये 10 to 14 रखा, सो आई एक्चुअली गो एंड अंडरस्टैंड कि 14 बिलोंग्स टू दिस क्लास. Similarly, when I go and I keep 15 to 19, so now I know कि 15 belongs to the second class. So each data belongs to one class. ठीक है, is it clear? ये बात समझ में आ गई? Now, if I go ahead and if I use these things together, ठीक है, so I can give you a certain form. ठीक है, जैसे यहां पर अगर मैं वापस आऊं और इस डेटा को अब मैं एक इन तीन चीजों को कंसिडर करते हुए चलूं, right? So I will get, suppose I am making this only 10 to 14 only, हाँ. So हमने ये बनाया, so I get 10 to 14 and the frequency comes out as 4, and then 15 to 19 and the frequency comes as 8, and then 20 to 24 and the frequency comes out as 5, and then 25 to 29 and the frequency comes as 2, and then 30 to 34 and the frequency comes out as 1. So sum है 20. अब एक बार ही हमें ये फ्रीक्वेंसी मिल गए, वंस वी गेट द फ्रीक्वेंसी, तो इसको हम वेरी वेल रिलेटिव फ्रीक्वेंसी में कन्वर्ट कर सकते हैं. सो वी कैन गो ahead and get 4 by 20, 8 by 20, 5 by 20, 2 by 20, 1 by 20. We can convert this in relative frequency. So you will get the answer as 0.20, 0.40, 0.25, 0.10, 0.05. और एक बार ही मेरे पास रिलेटिव फ्रीक्वेंसी आ गई, तो इसको 100 से मल्टीप्लाई करके आई कैन ऑल्सो कन्वर्ट इट इन परसेंटेज फ्रीक्वेंसी. सो 20%, 40%, 25%, 10% एंड 5%. ठीक है, ये बात समझ में आती है? अब हम बात करते हैं समथिंग विच इज नोन एज क्लास मिड पॉइंट की. क्लास मिड पॉइंट कभी कभी जानना जरूरी होता है. क्लास मिड पॉइंट मीन्स हाफ इंटरवल. सो इट इज अपर लिमिट प्लस लोअर लिमिट बाय 2. सो अगर मुझे यहां पर क्लास मिड पॉइंट जानना है, सपोज इसी के केस में, सो द क्लास मिड पॉइंट ऑफ दिस विल बी 10 प्लस 14 बाय 2, 24 बाय 2, 12. अगर मुझे इसका क्लास मिड पॉइंट जानना है तो 15 प्लस 19 बाय 2, सो 9 1 10 14, 34 बाय 2, सो 17. So this is how you can go ahead and you can find the class midpoint. एक बारी दो निकल गए तो you can find everything. You can see कि +5 हो रहा है. So इसका class midpoint will be 22, 27, 32 and you can just find the class midpoints. ठीक है. Relative frequency I've already explained you. Relative frequency is nothing but frequency divided by n. Percentage frequency is relative frequency into 100 and इसके आगे percentage लगा दो. Right? Now I want to go ahead and I want to give you the simplest graphical form, and that is actually known as a dot plot. मैम अब ये डॉट प्लॉट क्या है? बहुत सिंपल है. डॉट प्लॉट मीन्स हर एक से रिलेटेड डॉट्स प्लॉट करना. जैसे फॉर एग्जाम्पल अगर मैं यहाँ देखती हूँ, इफ आई गो बैक एंड आई लुक हियर, in this data, if I look into this data, so beta 10, 15, 20 ऐसे करके आई एम जस्ट राइटिंग, ठीक है। अब देखो यहाँ पे आप 11, 12, सो जस्ट गिव मी अ मिनट, हाँ, इसको थोड़ा सा क्लियर बनाने के लिए। ठीक है, सो यू हैव 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, आगे का आप खुद कर लेना। आई एम जस्ट टीचिंग यू हाउ टू मेक अ डॉट प्लॉट, ठीक है। सो 12 का फ्रीक्वेंसी इज 1, सो 12 के आगे आई विल हैव 1 डॉट। 13 is there, yes, 13 का frequency is 1 dot। 14 is there, 14 का frequency is 1 dot। 15 का frequency is 2, so 15 will have 2 dots, ठीक है। देन अरे 14 का फ्रीक्वेंसी इज ऑल्सो 2 बेटा, तो 14 भी 2 डॉट्स। फिर 16 का फ्रीक्वेंसी 1 है, तो 16 विल हैव 1 डॉट। फिर 17 का फ्रीक्वेंसी नहीं है, सो यू लीव 17। फिर 18 का अच्छा 17 भी है, सॉरी 17 का भी 1 है। फिर 18 का 1, 2, 3, तो 3 डॉट्स। तो फिर 19 का 1 एंड 20 का 1। आर यू अंडरस्टैंडिंग दिस? फिर जो जो नहीं होगा, सपोज 21 का 1 डॉट, 22 का 1 2 डॉट्स, 23 नहीं है तो लीव इट, 24 नहीं है, 25 नहीं है, 26 नहीं है, ओ सॉरी 23 है, सो 21 था ये ना, सो 22, 23, 24 नहीं है, 25 नहीं, यू अंडरस्टूड ना। 25 नहीं है, 26 नहीं है, 27 के आगे 1 होगा, 28 1 and then 33 directly, so 28 and then आगे जाके यहाँ कहीं जहां पे भी 33 आएगा, 33, clear? So when we go ahead and when we just put dots, ठीक है, हॉरिजॉन्टल एक्सेस आपका रेंज दिखा रहा है, हॉरिजॉन्टल एक्सेस इज शोइंग कहाँ से कहाँ तक आप जा रहे हो, यू आर बिगनिंग फ्रॉम 10 and going all the way till 33, and the dots are representing the frequency. So you understand कि 12 का frequency 1 है, 13 का 1 है, 14 का 2 है, 15 का 2 है, 16 का 1 है, and so on and so forth, you're getting the frequency. So this is dot plot. This is very useful जब हमें दो variables को compare करना होता है. So for example, this is the audit done by person 1. अब अगर मेरे को पर्सन 2 का ऑडिट भी दे दिया जाए ना, आई हैव टू कंपेयर कि कौन ज्यादा प्रोडक्टिव है, सो आई कैन जस्ट लुक एट देयर डॉट प्लॉट्स एंड सी कि कितना कम टाइम में दे आर एबल टू डू, हु इज एबल टू डू एट ए लेस टाइम, ठीक है। अब नेक्स्ट चीज जो वी हैव टू गो अहेड एंड अंडरस्टैंड, दैट इज बेसिकली कॉल्ड एज अ हिस्टोग्राम। सो नेक्स्ट थिंग दैट वी गो अहेड एंड हैव बेटा, दैट इज अ हिस्टोग्राम। Histogram. What is a histogram? Histogram basically is displaying this quantitative data, ठीक है। अब इस हिस्टोग्राम में वी कैन ईदर प्लॉट फ्रीक्वेंसी और वी कैन प्लॉट रिलेटिव फ्रीक्वेंसी और वी कैन प्लॉट परसेंटेज फ्रीक्वेंसी, तीनों में से कुछ भी हम हिस्टोग्राम में प्लॉट कर सकते हैं, एनी वन, राइट। हिस्टोग्राम को प्लॉट करने के लिए यहां पे वी विल राइट द वेरिएबल ऑफ इंटरेस्ट एंड यहां पे वी विल राइट द फ्रीक्वेंसी, राइट। नाउ फॉर हिस्टोग्राम, जैसे वेरिएबल ऑफ इंटरेस्ट यहाँ पे है ऑडिट टाइम, एंड वाई एक्सिस पे आई हैव द फ्रीक्वेंसी, ठीक है। Please go ahead and notice that when we talk about histogram, in histogram, we have to show rectangles. The rectangles should not have any separation between them. When we were making a bar graph, तो ये जो बार ग्राफ था इसमें सेपरेशन वॉज अलाउड क्योंकि इट वॉज क्वालिटेटिव डेटा, मतलब कितना मेल है और कितना फीमेल वर्क कर रहा है एक ऑर्गेनाइजेशन में, मेल एंड फीमेल का डेटा. दिस इज फ्रीक्वेंसी. आई कुड हैव गॉन अहेड एंड आई कुड हैव हैड अ गैप. इसके बीच में मैं गैप अफोर्ड कर सकती हूँ, वी पुट अ गैप. बट हिस्टोग्राम में वी डू नॉट गिव अ गैप. हिस्टोग्राम में जो बार्स होते हैं दे डोंट हैव अ नेचुरल सेपरेशन बिटवीन रेक्टेंगल्स. उसमें रेक्टेंगल्स में हम सेपरेट नहीं करते हैं, right? And therefore what we go ahead and what we do is कि जब हम हिस्टोग्राम बनाते हैं जो हमारा स्पेस होता है हम उसको एलिमिनेट करने का ट्राई करते हैं. वी ट्राई टू एलिमिनेट द स्पेस. Now, in order to go ahead and in order to eliminate the space, जैसे इस केस में if I have to eliminate the space, so I have to remove this gap. ये 14 और 15 का जो gap है, I have to remove this gap. Only then I can create a histogram, right? So in order to go ahead and in order to remove this gap, अगर मुझे इस gap को remove करना है, then I need to go ahead and I need to डू समथिंग अबाउट दिस. ये नंबर सेम आना चाहिए. सो व्हाट आई विल डू इज, ध्यान से सुनना मेरी बात को, आई विल डू लोअर लिमिट माइनस अपर लिमिट. लोअर लिमिट ऑफ नेक्स्ट क्लास, अपर लिमिट ऑफ प्रीवियस क्लास डिवाइडेड बाय 2. ये स्टेप 1 रहेगा मेरा. स्टेप 2, दिस वैल्यू विल बी एडेड in lower limit of previous class, sorry, upper limit of previous class and subtracted from lower limit of the next class. बहुत आसान है, इतना कॉम्प्लिकेटेड नहीं है जितना यहाँ साउंड कर रहा है. तो हम क्या बोल रहे हैं, व्हाट आर वी गोइंग अहेड एंड सेइंग, हम बहुत सिंपल बात बोल रहे हैं कि देखो इस गैप को हटाना है तो ये 15 और 14 का डिफरेंस निकाल लो, उसे 2 से डिवाइड कर लो तो ये आ जाएगा हाफ. इस हाफ को 14 में ऐड कर दो और 15 से सब्ट्रैक्ट कर दो. तो जब हम 14 में ऐड करेंगे तो ये हो जाएगा 14.5 और 15 में से सब्ट्रैक्ट करोगे तो हो जाएगा 15 माइनस हाफ करोगे तो वो भी हो जाएगा 14.5. सिमिलरली जो ये 19 और 20 का गैप है, सो 20 माइनस 19/2 माने हाफ. इस हाफ को इस 19 में ऐड कर दो और 20 में से सब्ट्रैक्ट कर दो ताकि ये क्लास सेम हो जाए. So now when I will be plotting this, so I am going to go ahead and I am going to plot it in a way that मेरा क्लास दिखेगा 10 to 14 ही, नेक्स्ट क्लास 15 to 19 ही है, राइट. नेक्स्ट क्लास मेरा 20 to 24 ही है, राइट. बट द वे दैट आई एम प्लॉटिंग इज दिस. ठीक है, आई डोंट नीड दिस गैप, आई डोंट नीड एनी गैप. तो यू कैन ईदर डायरेक्टली एलिमिनेट द गैप, या तो आप डायरेक्टली गैप के बिना ही दिखा दो, यू डोंट शो द गैप. ऑल्दो आपकी क्लासेस के बीच में एक गैप है बट यू डोंट शो इट. तो आप इस जो भी उसका फ्रीक्वेंसी आता, फ्रीक्वेंसी वाज हाउ मच बेटा, फ्रीक्वेंसी 4 and 8 and 5 and 2 and 1. सो 4 8, यहाँ कहीं 5 होगा, 5 2 1. But this class is 10 to 14. This class is 15 to 19. This class is 20 to 24. This class is 25 to 29. This class is 30 to 34. Although you have eliminated the gap. Okay. मतलब you cannot have gap between the classes. आप वो गैप नहीं कर सकते हो, राइट? द rectangles have to be adjacent to each other, they have to touch each other, right? Unlike a bar chart, जब हम बार चार्ट बना रहे थे, हिस्टोग्राम में it contains no natural separation, ठीक है? दिस इज व्हाट इज द फॉर्मेट यूज्ड। और अगर आपको लग रहा है कि मैम 14 और 15 के बीच तो गैप है, फिर भी हम गैप क्यों नहीं रख रहे हैं, तो उसको हटाने के लिए आप कुछ नहीं, यू विल जस्ट गो हेड एंड उस 14 और 15 के गैप की जगह पे यू विल राइट हियर 14.5, 19.5, समझ रहे हो बात को? यू विल राइट हियर 24.5। तो दैट नेचुरल जो भी वो एलिमिनेट, यू नो वॉट एवर वॉज द डिफरेंस, that has been naturally eliminated. We have eliminated the space between class, ठीक है? Why we want to go ahead and eliminate this space? क्यों हमें eliminate करना है? क्योंकि इसी हिस्टोग्राम से आके हम बहुत कुछ और बनाएंगे। इसी हिस्टोग्राम के सेंटर्स को ज्वाइन करके हम फ्रीक्वेंसीज को प्लॉट करेंगे, हम ओजाइव्स बनाएंगे, हम बहुत कुछ कर सकते हैं। वी कैन मेक अ लॉट ऑफ थिंग्स। बट वो चीजें बनाने के लिए, टू मेक दोज थिंग्स, अभी के लिए वी वांट टू गो अहेड एंड वी वांट टू जस्ट, हम डेटा का स्क्यूनेस चेक कर सकते हैं। वो सब अभी धीरे धीरे यू विल अंडरस्टैंड, वी कैन चेक अ लॉट ऑफ थिंग्स। बट फॉर नाउ व्हाट यू हैव टू गो अहेड एंड व्हाट यू हैव टू डू इज जस्ट अंडरस्टैंड कि व्हेन वी मेक अ हिस्टोग्राम, जब हम एक हिस्टोग्राम बनाते हैं, बाय डिफॉल्ट जब हिस्टोग्राम बनता है, इट डज नॉट हैव गैप। हिस्टोग्राम में गैप नहीं होता है, देयर इज नो गैप इन द हिस्टोग्राम, ठीक है? Now the next thing is that can histogram help me understand different shapes? The answer is yes. When histogram looks like this, beta, अगर histogram ऐसा कुछ दिख रहा है, ठीक है? सो इफ आई ट्राई टू ज्वाइन द मिड पॉइंट्स, अगर मैं इस मिड पॉइंट से कुछ कर्व निकालने की कोशिश करूं, इफ आई ट्राई टू ज्वाइन द मिड पॉइंट्स एंड ड्रॉ अ कर्व, दिस इज स्क्यूड लेफ्टवर्ड्स, इसको बोलते हैं लेफ्ट स्क्यूड, ठीक है? सिमिलरली अगर हिस्टोग्राम ऐसा कुछ दिख रहा है, दिस हिस्टोग्राम लुक्स लाइक दिस, एंड इफ आई ज्वाइन द सेंट मिड पॉइंट्स, then it will be skewed to the right, तो ये rightward skewed है, right? Similarly if my data looks like this, धीरे धीरे you will understand stats, you will understand skewness well. If I join the midpoints, so this data is symmetric, right? Neither it is skewed to the left, neither it is skewed to the right. This data is very well symmetric. जितना area यहाँ है, very well the area looks similar here. It has a symmetry made. So please try to understand that a histogram helps us go ahead and understand, right, what kind of the distribution is. इसलिए बहुत important है। I'll give you an example for each of them, ठीक है? तो जब हम बोलते हैं in the first case, when we talk about the first kind of data, तो first kind of data क्या दिखा रहा है बेटा, कि शुरुआत में फ्रीक्वेंसी बहुत कम है और बाद में फ्रीक्वेंसी बहुत बढ़ गई, वेयर एज दिस इज सेइंग कि शुरुआत में फ्रीक्वेंसी बहुत ज्यादा है और बाद में फ्रीक्वेंसी कम हो गई, देन द फ्रीक्वेंसी ड्रॉप्ड। सो कैन वी से दैट दिस इज लाइक द इनकम ऑफ एनी डेवलपिंग कंट्री, इनकम पर पर्सन, पर कैपिटा? देर आर मेनी पीपल हु हैव लो इनकम, है ना? तो लो इनकम ग्रुप का फ्रीक्वेंसी ज्यादा है, लो इनकम ग्रुप का फ्रीक्वेंसी ज्यादा है, लो इनकम ग्रुप का फ्रीक्वेंसी ज्यादा है, एंड यहाँ पे हाई इनकम ग्रुप आ रहे होंगे और हाई इनकम ग्रुप का फ्रीक्वेंसी इज लेस, हाई इनकम ग्रुप फ्रीक्वेंसी इज लेस, right? So we can go ahead and we can say that this is the income of the people in a developing country, ऐसा बोल सकते हैं, ठीक है? नाउ सिमिलरली सपोज नाउ इफ आई वांट टू थिंक अबाउट दिस, तो अब कहीं और कोई और एग्जांपल सोचने का कोशिश करो कि शुरू में फ्रीक्वेंसी कम है, लेस फ्रीक्वेंसी, and then frequency is more. So can we say that this is the consumption of AC, but वो qualitative data हो जाएगा. So can we go ahead and can we say that this is the marks obtained by IIM students? Marks obtained by IIM students. कम मार्क्स आने का फ्रीक्वेंसी इज लेस बिकॉज दे आर इंटेलिजेंट, बिकॉज they have got admission in IIM, and ज्यादा मार्क्स आने का फ्रीक्वेंसी इज मोर because they are intelligent. Marks obtained by SRCC students. Hoping you guys are intelligent. है ना? तो we can go ahead and say that कि this is the marks obtained by intelligent students. अच्छा, दिस इज सिमेट्रिक, तो जितना यहाँ पे है उतना ही यहाँ पे, दिस इज एन आइडल सिचुएशन. ठीक है, इसके बारे में आराम से डिटेल में वील टॉक अबाउट. इसी का एक और हमारे पास एक और हमारा वर्जन होता है जिसको वी गो एंड वी से एज क्यूमुलेटिव डिस्ट्रीब्यूशन. क्यूमुलेटिव डिस्ट्रीब्यूशन, अब व्हाट इज दिस क्यूमुलेटिव डिस्ट्रीब्यूशन मैम? एज द वर्ड सेज, क्यूमुलेटिव मींस क्यूमुलेट, मींस ऐड. So cumulative distribution वो distribution है in which we go ahead and in which we add the frequencies together. We cumulate them, हम उनको add करते हैं. तो इसमें अब हम क्या कर रहे हैं frequency में कि अब हमने बोला अगर if I go back to this, ये हटा देते हैं बेटा. ठीक है. Now what we are saying is we are saying how many people have scored less than 14. Not scored, sorry, क्या था ये? How many people take to audit less than 14 days में? So 4. अब अगर मैं पूछूं how many take less than 19, तो इन्होंने भी ये these 8 people have also taken less than 19 days. इन्होंने भी 19 से कम दिन लिए हैं, और इन लोगों ने भी 19 से कम ही दिन लिए हैं क्योंकि इन्होंने तो 14 से भी कम लिए हैं. सो इफ आई आस्क हाउ मेनी पीपल हैव टेकन लेस देन 19, these people also have taken less than 19 and these people also have taken less than 19. So माने 8 plus 4 माने 12 लोगों ने, 12 people have taken less than 19. ये बात समझ में आती है? अच्छा, इफ आई आस्क हाउ मेनी पीपल हैव टेकन लेस देन 24, कितने लोगों ने 24 से कम लिया है? सो देन इन सब ने 24 से कम डेज लिए हैं. सो यू विल हैव 4 प्लस 8 प्लस 5. सो 8 9 10 11 12 या 9 प्लस 8 से 17. ठीक है, लेस देन 29, तो ये हो जाता है 19. लेस देन 34, तो ये हो जाता है 20. ये बात समझ में आ रही है? सो दिस इज कॉल्ड एज क्यूमुलेटिव फ्रीक्वेंसी. अच्छा, क्यूमुलेटिव फ्रीक्वेंसी के साथ यू कैन ऑल्सो मेक रिलेटिव क्यूमुलेटिव फ्रीक्वेंसी. जब भी हम क्यूमुलेटिव फ्रीक्वेंसी बनाते हैं उसका रिलेटिव भी कर सकते हैं. सो 4 डिवाइडेड बाई 20, 20 divided by 12 divided by 20, 17 divided by 20, 19 divided by 20, 20 divided by 20. So this will be 0.20, 0.60, 0.85, 0.95 and 1. ठीक है, और इसको परसेंटेज में भी कन्वर्ट कर सकते हो 100 से मल्टीप्लाई करके. 20, 60, 85, 95, 100. है ना? सो यू कैन ऑल्सो हैव रिलेटिव क्यूमुलेटिव फ्रीक्वेंसी डिस्ट्रीब्यूशन, रिलेटिव क्यूमुलेटिव परसेंटेज डिस्ट्रीब्यूशन, रिलेटिव सॉरी क्यूमुलेटिव परसेंटेज फ्रीक्वेंसी डिस्ट्रीब्यूशन, क्यूमुलेटिव फ्रीक्वेंसी डिस्ट्रीब्यूशन, क्यूमुलेटिव रिलेटिव डिस्ट्रीब्यूशन. ये तीनों ही हम बना सकते हैं. क्यूमुलेटिव मींस एडिशन. ये बहुत इंपॉर्टेंट है क्यूमुलेटिव समझना. सो आई होप दैट दिस इज क्लियर टू यू. एक बार इसको अच्छे से मेक अ नोट ऑफ इट एवरीवन. जल्दी से ध्यान से इसको नोट डाउन कर लो. डन? कर लिया जी? चलिए अब मेरे साथ आगे चलते हैं और अब हम बात करते हैं स्टेम एंड लीफ मेथड की। बड़ा ही इंटरेस्टिंग मेथड है स्टेम एंड लीफ डिस्प्ले। स्टेम एंड लीफ डिस्प्ले व्हाट इट डज इज, और इसके लिए वी विल हैव टू रिक्रिएट द डेटा। स्टेम एंड लीफ डिस्प्ले क्या करता है कि वो बेसिकली आपको एक पार्ट इट गिव्स एस स्टेम जैसा वर्ड बोल रहा है, एंड एक पार्ट इट गोज अहेड इट गिव्स एस डिस्प्ले। राइट, तो कैसे काम करेगा? So suppose that you are given number of questions answered by students in an aptitude test। कितने क्वेश्चन बच्चों ने एक एप्टीट्यूड टेस्ट में ठीक से आंसर दिए, एंड यू आर गिवन 112, यू आर गिवन 73, 126, ऐसे करके अलग अलग नंबर ऑफ क्वेश्चंस डिफरेंट स्टूडेंट्स आंसर्ड करेक्टली एक एप्टीट्यूड टेस्ट में। ठीक है। अच्छा, अब हमें क्या करना है कि सपोजिटली देयर वाज वन स्टूडेंट जिसने 69 क्वेश्चंस ठीक से आंसर किए थे, 72 किसी और ने 76, दिस वाज द लोएस्ट वैल्यू। ठीक है। सो अब हम क्या करेंगे, इसको हम स्टेम एंड लीफ में कन्वर्ट करेंगे। जैसे स्टेम मींस दिस वैल्यू, फर्स्ट वैल्यू 6, एंड इसका लीफ हो जाता है 9। फिर स्टेम मींस यहां पे स्टेम हो गया 7, ये वैल्यू, दिस वैल्यू, एंड लीफ हो जाता है 2, 6। आर यू अंडरस्टैंडिंग दिस? स्टेम एंड लीफ का क्या इंप्लीकेशन है? सो दिस इज व्हाट अ स्टेम एंड लीफ मेथड इज। ठीक है। सपोज किसी ने 68 क्वेश्चंस करेक्टली आंसर किए, सो 8 भी आ जाएगा। ठीक है। सपोज किसी ने 73 क्वेश्चंस करेक्टली आंसर किए, तो देन यू विल गेट 3 ऑल्सो। आई यू अंडरस्टैंडिंग? सपोज किसी ने 86 क्वेश्चंस आंसर्स किए करेक्टली, सो 8 बिकम्स द स्टेम, 6 बिकम्स द लीफ। सपोज किसी ने 82 क्वेश्चंस करेक्टली आंसर किए, सो 8 इज द स्टेम, 2 इज द लीफ। राइट, सो दिस इज हाउ स्टेम एंड लीफ मेथड वर्क्स। ठीक है। सो स्टेम एंड लीफ मेथड को हमेशा हमेशा यू पुट इट इन द असेंडिंग ऑर्डर। मतलब 9 पहले मत लिखो, 8 पहले लिखो। राइट, सो यू गो अहेड एंड आई विल जस्ट डिस्प्ले दिस अगेन। सो अगर किसी ने 68 आंसर किया एंड किसी ने 69, यू राइट 8 फर्स्ट एंड 9 हियर। सिमिलरली यू राइट 3 फर्स्ट एंड 6 हियर। यू राइट 2 फर्स्ट एंड 6 हियर, एक असेंडिंग ऑर्डर में। सो वी नो कि फर्स्ट वन ऑफ द स्टूडेंट आंसर्ड 68 क्वेश्चंस करेक्टली, one of the student answered 69 correctly, then 72 correctly, then 73 correctly, then 76 correctly, then 82 correctly, then 86 correctly, and so on and so forth। राइट, तो ये जो होता है विद दिस ऑर्गेनाइजेशन ऑफ डेटा, आपने सॉर्ट करना है। ठीक है। एंड आप एक स्टेम एंड लीफ मेथड दिखा रहे हो, यू आर शोइंग द स्टेम एंड यू आर शोइंग द लीव्स। राइट, नाउ टू फोकस ऑन द शेप। ठीक है, आप इसको एक रेक्टेंगुलर शेप भी दे सकते हो, सो आई विल टेल यू हाउ। बड़ा इंटरेस्टिंग है ये। तो अब देखो, अब मैं क्या करती हूँ। सो यहां पे आई विल गिव एक ऐसा, फिर यहां पे एक ऐसा, फिर यहां पे एक ऐसा। ठीक है। सपोज 9 के साथ वन स्टूडेंट आंसर्ड 91 क्वेश्चंस, 92 क्वेश्चंस, 92 क्वेश्चंस, 92 क्वेश्चंस, 94 क्वेश्चंस, 95 क्वेश्चंस करेक्टली। ठीक है, तो अब हमारे पास एक ऐसा बन जाएगा। इज इट मेकिंग सेंस? अच्छा, नाउ द मोमेंट यू रोटेट इट, अगर मैं इसको थोड़ा सा रोटेट कर दूं, तो देखो कितना इंटरेस्टिंग एस्पेक्ट आ जाता है। सो इफ आई जस्ट रोटेट दिस, तो इजंट दिस दीज स्टूडेंट्स जिन्होंने नंबर ऑफ क्वेश्चंस करेक्टली आंसर्ड इज बिटवीन 60 टू 69, तो ये इंटरवल हो जाता है 60 टू 69 का। aren't these students who have answered correctly between 70 to 79, क्योंकि इनके 72, 73, 76 करेक्ट है, तो 70 to 79। these students have answered between 80 to 89 correctly, 80 to 89। these students have answered between 90 to 99 correctly, so we have made histogram। तो स्टेम एंड लीफ को व्हेन वी पुट अ बॉक्स एंड वी रोटेट इट, जब हम इसके आगे एक बॉक्स बनाते हैं और उसको हम रोटेट कर देते हैं, तो वी गो अहेड एंड वी गेट अ हिस्टोग्राम। इजंट इट? अच्छा, यहाँ पे देयर इज वन थिंग वेरी इंटरेस्टिंग, जिस चीज को मैं आपको थोड़ा सा एक्सप्लेन करना चाहती हूँ, एंड दैट इज दैट व्हेनेवर वी टॉक अबाउट स्टेम एंड लीफ मेथड, अगर हम कभी भी स्टेम एंड लीफ मेथड की बात करते हैं, सो यू हैव टू रिमेंबर दैट अभी तक हिस्टोग्राम या स्टेम एंड लीफ में वी आर ओनली डीलिंग विद डिस्क्रीट डेटा, हम सिर्फ डिस्क्रीट डेटा की बात करें, मतलब हमने डेसिमल्स को इंक्लूड नहीं किया। नंबर ऑफ क्वेश्चंस आंसर्ड करेक्टली या 11 होंगे या 12, 11.5 नहीं हो सकते हैं, ठीक है। नंबर ऑफ डेज टू ऑडिट या 10 होंगे या 11, सो वी आर ओनली वर्किंग विद डिस्क्रीट डेटा। इसलिए ये क्लास इंटरवल परफेक्टली काम करता, 60 to 69, 70 to 79, क्योंकि मुझे पता है 69 एंड 70 के बीच में कोई वैल्यू नहीं हो सकता, 79 एंड 80 के बीच में कोई वैल्यू नहीं हो सकता, या 79 होगा, इधर इट विल बी 79 और 80, there will be no value in between 79 and 80, right? These are discrete values, decimals are not there, right? Acha, what if, ma'am, what if someone has answered 112 questions correctly, then what will become the stem? So again, if I just go back one step, I will go back to my stem and leaf diagram, यही था ना? So ऐसे था, this was my stem and leaf. Now just think about it, that suppose someone has answered 112 क्वेश्चन करेक्टली, तो कोई नहीं, दिस इज 10, दिस इज 11, यहाँ पे 2 लिख दो, सो 112 क्वेश्चन करेक्टली, डजंट मैटर, ठीक है। तो अब हमारे पास 112, 113, 115, 118, जो लिखना है यू कैन गो अहेड एंड राइट इट डाउन। इज इट क्लियर? राइट, सो सपोज समवन इज आंसर्ड, अच्छा, अब व्हाट इफ मैम दिस हैपेंस, ध्यान से देखना, हाँ। व्हाट इफ मैम आई एम गिवन अ डेटा जिसको मेरे को स्टेम एंड लीफ में कन्वर्ट करना है, एंड डेटा सेज 1565, 1852, 1644, 1766 एंड सो ऑन, सो दिस इज अ 4 डिजिट का डेटा जो मुझे दिया हुआ है मैम। नाउ व्हाट डू वी गो अहेड एंड व्हाट डू वी डू? इसको मैं कैसे डील करूं? हाउ डू आई डील विद दिस काइंड ऑफ डेटा? So now what you can go ahead and what you can do is that you can, तो यहाँ पे there is a rule that you can only define leaf with single digit. लीफ को सिंगल डिजिट होना जरूरी है। अ सिंगल डिजिट कैन बी यूज टू डिफाइन ईच लीफ, जो हमारी लीफ बनती है, लीफ, वहां मेरे पास सिर्फ एक ही डिजिट हो सकता है, आई कैन हैव ओनली सिंगल डिजिट, ठीक है। तो अब हमें क्या करना है, कैसे हम करें मैम, क्या हम करें? तो अब हम क्या कर सकते हैं, अब हम बना सकते हैं लीफ का यूनिट, एंड अब हम डाल सकते हैं अप्रोक्सीमेट वैल्यू। बहुत ध्यान से सुनना बेटा, नाउ वी विल मेक लीफ यूनिट एंड राइट अप्रोक्सीमेट वैल्यू, माने 1565 का अप्रोक्सीमेट विल बी 1560, 1852 का अप्रोक्सीमेट विल बी 1850, 1644 का approximate will be 1640. I have to put the last as zero. किसी भी हाल में मुझे लास्ट वाले को जीरो करना है। I will not have any other digit. ठीक है। अब ये होने के बाद अगर ये सब जीरो को मान लेते हैं, तो यहाँ पे आई एम लेफ्ट अप विद 156, 185, 164। अब हम क्या करेंगे, वी विल से 156, 185, 164, समझ रहे हो बात को? Are you understanding this? Of course 185 will come after this, and I will say that my leaf unit is 10, मतलब whatever number you create from here, जो भी नंबर आप यहां से बनाओगे उसको 10 से मल्टीप्लाई करते रहो, so you will get back these approximate values, ठीक है। So this is how you can go ahead and use your step Section 2.4. In this section, we are going to go ahead and talk about summarizing data for two variable using graphical display. समराइजिंग डेटा फॉर टू वेरिएबल यूजिंग ग्राफिकल डिस्प्ले. ठीक है, अब इसमें क्या करना है ना, व्हाट वी वांट टू गो अहेड एंड व्हाट वी वांट टू डू इज, फर्स्ट ऑफ ऑल वी वांट टू टॉक अबाउट अ स्कैटर डायग्राम. इसको स्कैटर ग्राफ भी बोलते हैं, राइट. दिस स्कैटर ग्राफ ये क्या करता है बेटा, ये हेल्प करता है, इट हेल्प्स अस टू अंडरस्टैंड रिलेशनशिप बिटवीन टू वेरिएबल. अगर मुझे दो वेरिएबल के बीच में रिलेशनशिप समझना है तो ये स्कैटर ग्राफ बहुत बढ़िया रहता है. ठीक है, एंड इफ आई पास अ लाइन थ्रू दीज स्कैटर पॉइंट्स, अगर मैं इनके थ्रू एक लाइन पास कर दूं, सो दिस इज कॉल्ड एज अ ट्रेंड लाइन. इसको हम एक ट्रेंड लाइन बोल देते हैं. सो अ स्कैटर ग्राफ, इट इज हेल्पिंग अस अंडरस्टैंड रिलेशनशिप बिटवीन टू वेरिएबल. अगर मुझे दो वेरिएबल्स के बीच में रिलेशनशिप समझना है तो मैं स्कैटर ग्राफ बनाऊंगी, और अगर उसके थ्रू एक लाइन पास कर दूंगी जो एक अप्रोक्सीमेट रिलेशनशिप दे पाए तो वो एक ट्रेंड लाइन होगी. लेट मी गो अहेड एंड लेट मी गिव यू एन एग्जाम्पल टू एक्सप्लेन दिस. ठीक है, सो supposedly we are given a table. ठीक है, और ये टेबल है बिटवीन कितनी एड्स आप देते हो, हाउ मेनी एड्स यू हैव टू गिव, और अकॉर्डिंगली कितना आपका सेल्स हो रहा है. टीवी पे कितनी एड्स दे रहे हो और कितना सेल हो रहा है. सो वीक 1, वीक 2, वीक 3, वीक 4, वीक 5. वीक का जरूरत भी नहीं है, बट आई एम जस्ट राइटिंग वीक 6, 7, 8, 9 and 10. सो बेटा दिस इज द नंबर ऑफ कमर्शियल्स और ये है कॉरेस्पॉन्डिंग सेल्स. अगर आप दो एड्स दोगे यू विल हैव अ सेल ऑफ 50 यूनिट्स या 50,000 कर देते हैं, डिपेंड्स, मैं कुछ भी वेरिएबल ले लो. सपोज 50 रिप्रेजेंट्स द सेल इज इन $100,000 या $100. ठीक है, तो ये 50 $100 में सेल होगा. इफ यू गिव 5 एड्स तो 57. If you give one ad, 41. If you give 3 ad, 54. If you give 4 ad, then also 54. So I must create a space ताकि ये थोड़ा विजिबली समझ में आए. ठीक है, then if you give one ad 38, if you give 5 ad 63, then if you week 8 में you gave 3 ads 48, then you gave 4 ads 59, and then you gave 2 ads 46. तो आप देख रहे होगे, you will be able to notice that here when I increased the number of ads, my sale did not increase, sale नहीं बढ़ा. And here you will see that when I increase the number of ads, sale increase. माने there is a pattern, but that's not very quite complete, ऐसा नहीं है. So this is the thing. Okay, अब इसी को if I have to represent using a scatter diagram, so now what I can do now, इसको एक स्कैटर ग्राफ पे बना देते हैं. ठीक है, तो यहाँ पे हमारा x का वैल्यूज आएगा. सो माय x वैल्यू इज द number of ads I gave. सो 1, 2, 3, 4, 5 तक जा रहा है वैल्यू. हाँ, सो 1, So it can be 1, 2, 3, 4, 5. And when I gave one ad, so once I had 41 ka sale and once I had 38 ka sale, right? So suppose I begin here from 35, 40, 45, 50. 50 से ऊपर कोई वैल्यू है क्या? I have values till 59 ना, तो 55 and 60. ठीक है, क्लियर है ये बात? सो नाउ इफ आई सी वीक 1 में, मतलब वन एड में आई एम गेटिंग, with one ad I'm getting a sale of 38 and with one ad I'm getting the sale of 41. तो 38 means 40 से हल्का सा नीचे and 41 means 40 से little ऊपर, ठीक है, little above. 2 में 46 and 50. So 46 means 45 से little ऊपर and 50 means this. 3 में 54, 48. So 48 means 50 से little नीचे and then the other one was what beta? 54 means 55 से हल्का सा lower. Then 4 में 59, 54 है ना, तो 54 means 55 से हल्का सा नीचे and then the other value 4 से related was 59, that means 60 से हल्का सा lower. Then 50 में it is 63 and 57. So 57 means it is going to be 55 say here and then the other one is what beta? 63. तो 60 के ऊपर somewhere here. ठीक है, so this is called as a scatter plot. इसको मैंने बोल दिया scatter plot. Now what is a line? Trend line. Trend line means a line that approximately tells me what the relationship is. So if I draw a line, because the dots go upward, as I increase x, the dots are also increasing, they're going upward. So my line will be upward sloping. So this is called as a trend line. This is telling me an approximate relationship. So the trend line is telling me that, as you go ahead and as you increase the number of commercial ads, the sales will also increase. क्योंकि upward sloping line है, right? So this is a trend line. ये clear हुई बात को? Is it clear? ठीक है. Then the next thing that we have, that is basically your side by side and stacked bar graph. And stacked bar chart. ठीक है. So now what we can go ahead and we can do. अच्छा, before I do this, just एक चीज मुझे यहाँ पे बतानी है, that when you go ahead and when you see upward trend line, so it clearly means कि there is a positive relationship. So positive relationship basically means that as you increase x, you increase the sales. So this is a positive relationship. Okay. The second one that you can have is where you see a trend line which looks like this. माने you see it's downward sloping. जैसे जैसे x increase हो रहा है, y is falling. So this is a negative relationship. ठीक है. The third one that we have, that is basically like this. Okay, so where you just see some points like this, so you see as x is increasing, y is almost not changing, मतलब there is no apparent relationship, ऐसा कोई relationship है नहीं. ठीक है, या something like this, मतलब x and y के बीच में just कुछ भी, you can very well see negative, positive, like this, like this. You're not able to get कि क्या relationship बनेगा, what kind of relationship will actually exist. You're not able to tell that. ठीक है? Okay. अब now let's go back and let's talk about a side by side bar graph. So a side by side bar chart जो होता है, it is basically displaying multiple bar charts. तो ये कब यूज होता है बेटा? When you have to compare. जब हमें कंपेयर करना है, then we use multiple bar charts together. कैसे होता है ये? Let's see this. So to give you an example, let's say that I have to compare marks of section A students with B students with C students. 3 सेक्शन है मेरे स्कूल में, एक क्लास के, सपोज क्लास 10th के बोर्ड एग्जाम्स. So how many students scored between, say 50 marks का एग्जाम था, 10 to 20. So section A was very intelligent, only one student scored between 10 to 20. Section B में 10 students scored between 10 to 20. और C में 5 students scored between 10 to 20. Then how many scored between 20 to 30? Section A में 12 students scored between 20 to 30. Section B में 20 students scored between 20 to 30. And section C में 3 students scored between 20 to 30. फिर how many scored between 30 to 40? फिर से बनाएंगे 40 to 50. So I am comparing different section. ये section A का कलर है ऑरेंज, ये section B का कलर है ब्लू. ये section C का कलर है येलो. Are you understanding? So here we are able to understand the relationship between marks and sections also. कि as I go, अगर किसी बच्चा कोई section B में है तो वो कितना इंटेलिजेंट है, A में है तो कितना इंटेलिजेंट है, and so on and so forth. Another way in which we can go ahead and we can make a diagram that is basically called as a stacked bar chart. स्टैक बार चार्ट बनाने के लिए we basically go ahead and convert everything in percentage terms. हमें उसको percentage terms में convert करना होगा. So for example, to give you an example, let's say that यहाँ पर I am given a data. ठीक है? So this is the rating and this is the meal price. तो जो खाना 10 से 19 डॉलर के बीच में है, उसमें से कितने की क्वालिटी रेटिंग ए है, कितने की बी है और कितने की सी है. ठीक है? देन दैट फूड विच इज बिटवीन 20 to 29 डॉलर, हाउ मेनी हैव रेटिंग ए, हाउ मेनी हैव बी, हाउ मेनी हैव सी. देन 30 to 39 डॉलर, हाउ मेनी हैव ए, हाउ मेनी हैव बी, हाउ मेनी हैव सी. ऐसे करके आई एम गिवन अ टेबल. ठीक है? And this table I can go ahead and I can show as a bar diagram. ठीक है? As a side by side bar diagram. ठीक है? Now, once I am given this side by side bar diagram, so supposedly यहाँ पर, they tell me कि 42 restaurants का rating A है out of 78. ठीक है? Then suppose someone goes ahead and tells me कि कुछ तो नंबर दिया हुआ है, राइट? दे गो अहेड एंड से दे टेल मी कि द नेक्स्ट वन, सो सपोज टोटल रेस्टोरेंट्स आर 78 रेस्टोरेंट्स. ठीक है? सो दे टेल मी कि 10 to 19 के बीच में 34 have B, ठीक है, 2 have C. यहाँ पे it is 40, 64, 114. Sum is 118. यहाँ पे it is 2, 46, 28. Sum is 76. यहाँ पे it is 0, 6, 22, 40 to $49 के बीच में, and sum is 28. तो if I have to make this, तो ये कैसे रहेगा कि for rating, so I'm going between the my first income is 10 to 19. 10 to 19 में how many have scored rating A? How many have scored rating B? How many have scored rating C? इसको I can go ahead and I can plot. फिर उसके बाद I will go with 20 to 29. फिर से I will go ahead and I will show the same plot. फिर 30 to 39 and so on and so forth. ऐसे करके I can go ahead and I can just show different plots, right? So let's just make this graph. एक बार ये बना लो. 10 to 19 में 42 यहाँ कहीं हो गया, है ना? फिर 34, मतलब आई एम नॉट मेकिंग एग्जैक्ट, यू कैन डू इट, एंड ये 2 हो गया. ठीक है, तो सपोज क्वालिटी रेटिंग ए को आई एम गिविंग कलर ब्लू, फिर क्वालिटी रेटिंग बी को आई एम गिविंग कलर ग्रीन, एंड क्वालिटी रेटिंग सी को आई एम गिविंग कलर लाइट. ठीक है, फिर से यहाँ पे 40, 64, 114, तो 40, 40, 64, 112. 64 will be above this. 40, 42 के आसपास होगा कहीं पे एक्चुअली. 40, it has to be close to this ना. फिर 64 एंड फिर 112. ठीक है, अगेन क्वालिटी रेटिंग ए, फिर बी, एंड सी. ठीक है, सो नाउ व्हाट यू विल डू इज यू विल से कि ये जो इनकम लेवल है दिस इज 20 to 29, ए बी सी रेटिंग, ए बी सी रेटिंग एंड सो ऑन एंड सो, ऐसे करके यू विल मेक. ये बात समझ में आती है. Now I am saying another way to show this is through a star diagram, जिसके लिए we need to convert this in terms of percentage. So percentage में convert करने के लिए ये क्या बनेगा, this divided by this into 100, right? So 42 divided by 78 into 100, तो ये हो जाता है about approximately 53.8%. 34 divided by 78 into 100, this is approximately 43.6%. 2 divided by 78 into 100, this is approximately 2.6%. ठीक है, is it clear? ठीक है, अब ऐसे ही you can go ahead and do for the other one. So this divided by its total into 100. ठीक है, so when you will convert this in percentage, जब आप इसको percentage में convert करोगे, this will be 53.8, ये हो जाएगा 43.6, और ये हो जाएगा 2.6. फिर ये हो जाएगा 33.9, ये हो जाएगा 54.2, और ये हो जाएगा 11.9. ठीक है, फिर ये हो जाएगा 2.6, ये हो जाएगा 60.5 एंड 36.8, राइट. एंड द लास्ट वन दैट यू विल बी हैविंग वो हो जाएगा 0, 6 by 28 एंड 22 by 28. ये आपका परसेंटेज में हो गया. Now once you get this in the percentage terms, एक बार ये आपको ये percentage terms में मिल गया, now you will stack one over the other. तो now you see कि ये भी total 100% है, 100. So now you have got the same height of the final, वो जो total height रहेगा वो हमेशा 100 रहेगा. तो ये भी 100 है, ये भी 100 है, ये भी 100 है, और ये भी 100 है. Are you understanding this? ये मील प्राइस 10 to 19 है, 20 to 29 है, 30 to 39 है, एंड 40 to 49 है. अब फर्स्ट केस में वी हैव 53%, माने इसका हाफ, ऑलमोस्ट उससे थोड़ा ऊपर. देन वी हैव 43% एंड देन 2%। तो ये हो गया क्वालिटी ए। ये वाला एरिया जो होना चाहिए इट शुड बी अप्रोक्सीमेटली 53%। तो 53 कैसे पता चलेगा? टोटल 100 है, 100 का हाफ 50 है, 50 से लिटिल ऊपर। देन द नेक्स्ट वन विल बी क्वालिटी बी, और फिर नेक्स्ट क्वालिटी सी। ऐसे ही फॉर द सेकेंड वन दिस इज 33%, सो समवेयर हियर। 50 का हाफ 25 होता है ना, सो 33 उसके हाफ से ऊपर, देन 54% एंड देन 11%। सो अगेन यू कैन जस्ट कलर इट, ठीक है। ऑफ कोर्स इसके लिए टूल्स हैं जो एग्जैक्ट बॉक्स का परसेंटेज निकाल सकते हैं, बट वी कैन ओनली डू एन अप्रोक्सीमेट गेम। हम सिर्फ अप्रोक्सीमेटली ही बता सकते हैं कि कौन सा कितना है एरिया। फिर थर्ड वाले में दिस इज 2.6%, मतलब ये बहुत कम है, इट्स हियर राइट, 2.6%। उसके बाद इट इज 60.5%, बहुत ज्यादा है। एंड उसके बाद इट इज 36%, तो 60.5, और उसके बाद ये है 36। एंड लास्ट वाले में दिस इज 0 एंड देन 21 एंड 78, तो 0 तो है ही नहीं, सो 21 एंड देन 78। तो व्हाट वी ऑब्जर्व इज कि एज द मील प्राइस इज इंक्रीजिंग, जैसे जैसे मील प्राइस इंक्रीज हो रहा है, वी नोटिस दैट द क्वालिटी इज ऑल्सो इम्प्रूविंग, ठीक है। सो यहाँ पर ये ए जो है इट सपोज इट रिप्रेजेंट्स गुड क्वालिटी, बी रिप्रेजेंट्स वेरी गुड क्वालिटी, एंड कैटेगरी सी रिप्रेजेंट्स एक्सीलेंट क्वालिटी। तो हम बोल रहे हैं कि एज द मील प्राइस इज इंक्रीजिंग, देखो ब्लू वाला थिंग इज कमिंग डाउन, मतलब गुड क्वालिटी इज कमिंग डाउन। और देखो येलो एरिया इज इंक्रीजिंग, कितना इजी हो गया अंडरस्टैंड करना, येलो एरिया इज इंक्रीजिंग एंड येलो वाज एक्सीलेंट क्वालिटी। So as the meal price is increasing, the excellent quality is increasing. जो हमारा excellent quality है, that is actually increasing. This is what it goes ahead and it means. ये बात समझ में आ गई? So stacked bar chart is this, right? So when we talk about stacked bar chart, it is basically used to represent frequencies, but इसमें हम क्या कर रहे हैं फ्रीक्वेंसीज में, ये फ्रीक्वेंसीज को हम परसेंटेज टर्म्स में लिख रहे हैं। इट डज नॉट मीन दैट स्टैक्ड बार चार्ट कैन नॉट बी यूज टू रिप्रेजेंट फ्रीक्वेंसीज डायरेक्टली। हम डायरेक्टली फ्रीक्वेंसी को भी स्टैक्ड बार चार्ट में ऐड कर सकते थे 40, तो फिर फर्स्ट स्टैक्ड बार चार्ट 78 का ही बनता, सेकेंड स्टैक्ड बार चार्ट वुड हैव बीन ऑफ 118। मतलब वेरी वेल आई कुड हैव डन लाइक दिस कि जो पहला स्टैक्ड बार चार्ट है ये 78 का है टोटल, ठीक है, आउट ऑफ विच जो फर्स्ट वाला है 42 है, फिर नेक्स्ट वाला 38 है, एंड देन नेक्स्ट आई कैन वेरी वेल 38 के बाद व्हाट वाज द वैल्यू 34 एंड 2 सॉरी। तो वेरी वेल मैं डायरेक्ट फ्रीक्वेंसी के साथ भी कर सकती हूँ, इन विच केस द स्टैक्ड बार चार्ट का जो हाइट होगा दैट विल डिफर, क्योंकि देन नेक्स्ट स्टैक्ड बार चार्ट का हाइट 118 होगा, फिर 76 होगा, फिर 28 होगा हाइट। सो स्टैक्ड बार चार्ट कैन वेरी वेल बी यूज टू डिस्प्ले फ्रीक्वेंसीज डायरेक्टली ऑल्सो, बट जब हम उसको परसेंटेज फ्रीक्वेंसी में करते हैं, सो वी आर एबल टू इंश्योर दैट दे हैव द सेम हाइट, एंड देयरफॉर कंपैरिजन और बेटर हो जाता है, right? It is easy to analyze and Hi, good morning, everyone. Beta, today we are going to go ahead and begin with the measures of location. Now, all of you would have heard about the measures of central tendency. In that case, what we are going to go ahead and do is
within the measures of central tendency, we will study the measures of location and we will study the measures of variation. So, when I say location, what do I mean? By location, I actually mean that I want to go ahead and I want to talk about mean, median, and mode. And by variation, I mean that I want to talk about standard deviation and I want to talk about variance, right? I will also go ahead and take you through movements and curtices, and I will show you why that is also important. Okay. So to begin with, let us today begin with mean, median, mode. That's the first thing I want to do for the day. So beta, what you should be doing is you should start by understanding what is central tendency. सबसे पहले ये समझो कि central tendency क्या होती है. See, a lot of times we have huge distributions of data, huge amount of data. And we cannot go ahead and we cannot, always talk about the entire data set. ऐसा तो नहीं हो सकता ना कि जब भी आप मेरे से पूछो, okay, what are the marks of the students in your class? I start dictating. The first student scored this much, second this much, third this much, 10th this much. Now, that is very difficult. Similarly, it is very difficult to go ahead and to talk about, the income of every individual in the society. So a lot of times what we have to do is we have to condense huge amount of uncondensed information into a condensed form of information. है ना? And how do I condense the information? By finding out the average, by finding out the median, by finding out the mode. So the purpose of these measures is that there is huge amount of data set and I want to go ahead and I want to condense this data set in one number, right? So let us start by understanding this a bit. So please write down with me the purpose. I will give you some features also which are important of these measures is to condense huge, unwidely set of numerical data into single numerical value which represents entire data set. So I want to represent the entire data set by one representative value. Now, central tendency is used for a lot of purposes, right? So there are three main purposes of using central tendencies. The first purpose that you have is, as I mentioned, so its purpose. The first one is to describe distribution in concise manner. So if I want to go ahead and I want to write the entire distribution in one number, that is where it is going to help me. But suppose now I tell you that I have two sections of students and I want to go ahead and I want to compare these sections as to which section is performing well. What can I do? I can go ahead and I can do something which is known as a comparative study. So I can find out the average marks of the first section, the average marks of the second section, and then I can compare which section is performing well, right? So to compare different distributions also, the the central tendency becomes important. So second one is for comparative study of different distributions. Third, now just imagine, I not only want to go ahead and compare different distributions, I sometimes want to also understand more about the distribution. Like for example, is it right skewed? Is it left skewed? What kind of distribution am I talking about? So for computing various other measures like skewness, like coefficient of variance. So you remember that in economics, we do something which is called risk. You know? Risk is basically understanding how risky a portfolio is. And to find the riskiness of a portfolio, you can clearly find covariance, coefficient of variance, right? So for computing other things also, like for example, to understand how skewed is my data set, for understanding the coefficient of variance, for all those purpose also, this is one thing that I need. So you can just say for computing other statistical measures. Like variance, skewness, etc. Now try and understand. You have to understand that when I have to find the variance, उसके लिए भी मेरे को मीन की जरूरत तो पड़ेगी ही पड़ेगी, right? So central tendency will also become important when I have to go ahead and I have to find the variance or skewness. Even then, in their formulas, I would need mean or I will need median, right? Now, there are some prerequisites that you should have for central tendency. So please write down requisites of a good central tendency. So in mean median mode, what should be the factors that I should be looking for? Or supposedly tomorrow you go ahead and you make your own central tendency. आप एक formula के साथ आ जाओ कि मैम मेरे को लगता है कि central tendency ये एक central tendency हो सकती है. What are things that I will be looking out for in a good central tendency? That is what we are going to discuss. So the first one that we should be looking out for, beta, that it should be rigidly defined. By saying that it should be rigidly defined, what do I mean? I mean that it should be very clear and unambiguous. मतलब ऐसा नहीं होना चाहिए कि अगर आप मुझे बोलो मीन निकालो तो कभी मैं समिशन x by n कर रही हूँ और कभी मैं समिशन x by x कर रही हूँ. ऐसा नहीं होना चाहिए. I should be very clear with what the definition is saying कि कैसे उसको define किया गया है, उसमें बहुत clarity होनी जरूरी है. So it should be rigidly defined. Any good central tendency. The second thing is that it should be easy to understand. So the formula should be such that it does not takes a lot of time to understand, a lot of time to calculate, and at the same time, when I interpret it, it should have some meaning. Just when I interpret mean, I know that it is talking about the average marks of students or average height of students or average income of the society. So I should be able to also interpret the central tendency. But the third one is that it should be based on all observations. This is a good property of central tendency. I will show you that among mean median mode, is this satisfied or not? But abhi ke liye important ye hai that it should be based on all observation. Ye important property hai. The fourth one, but it should be suitable for further mathematical theory. So एक अच्छा सेंट्रल टेंडेंसी वो है जो आगे भी किसी पर्पस में काम आ पाए. जैसे सेंट्रल टेंडेंसी, once you know how to find the mean, you can use mean to go ahead and find the variance. Once you know how to find the mean, you can use mean while hypothesis testing. So a good central tendency is such which is suitable for further mathematical or statistical theory. Fifth, it should be affected as little as possible by fluctuation of sampling. इसका क्या मतलब है? मतलब जैसे जैसे मैं सैंपल को फ्लक्चुएट करूं, एज आई फ्लक्चुएट द सैंपल, it should not be the case that this just keeps fluctuating. So just imagine, suppose beta I have a data set and the last income, I'm finding average income, and one of the income was 100. All incomes were between 60 to 100. Okay. Now all of a sudden I changed the last income to 1000. So beta when you will find the average, अब आप 100 की जगह 1000 ऐड करोगे, your mean will be affected. So as you fluctuate your sample, the central tendency is getting affected. But what we are saying that as part of a good central tendency, your prerequisite is that it should be affected as little by sampling as possible. Okay, come to the sixth one. The sixth one is it should not be affected by extreme values. So beta when I say it should not be affected by extreme values, मतलब extreme values को हम बोलते हैं outliers. So जो भी हमारी extreme values होती है, हमारे outliers होते हैं. Outlier मतलब जो data से बहुत अलग दिखते हैं. Like in one of the class I told you the dot method. और जब हम वो dot method बना रहे थे, तो I showed you that there can be some values to the extreme, है ना? तो उन outliers से हमारी central tendency affect नहीं होनी चाहिए. That's also another property that we have. We will talk about it. Yes, beta, you're right. That fifth, so any central tendency, जो भी हमारे, whatever central tendencies I will teach you, it is not going to follow all six. Okay? So we have to compromise a bit. So that means you're correct that even mean will not follow all six. I will show you which properties mean follows. But as long as they're following most of them, we are okay and we will go ahead with that particular central tendency. Depending on my purpose. ठीक है, तो mean, median, mode का भी अपना अपना purpose है. So depending on purpose, I will go ahead with that particular central tendency. Okay, beta. So now in measures of central tendency, I'm going to go ahead in this sequence. We will talk about mean. In mean, we will also talk about arithmetic mean, geometric mean, and harmonic mean. Then beta, we will talk about median. And at last, we will talk about mode. So this is what I want to go ahead and cover from central tendency. In today's class, let us begin with mean. Okay, beta. तो मीन बहुत ही सिंपल है. हम मीन में जब जनरली बात करते हैं तो हम अरिथमेटिक मीन की बात करते हैं, एएम की बात करते हैं. So beta, mean is pretty simple. What are you doing? You are adding all the observations together and dividing by the number of the observations. So if x1, x2 till xn are your observations, then you can define x bar or arithmetic mean as summation x by n, right? Now, a lot of times you will also be given some frequencies associated with the data. Just for example, what will happen? Like I will say that this is my x and this is my frequency. Just say for example, let's say x is marks. So I can say that x1 marks are scored by F1 students. This I can say 10 marks are scored by 20 students. 12 marks are scored by 13 students, and so on. So I can be given some data of x's, and corresponding to that, I can be given some frequencies here, x1 till xn and f1 till fn. So beta, in this case, your arithmetic mean, this is going to be f1 x1 plus f2 x2 and so on till fn xn upon f1 plus f2 till fn. That is going to be your arithmetic mean. So that's the second formula that we have for mean. So the first one is if you're only given data set. So if you're only given data set, it is pretty simple. All of us are aware of it. So if I'm only given data set like 10, 12, 13, 14, and let's say 20, 25, 27, then beta mean is simple. Mean will be 10 plus 12 plus 13 plus 14 plus 20 plus 25 plus 27 divided by the number of observations. So 1, 2, 3, 4, 5, 6, and 7. That is mean. But if you are given frequency of each data point, then you will have F1 into X1 and divided by the total frequency that you will get from here, summation F. Now, suppose you're given continuous data. I will solve numericals in a while. Let's write down all the formulas. So let's say you're given continuous data. So in that case, what will happen? You're given some class intervals like lower class interval 1 to upper class interval 1, lower class interval 2 to upper, lower to upper, and so on till lower to upper. Lower and upper का क्या मतलब है? जैसे if I say 10 to 20, if I say 20 to 30, and so on. So beta, this becomes my lower and this becomes upper. This becomes lower and this becomes upper, and so on. And you're also given frequencies. So the frequency you're given is F1, F2, F3 till Fn. Now, in order to solve for the mean in the continuous data set, you have two methods. The first method is called the direct method. So what can we do in the direct method? In the direct method, you can step 1, find midpoint of interval. So you can just find the midpoint of the interval. Midpoint will be nothing but lower limit plus upper limit divided by 2. Now that midpoint will act as an X for you. And then you can just find the mean by doing X into F summed up by summation F. Right? Let's take an example. So suppose you're given a data set, beta. Let's again take marks here. So the marks given to you are 0 to 10, 10 to 20, 20 to 30, 30 to 40, 40 to 50, and 50 to 60, 60 to 70. These are the marks given to you. And you're given the number of students here. So the number of students given are 6, 5, 8, 15, 7, 6, and 3. So what did I tell you? What is the direct method? You will find the midpoint and call that as X. So beta midpoint will be lower plus upper divided by 2. So 0 plus 10 is 10 divided by 2 is 5. So you will get 5, 15, 25, 35, 45, 55, and 65. This is your frequency. You will multiply frequency with X. So 5 into 6 will be 30. This will be 75. And keep doing this. This will be 200, 525, 315, 330, and 195. This will be F into X. Just add this together and you will get 1670. So simply your mean will be summation XF by summation F. And when you will do summation F, that means I'm adding this together. So I have got here 50. So this will be 1670 by 50, which will be 33.4 marks. So on an average, the students are scoring 33.4. ठीक है बेटा? ये आपका पहला मेथड हो गया, which is known as the direct method. But now the second method that you have, this is called as the step deviation method. So in the step deviation method, what you can do is you can go ahead and you can find mean by using the formula A plus F summation F into D by summation F. ठीक है? अब अच्छा इसको ना F मत लिखो, then it will be creating confusion for you. Let's write it as H. Now, beta D is the deviation, step deviation. And in order to find step deviation, you start by forming something which is known as assumed mean. So A, this is called as your assumed mean. So we assume some mean to begin with. And then we go ahead and we find deviation from each observation from the assumed mean. And then we divide it by the width of the class interval. So H is the width of class interval. Let us try to do the same question using step deviation and then things will seem easier. So beta, I am taking the same data set that I have. And then we will use the step deviation method. Okay, so now in order to go ahead and use the step deviation method, as I told you, you have to start by first finding the midpoint only. So beta midpoint nikal do. Midpoint will be between 0 to 10, 5, 15, 25, 35, 45, 55 and 65. अब इसमें से एक को assumed mean मानना है. Assumed mean ऐसा रखो जो पूरे ये जो मेरा midpoint का data set है, it's in between. So you know I can take 35 as the assumed mean. There are 3 values above, 3 below. So it acts as an average. मतलब ऐसा लग रहा है कि most probably average 35 marks ही रहे होंगे. So I have taken the average as 35. This is assumed for now. Okay, beta. Then find out D. So what is deviation? X minus A divided by H. So X is 5 minus 35. So minus 30. And the size of the class interval beta is 10. And the gap between 0 to 10 is 10. So beta, this will be 5 minus 35 divided by 10. That means minus 3. ऐसे ही if you solve, you will get minus 2, minus 1, 0, 1, 2 and 3. You can solve this. यहाँ पे भी देख लो. So ये क्या होगा यहाँ पर? This is 65 minus 35, which is 30, divided by the class interval, which is 10. So you will get 3. So now beta, once we have gone ahead and done that, just find F into D. Frequency into this deviation. So minus 3 into 6 is going to give me minus 18, then minus 10, minus 8, 0, 7, 12 and 9. And when you will add this together, you will get minus 8. So this is how I have gone ahead and found out F into D. ठीक है जी, अब formula में लगा दो. So beta, what is my mean? Mean is A plus H summation FD by summation F. So I had assumed my mean to be 35. The width of the class interval, ये H जो है, this is 10. Summation F into D I found out as minus 8. And the sum of the frequency is 50. So when you solve this, you will get exactly the same answer as 33.4. यही same आएगा जो यहाँ पे है ना 33.4. You will get exactly that as your answer. ठीक है? So both methods can be used to find the mean value. Okay, beta, let's take some questions related to mean. So quickly we will do these questions. So write down the number. Beta, stats, if you do these questions that I give you in my assignments, then these are so intensive. I try and cover each type of question. you should be in a good position. So the numbers have frequency, and the frequency is given as x, x plus 2, x minus 3, and x plus 6. The arithmetic mean is given to you as 4.876. You have to find the value of x. Okay, beta. Let's start. So what is given to you? You are given the marks of the student, and the marks are given to you as 3.2, 5.8, 7.9, and 4.5. You are given the frequency, and the frequency is given as x, x plus 2, x minus 3, and x plus 6. So beta, mean already given hai. Mean is given as 4.876. So what will be your f into x? 3.2 into x, 5.8 into x plus 2. Keep finding this. 7.9 into x minus 3. 4.5 into x plus 6. So when you add this together, add kar lo, you will get 21.4x plus 14.9. So understand that summation fx is this. And summation f kya hoga? So x plus x plus x plus x, 4x. 6 plus 2, 8, minus 3, 5. So 4x plus 5. So summation of frequency is 4x plus 5. Summation of fx is this. So beta mean kya hai? Arithmetic mean. It is summation fx by summation x. And this is given to you as 4.876. Just equate kar do isko. So equate this to 21.4x plus 14.9 upon 4x plus 5. This is simple. You just have to find the value of x. So kuch bhi nahi hai. I will leave this up to you, beta. So just do 4.786, 4x plus 5. Can you quickly calculate this and tell me, please? I will also multiply this and check. Quickly, because this is decimals, quickly calculate this. 4.876 into 4. 19.504x plus into 5. 24.38 is equal to 24.1x plus 14.9. Anyone who has done this already? Minus 19.504. 1.896x. So 9.48 divided by 1.896. So I'm getting the x as 5. So your x value will be 5, right? So very simple. Sometimes they will simply give you the AM and they will ask you to find the value of x. Okay, beta, come to the next question. So please write down. It says from the following data set, you should go ahead and you should calculate arithmetic mean. It is given to you that the total number of person in highest group is 435 and none is earning less than 20. So it says that nobody is earning less than 20. The total number of people in the highest group is 435. तो एक बारी समझ लेते हैं क्या data set given है. So beta, you're given the income and you're given the number of person. The income given to you is in this format: below 30, below 40, below 50, below 60, below 70, and then you're given below 80, and 80 and above. And you're given number of people, 16, 36, 61, 76, 87, 95 and 5. It is asking you to find out the mean. बेटा अब इस केस में क्या है कि मेरे को कोई इंटरवल तो दिया नहीं है. So I have to convert this into a class interval. Only then I will be able to solve this. So try and understand this. Below 30 means, okay, I don't know whether it is 0 to 30 or whether it is going to be 20 to 30. But because it is given below 30, and then each subsequent interval is below 40, matlab 30 to 40 raha hoga, 40 to 50 raha hoga. So for solving purpose, I can take the class interval starting from 20. So I can say that this will be 20 to 30. Similarly, it says above 80. So beta again above 80 mein I don't know ki kitna raha hoga, but because each gap stands for 10, for solving purpose I can take it between 80 to 90. So what can I do? So this will be 20 to 30, 30 to 40, 40 to 50 and so on. ऐसे करके आप इन intervals को redefine कर सकते हो. Now look at the second thing. Beta this says that below 30 there are 16 people. So no problem. My CF will be 16. But now it says below 40 there are 36 people. So ye dekho beta. Below 40 there are 36 people, out of which below 30 there are 16 people. तो बेटा 40 से 30 से 40 के बीच में कितने लोग हो गए? 36 minus 16, right? Below 40 you're given 36 and below 30 you're given 16. So between 30 to 40 you will have the gap between the two, 36 minus 16 people. So this is exactly what you will have to follow here. So below 40 minus below 30 will give you between 30 to 40. ऐसे ही बाकियों को निकाल लो. Below 50 61 है और below 40 36 है. तो 40 से 50 के बीच में कितने हो जाएंगे? It will be 61 minus 36, that will be 25. And keep doing this. So 76 minus 61. And then you will have 87 minus 76 and 95 minus 87. This will happen. And now it says above 80 you have 5 people. So okay, no problem. I will write 5. So this is how you can go ahead and formulate the frequency. Now beta, now finding the mean is easy. So you can find the midpoint. 20 से 30 के बीच का midpoint will be 25. Then 35, 45, 55, 65, 75 and 85. ये आपके midpoints हो जाएंगे. And once you have found out these midpoints, then I'm leaving it again. You can just solve this. Just find f into x. So 25 into 16 will be 400. 30 into 20, as we can see, is 700. You can just fill up this entire information. ठीक है. अच्छा, when you will do 85 into 5 na, you will get 435. And that is exactly what this was saying na, that it is given that the total number of people in the highest group is 435 and none is earning less than 20. Actually, this meant this only, that the actually total number nahi, total income. I've written it in the wrong way. Total income of the people in the highest group, that is 435. So that is meeting exactly this. Right? So we also satisfy what they have mentioned there. Right? So again, you can just add this together and you will get 4800. So beta, your mean will be, just add this also together and this will come out as 100. So mean will be 4800 divided by 100. That means it will be 48. That will be the mean. Okay, write down the next question now. So write down that an investor Please do these questions with me only. He buys 1200 worth of shares, right? And during the first 5 months, he bought the shares worth 10, 12, 15, 20, and 24. After 5 months, what is the average price paid for shares? So I'm just comparing. So the question said that the total income of people in the highest group is 435. Highest group is this group, na? People who are earning between 80 to 90. If there are 5 people and each of them has an, the midpoint is 85. So this comes as 435. I'm just checking that this is the same number that was given to me in the question. So it is verified that we are going in the right direction, that the midpoint is in fact 85. Varna, because it said 80 and above, I could have taken this interval from 80 to 100 also. If I would have taken this between 80 to 100, तो यहाँ पे 90 हो जाता, यहाँ पे 435 नहीं बन पाता फिर. So I am assured that the interval, last interval that I have taken of 10 is in fact correct. Because they didn't say that the last interval should be of 10. They just said that this is 80 and above. So this number verifies what is given in the question. Clear? Okay. So now, beta, ये देखो ध्यान से समझना, हाँ, बहुत इंपॉर्टेंट है. ये यहाँ पे लिख लो each month. So an investor buys 1200 worth of shares each month. During the first 5 months, he bought shares 10, 12, 15, 20, and 24. This is the price. After 5 months, what is the average price paid for the share? Now, a lot of times, what students do is that they're just going to add these together. So, क्या करते हैं ना? So, for example, they will do 10 plus 12 plus 15 plus 20 plus 24 and divide this by 5. ये क्योंकि it seems very easy, huh? But ऐसा नहीं करना है. This is not what the question is saying. The question has given you the price. यहाँ पे worth भी लिख लो. This is worth. Because I frame it in my language, sometimes, you have to understand this. So here, beta, you just don't have to add these 5 numbers and divide it by 5. Nah, that is not what it's saying. It is saying that every month you are buying 1200 worth of shares. Total जो खरीद रहे हो ना, cost जो लगा रहे हो वो 1200 है. और share का जो price था वो 10, 12, 15, 20 और 24 था इन 5 महीनों के अंदर. तो आपने एवरेज प्राइस क्या पे किया? तो ध्यान से देखते हैं सॉल्यूशन. सो बेटा मंथ मैं यहां लिख रही हूं, एंड देन आई एम राइटिंग फर्स्ट मंथ, सेकेंड मंथ, थर्ड मंथ, फोर्थ मंथ एंड फिफ्थ मंथ. द प्राइस पर शेयर दैट यू आर पेइंग, हर शेयर के लिए पहले महीने में आपने 10 पे किया, फिर 12, दिस इज व्हाट इट सेज, देन 15, देन 20 एंड देन 24. बट जो आपकी टोटल कॉस्ट थी, टोटल कॉस्ट, तो बेटा ये जो टोटल कॉस्ट है ये कंसिस्टेंट है कि आपने हमेशा 1200 ही स्पेंड किया है. You have always spent 1200. This is consistent. So can you tell me what will be the number of the shares? Bhai, I have spent 1200 and each share costed me 10. So beta, the number of shares I would have bought will be 1200 divided by 10 means 120. Then 1200 divided by 12, 1200 divided by 15, 1200 divided by 20, and 1200 divided by this. So the total number of shares you would have bought would have been the summation of these, that means 410. So the total value that I have spent beta is 6,000. 6,000 रुपए खर्च किए ना इन 5 महीनों में. And total shares I have bought is 410. So average price per share will be 6,000 divided by 410. That means 14.63. Many students over the years I have seen will simply add these 5 values and divide them by 5. No. That is not what you have to do. First, find out now that I have purchased 410 shares. And only then you will be able to go ahead and give the average price of the share. ठीक है जी? Take the next question, beta. So now I'm doing one on missing frequency. So please write down, find the missing frequency and I'm not considering price as X. You could have considered price as X and done also, but it's the same thing only. So अगर मैं price को X लेती, if I would have taken this as X and this as frequency, so I would have done what? Summation XF by summation F. But summation XF ही तो 6,000 ये हो रहा है. So this is X, this is F, this is 1200, this is also 1200, this is also 1200. So if I add that, यही वो ये XF ही तो है. This is already given to me, right? So it's the same thing. Okay. So now you have to go ahead and you have to calculate the missing frequency, and you are given that the mean of the distribution, that is 1.46. This is given to you. So you're given the data set beta that the number of accidents and the number of days are given. So accidents ka data set is 0, 1, 2, 3, 4, and 5. And days are given to you as 46. This is missing 23, 10, and 2 data sets are missing, sorry. So this is also missing and this is also missing, 23, 10, 5, and the sum is given to you as 200. So you need to find these missing frequencies. So let's say beta that I name these missing frequencies as A and B. So what is the formula of mean? Mean is summation F into X by summation F. Now when I go ahead and I find a summation, ये मेरा frequency है, ये मेरा X है. So when I go ahead and I do X into F, what will I get? 46 into 0 is 0. A into 1 is A. This will become 2B. 23 into 3 will be, let's go 25 lena hai, sorry. 25 into 3 will be 75. 10 into 4 will be 40. This will be 25. So summation XF will come down as beta how much? 65 plus 75, which means 140, plus A plus 2B. So how do you find mean? Mean is summation XF, matlab A plus 2B plus 140 upon summation F. So summation F is coming down as 200. So divided by 200. And your mean is given to you as 1.46. So I can just equate this to 1.46. So when I do this, I am going to get A plus 2B plus 140 and 1.46 into 200 kar lo. So you will get 292. So A plus 2B, this will be 292 minus 140. So this will be beta 152. So this becomes your first equation, that A plus 2B will be 152. Now find out the second equation. What is the second equation? The second equation is that the sum of the frequencies is given to you as 200. So beta, this means that 46 plus A plus B plus 25 plus 10 plus 5 is given to me as 200. Just solve this. So when you solve this, you will get A plus B will be coming as 140. ऐसे आ जाएगा. So you have got two equations. This is the first equation and this is the second equation. Two equation, two variable, solve them simultaneously. So from the second equation, I will put it back in the first equation. So beta यहाँ से A आ जाएगा 114 minus B. So 114 minus B plus 2B is equal to 152. So you will get 114 plus B is equal to 152. So B will be 152 minus 114. So B will come down as 38 and A will come as 76. So you are able to go ahead and find the missing frequency. Okay. So now I am going to give you one question. Please try that as homework, and it is also based on missing frequency. So please write down beta. So you're given a class interval, and the class interval is 10 to 20, 20 to 30, 30 to 40, 40 to 50, 50 to 60. You're given two distributions. So for distribution 1, you're given the frequency as 20, 15, 10, X and Y. And for distribution 2 also, you're given the frequency as 4, 8, 4, 2X and Y. Right? You're given that for distribution 1, the mean, that is beta 25.4. And for distribution 2, the mean is 32.5. So find X and Y. I'm giving you the answer also, and I want you to go ahead and verify it. So you will get X as 3 and Y as 2. Just verify this. Okay. Okay. So one last type of question that I want to discuss in mean. So please write down the next question. So you're given that the mean salary paid to 1,000 employees is given to you as 180.40. And after disbursement of salary, you're given that the salary was wrongly entered. Wrong. Huh? So it tells you that there were two values that were wrong. So two incorrect values, which were 297 and 165, right? And the correct salaries that should be there was 197 and 185. So find the correct mean. So again, beta, I have done all possible questions. ऐसे ही करेंगे. Whichever topic I will pick up, चाहे वो probability हो, distributions हो, hypothesis testing हो, I will do one question of each type before I give you an assignment, right? So the commonly asked questions from mean, they are one where you have incorrect value, उसको correct करना, ये वाला question आता है. One kind of question that you get, that is on the missing value. One kind of question that you get, that is on your open intervals like this. And one kind of question that you get is on the finding the frequencies. So only these kind of questions are the questions that can come from mean. Okay, beta. So let us go ahead and find the correct mean. So mean is given to you as 180.40. What is the formula of mean? The formula of mean is summation x by summation n. Summation की जरूरत नहीं है. You can just write n. And this is given to you as 180.40. So summation x by 1000. Beta, this is 180.40. So summation x will become 180,400. That means this is the sum of the 100 incomes that you have. Now, from this sum, I must remove the incorrect values. वो गलत था तो उनको हटाना पड़ेगा, उनको add नहीं करना है. And I must add the new correct entries. So we can say that the correct sum, this will be 180,400 minus incorrect entries plus beta correct entries. So when I do this, what will happen? It will be 180,400 minus जो भी incorrect entries थी and add back the correct entries. So when you do that, you will get 180,320. Now just find the correct mean. So correct mean will be correct summation divided by the number of people. So it will give you 180.32. So the correct mean will now be 180.32. I hope this is clear to you. Achha, now let us go back to the table, to the features that we had written. So if you just go back, beta, the features that I have written, these are the 6 features that I had about the prerequisite of the central tendency. So I am going to go ahead and I am going to check as to for which values this is being satisfied. Is it being satisfied for mean or not? That is what I want to go ahead and I want to check. Let me just take this below. And we will check this for everything. I will check this for median also. I will check this for mode also. That is what we want to do. Okay. So let's start with the first one. Rigidly defined. So is mean rigidly defined? Yes. We could see that there is a fixed formula for mean, summation x by n. So it has a fixed, clear, unambiguous formula and therefore it is rigidly defined. Is it easy to understand? Yes. This is a very simple formula. You don't have to do tons and tons of things. So this is very easy to understand. Is it based on all the observations? Yes. I took into consideration each and every observation. I am doing summation x. So it is based on all the observations. Is it suitable for further mathematical theory? Yes. It is used to calculate it is used to calculate variance, and it is otherwise also very useful, right? To find out how your, even if I have to find out the covariance, or I have to find out the correlations, in a lot of places averages play an important role. So yes. Then it says it should be affected as little as possible by the fluctuation of the sampling, right? And it says it should be affected, not be affected by the extreme values. तो बेटा ये जो दो चीजें हैं, यहां पर मेरा आंसर आ जाता है no. A lot of times, the moment I will change the data set, my mean will be quickly affected. है ना? So for example, here, when I took the first data set, कोई भी एक data set ले लो. Suppose यहाँ पर, if I go ahead and ये जो last वाला मेरा marks था, if instead of 60 to 70, I take the last point as maybe 120 to 150. So if I change the midpoint from 65 to, let's say, 125, ऐसा कुछ कर देते हैं, mean will immediately be affected. So the movement you change your data set, mean is quickly affected. So mean satisfies few of the features of the, of the properties of central deviation, but some of the features are not satisfied by mean also. So from here, you must note down all the demerits of mean. So beta, first, हम already कर चुके हैं, but let's quickly write them down. First, it is affected by extreme values. So when I say it is affected by extreme values, let's take an example. Let's say that you have a company whose, I've taken the average salary as 10,000 per month. Okay. Now, in this average salary, what I had done is the salaries were like this: 8,000, 11,000, 9,000, 12,000. ऐसा कुछ करके मैंने इनका average निकाला था, and on an average I was getting 10,000 per month divided by 4. But now what happened is that within the salaries, I had to include the salary of a very big positioned CEO, and his salary was 1 lakh. The moment I will add this salary, my mean will go ahead and become very high. But still, these 4 people are earning around 10,000 only. But the mean will become very high. So what will happen is that the mean will give distorted picture. It will give me wrong picture. It will show me as if everybody is earning well. But everybody is not earning well. Because of one person, the money of everybody is looking high, although it is not high. That's the first issue with the mean. But the second issue with mean that we have is that it cannot be used in open classes. So for example, if I go ahead and I say, suppose if I say less than 3, and then I give you some classes, 3 to 4, 4 to 7, 7 to 9, kuch classes de do main. And then I say more than 9. So but I cannot find mean if I have these open classes. In that question also, I converted those open classes into closed classes. But directly I cannot find mean for the open classes. Third, mean cannot be used for qualitative data set. So I cannot use mean to find out things like intelligence, honesty, any qualitative data set. I want to point out here, even though I haven't done median with you yet, but I want to point out that it can be used for the purpose of median. Median mein, I can go ahead and I can use it for qualitative data set also. Okay. Just for example, a lot of times you will listen people saying the median IQ, or you will listen people saying the median air quality or the median intelligence. Median can be used for qualitative information, but mean cannot be used. You cannot say on an average people are this much honest. Either they are honest or dishonest. You cannot find average honesty. So mean cannot be used for qualitative data set. Then fourth, mean cannot be used if single observation is missing. So even if a single observation is missing, like for example, if there are, let's say, I have a date, I have 100 students in my class. And now I tell you that 99 ke score I have, but ek ka marks nahi hai mere paas. I don't have the marks of one student. Can you find mean of 100? No, you cannot. Can you find median? I can still try. I can find median, but I cannot find mean. So even if a single data set is missing, mode nikalna to bahut aasan hai. I can still find the highest, the frequency of the, which mark says the highest, what's the mode. But I cannot find the mean in case even if a single observation is missing. Sixth, beta, mean leads to wrong conclusions a lot of times. So when I say wrong conclusions, what do I mean? I mean that imagine that I give you a data set like this. I tell you that these are the marks, and this is student A, and this is student B. And I tell you, this is first test, second test, third test. And I give you that the student scored 55%, he scored 65%, 60%, 60%. He scored 65% and he scored, let's say, 55%. And both of the students on an average have 60% marks. But this may lead to wrong conclusions if you don't know the data it came from. So mean can lead to wrong conclusions unless you know the data. You know the data माने क्या? बेटा हमें नहीं पता ना कि क्या इन दोनों स्टूडेंट्स के जो फर्स्ट, सेकंड और थर्ड टेस्ट थे वो सेम थे भी या नहीं. मे बी फॉर स्टूडेंट ए द फर्स्ट टेस्ट वाज इंग्लिश and for student B the first test was maths. So I cannot just say that on an average both the students are the same, or on an average both have scored 60%. Unless I know the data that they have come from. Maybe the difficulty test of the two tests were very different for the two students. So we cannot just simply say that if the average is the same, the students are the same, right? Seventh, but a mean cannot be determined by inspection or cannot be located graphically. What does this mean? It means that beta, if I make a histogram, then I can clearly check कि किस चीज की वैल्यू, किसकी फ्रीक्वेंसी सबसे हाईएस्ट है, and that will be my mode. So just by looking graphically, I can tell you my mode. Just by looking at the data 20, 22, 23, 24, 25, I can tell you what the mid value is. The third value is the mid value. So by looking at the data, just by inspecting the data, I can tell you the median. So there are your central tendencies, which you can solve only by inspection or only graphically. But for finding the mean, I cannot use these two techniques. I have to find out through the entire formula, and only then I can tell you what my mean will be. So finding mean is not very easy through inspection or graphical methods. It can only be done through the formula. Okay, so beta, with this I cover the topic of mean. Please explain second question from last class. What was the second question, beta? This one? What I had given as homework, are you talking about this? Then which one? This one, just give me a yes or a no. I don't remember what was the second question. This one? Which is the second question? Just tell me. I mean, I don't know which question you're referring to as a doubt. Okay. So, but this is pretty simple. This one, you just have to go ahead and you just have to use the properties of mean, in which the highest value was 435. Okay, let me solve both of them quickly for you. So beta, in this case, this one, you just have to go ahead and find iska midpoint nikal lo. So the midpoint is going to be 15, 25, 35, 45, 55, है ना? Then go ahead and find midpoint into x. So यहाँ पे what is going to happen? It will be 15 into 20. So this will be 300. ऐसे ये 375, 350, 45x and 55x आ जाएगा. ठीक है? So if you add this together, you will get 1025 plus 45x. Sorry, this will be 55y now. Plus 55y. This is what you will get. Now I think so you were already given that the mean is 25.4 for the first series. So it means that when you do summation fx by summation f, you should get 25.4. So summation fx, beta, this is this. This is 1025 plus 45x plus 55y divided by summation f. So summation of this frequency. So 20 plus 10, 30. This is 45 plus x plus y. So divided by 45 plus x plus y. But this is given as 25.4. So इसको solve कर लो. Just solve this. So when you will solve this, you will get an equation of x and y. And that equation will be something like this. I'm just writing the final equation. 19.6x plus 29.6y is equal to 118. ये equation आएगी. This is the equation you will get. ऐसे just do it for the other case also. So यहाँ पे if you add all the frequencies together, beta, you will get 4, 8, 12, 16. So you will get 16 plus 2x plus y. This is the sum of the frequency. इस distribution के लिए भी just find this. Frequency into x. So you will have frequency into x. So 15 into 4 is 60. ऐसे करके just solve this, huh? So this will be 60, 200, 35 into 4 is 140, 90x and 55y. So when you will add this together, na, you will get 400 plus 90x plus 55y. This is what you will get. So now you just have the second equation also. You can go ahead and you can solve this also simultaneously. Okay, beta? So क्या मिलेगा यहाँ से? 400 plus 90x plus 55y divided by summation frequency. So 16 plus 2x plus y should be the second mean, 32.5. So when you will solve this one, then you will get the second equation. So second equation will come out something like this. 25x plus 22.5y is equal to 120. ये second equation आएगी. Beta, two equations, two variables, solve for x and y. That I will leave up to you. So कुछ नहीं करना, बस mean का formula लगाना है and you should be able to get the answer. Now just try it, okay? Just find x and y by solving these two equations simultaneously. Okay, so the second doubt that you had, beta, was in 435 one. Na? Okay, let me go to that one also. So बेटा ये कुछ नहीं कह रहा था, ये कह रहा था कि आपके पास ये डेटा दिया हुआ है. You just have to go ahead and find the mean of this data set. So in order to find the mean, what I did is I just converted this into classes. अब दो चीजें दी हुई हैं. It is saying that nobody is earning less than 20. 20 रुपए से कम nobody is earning. ठीक है? Yes, beta, you can take help of the options. So because nobody is earning less than 20, it means beta जो मेरा यहाँ पे income set शुरू होगा ना, वो यहाँ पे 20 से 30 शुरू होगा. Because nobody earns less than 20. हाँ. अच्छा, below 30 का मतलब कुछ भी हो सकता था. Below 30 could have meant anything below 30. मतलब it could have included income of 15, income of 10, income of 5. But this statement says nobody earns less than 20. So I will start my first group from 20 to 30. So मतलब 20 से 30 के बीच में there are 16 people. Then this says below 40 there are 36 people. So वो लोग जिनकी इनकम 40 से कम है, ऐसे लोग 36 हैं. और जिनकी इनकम 30 से भी कम है, ऐसे लोग 16 हैं. ये भी गिवन है. जिनकी 30 से भी कम है, ऐसे 16 है. सो बेटा बिटवीन 30 to 40 मतलब कितने लोग रहे होंगे, कितने लोग होंगे जिनकी इनकम 36 से 40 के 30 से 40 के बीच में होगी? दैट विल बी 36 minus 16, so that will be 20 people, है ना? So that is what I have done here. I have tried to formulate this, so this will come out as 20. Similarly आगे किया है, below 50 there are 61 people, 50 से कम 61 कमाते हैं और 40 से कम 36. So बेटा बीच में कितने कमाते हैं? Just find the difference between the two. Just keep doing this, you will get this table. अब last part ये बोल रहा था that the highest, the total income of the people is 435 in the highest group. तो बेटा highest group के लिए हमने क्या चेक किया? ये बोल रहा है लास्ट में 80 and over. 80 and over का मतलब हो सकता था वो सारे लोग जिनकी 80 से इनकम ज्यादा है बट हमें अपर लिमिट नहीं पता. 80 से 100 भी हो सकती है, 80 से 120 भी हो सकती है. सो हमने एज्यूम किया कि शायद उनकी इनकम 80 से 90 के बीच में होगी क्योंकि बाकी सारे जो ग्रुप्स थे ना वो 10-10 के बन रहे थे. तो यहाँ पे भी हमने 80 to 90 लिया. जब हमने 80 to 90 लिया, ऐसे 5 लोग थे जिनकी इनकम 80 से 90 के बीच में थी, ये यहाँ पे गिवन है, और हमने मिड पॉइंट लिया 85. सो बेटा 85 into 5 जो आया ना वो आया 435, और यही हमें गिवन था that the total income is 435. That means this is correct. That means I have correctly taken the class to be between 80 to 90. So that was the next trick. The data will be given to you. Yes, beta. You will be given with the data that you need to convert. Bina data ke, it will not happen. Bas. So once I know this data set, once I have formulated this data set, अब तो मीन निकालना आसान है. मिड पॉइंट निकाल लिया, फ्रीक्वेंसी निकाल ली, make summation fx and divided by the total frequency. So that is what we had gone ahead and done. Okay. Okay, beta. Now I will move on to the next concept. So let us begin our class with median today. Median. Beta, what is median? Median is any data set, any number which divides your given data set in exactly 2 equal parts. So please write down, it is positional number which divides given series into 2 equal parts. Exactly 2 equal parts में अगर करे कोई चीज तो वो median है. जैसे for example, but if I say 1, 4, 5, 7, 8. So median will be any number on the third position. क्योंकि there will be 2 numbers below and 2 numbers above. So median will simply be any number on the third position. ऐसे for example, let's say I have the data set 11, 13, randomly take numbers 14, 17, 18, 19, 20. Then beta, this number, if I look at this number, this will be my median. I have exactly 3 numbers below 17 and exactly 3 numbers after 17. So this 17 will act as a median to my data set. But what is the formula for median? मतलब ऐसे तो just by inspection we don't want to do this. So in order to find the formula for any central tendency, we need to do it for 2 cases. The first is called as ungrouped data. So ungrouped data मतलब कि क्या? When my data is just scattered around like this, there are no classes that I have created. So in that case, I can have median depending on whether the number of observations are even or odd. So if my n is odd, then my median will be n plus 1 by 2th term. But whenever you will find median, you must arrange the data in ascending order and then try to find the median. So any observation which divides my data set exactly in two halves is the median. And here I am saying that if my n is odd, then I will find n plus 1th term. That term will be the median. And beta, if you have n as even, then it will be n by 2th term plus n by 2 plus 1th term divided by 2. So depending on whether you have even or odd, these are the two formulas that you will have. Now, beta, if your data set is in fact a grouped data set, then, or in other words, it is a continuous series that you have, then your median will be L plus H by F n by 2 minus C. So beta, L will be the lower limit of median class. H will be the width of median class. F will be the frequency of median class. Right, beta? N will be the total frequency. Okay, beta? And C will be the, so इसको बहुत books CF भी लिखती हैं. This is cumulative frequency of preceding class. Okay, बेटा. तो एक बार जरा एक एग्जाम्पल लेके देख लेते हैं. So यहीं से शुरू करते हैं. देखो that here my n is 5. I have 5 observations. These are already in ascending order, so I don't have to put them in the ascending order. So beta, median will be n plus 1 by 2th observation. So since my n is 5, it will be 5 plus 1 by 2th observation. That means 6 by 2. That means third observation. So my third observation came out to be 5. So that becomes the median. Suppose, let's say that your data set was this: 1, 5, 7, 4, 8, and let's say 15. Something like this was your data set. So beta, first of all, I can see that there are 6 observations. So I have to use the formula of even data set. Secondly, I can see that this is not in ascending order. So I must first put this in the ascending order. So what will I do? I will put this in the ascending order: 1, 4, 5, 7, 8, and 15. Now this is in the ascending order. And now what I will do? I will use the formula that I know for even series, which will be n by 2th observation plus n by 2 plus 1th observation divided by 2. So here, if you can see, I have n as 6. So beta, this will be 6 by 2th observation plus 6 by 2 plus 1th observation divided by 2. So 6 by 2 means 3. That means I am saying this will be third observation plus 6 by 2 is 3. 3 plus 1 is 4. So I will have beta fourth observation divided by 2. So my third observation is 5. My fourth observation is 7 divided by 2. So 12 by 2, that means 6. So median of this data set is 6, right? So median is any number that divides your data set in exactly 2 parts. So if I place a 6 here, then 3 numbers will come here and 3 here. That will be the median of my data set. So it is pretty simple to find the median of ungrouped data set. Now let us try to find it for a grouped data set. So take an example. Suppose I go ahead and So we can have a median which is not present in the data set. Yes, beta. A lot of times, whenever you have even data set, your median will never be present in the data set. That's correct, right? It's a lot of times it will also be a decimal. It should be a number which divides it into two equal parts. That's what the concept is. Okay, so let us go ahead and have the, let's say, age here. And my age can be 0 to 10, 10 to 20, 20 to 30, 30 to 40, 40 to 50, 50 to 60, and 60 to 70. This is my age group that I have taken. Now, let us take some frequencies. I will just explain what is C beta. Just take a minute. It is cumulative frequency. Let me show you how to get that. So now what I will do is, we will take frequency. So frequency is given to you. 8, 12, 10, 8, 3, 2, 7. इतना ही data दिया होगा. And they're asking you, find median. So the first thing that you have to do is find cumulative frequency, CF. This is what this is. Cumulative frequency. So cumulative frequency का क्या मतलब है? You will keep adding the preceding frequencies together. So beta, this will be 8. This will be 12 plus 8. That means 20. This will be 10 plus 12 plus 8. That means it will be 30. So till that level, you add all the preceding frequencies. So 38, then 41, 43, and 50. And so this is what you have got as cumulative frequency. Now, the first thing that you must be doing is you must be finding the median class. देखो हर चीज हमें किसके लिए निकालनी है? Lower limit of the median class, width of the median class, frequency of the median class. तो हर चीज तो median class के लिए निकालनी है ना? So the first thing that I need to do is find the median class. To do that, beta, we know that the sum of frequency will be 50. क्योंकि यहाँ पे 50 आ रहा है ना, तो इन सबको add करके मुझे 50 मिला होगा. Now, in order to find the median class, step 1, you will find n by 2. So beta, ये हो जाएगा 50 by 2. That means 25. ठीक है? Now, what will you do? You will go ahead and you will find where can you find CF just greater than n by 2. Where can you find CF, cumulative frequency, just greater than n by 2? तो ऐसा कहाँ हो रहा है जहां cumulative frequency greater than 25 रही होगी, just greater than 25? तो बेटा ये तो 8 है, ये तो नहीं हो सकता. ये 20 है, ये भी लेस है, ये 30 है, ये करेक्ट है. So you will get this as your median class. Right? So your median class will become as 20 to 30. अब बस फॉर्मूला में लगा दो. So median class हो गई 20 से 30. So 20 से 30 की lower limit हो गई बेटा 20. Width of the median class. तो width मतलब कि lower limit and upper limit का gap. So the gap beta is 10. Frequency of the median class. बेटा median class की जो frequency आई है वो है 10. N, that means total frequency. Total frequency आई है 50. And cumulative frequency of the previous class. Median class से पहले वाले की cumulative frequency. माने cumulative frequency में एक ऊपर वाली लूंगी. So I will take that as 20. So beta, with this, I have got all my values with me. Just put it in the formula. So if I just put this in the formula, I will get 20 plus 10 by 50, not 50, 10, 50 by 2 minus 20. This is what you will get. So if you solve this, you will get 20 plus 5. That means 25. So your median will be 25. So the aim here is to identify the median class. If you can identify the median class, you can just simply go ahead and solve the question. Okay, beta, let us take the next question. Question number 2. So I am saying find the median. And now what I have done is I have written here marks less than. And here I've written 80, 70, 60, 50, 40, 30, 20, and 10. And I've given you the number of students here. So I've given you 100, 90, 80, 60, 32, 20, and then 13, and then 5. These are the number of students that you have. Better check that now the language is changed. So it is saying number of students who have scored less than 80. तो 80 से कम कितने बच्चों के आए हैं? 100 बच्चों के. और 70 से कम कितने बच्चों के आए हैं? 90 के. So बेटा 70 और 80 के बीच में कितने बच्चे रहे होंगे? 10. So now what you have to do is you have to try and change this data set such that you are able to get the class interval from this data set. So again, just think about it. I am saying that there are 5 students who have scored less than 10. And there are 20, there are 13 students who have scored less than 20. So beta 10 से 20 के बीच में कितने बच्चे रहे होंगे? 13 minus 5, that means 8. So there will be 8 students who have scored between 10 to 20 and 0 से 10 के बीच में 5. Similarly, just try and convert it. So when you see that marks less than 30, there are 20 students who have scored less than 30 and there are 13 students who have scored less than 20. तो बच्चे 20 से 30 के बीच में कितने रहे होंगे? 20 minus 13, that means 7. Just convert this entire data set in that aspect. So I will now have 0 to 10, 10 to 20, 20 to 30, 30 to 40, 40 to 50, 50 to 60, 60 to 70, and 70 to 80. Between 0 to 10, I see that there are 5 people. Between 10 to 20, I see that there are 8 people. Between 20 to 30, there are 7 people. And similarly, you can just subtract and keep finding. So, if you see, then less than 40, there are 32 people, and less than 30, there are 20 people. So between them, there will be 12 people. So, इनको जब subtract करते जाओगे ना, you will keep getting how many people are there in that particular class. So by solving it, you will get a data set which looks like this. Beta, you have to practice these questions on the same day, please. This is your data set. Now, understand. Beta, everybody, all 100 students have scored less than 80. So total students to 100 हुए ना. So when you add this frequency together, you should get exactly 100. Because everybody has scored less than 80, all 100 students. So from that 100 only, I'm making this split. So when I add the frequency together, I should get back that 100. Now, we just have to find cumulative frequency. So, ये हो जाएगा 5, 13, 20, 32. बस add कर रहे हैं 60, 80, 90, and 100. अब median निकालो बेटा. So what will be n by 2? N by 2 will be 100 divided by 2. That means 50. Find the median class. Won't the CF be one given above? Yes, beta. That is exactly what the CF is. That is what I have written. 5, 13, 20, 32. Yahi CF hai. Correct. The same thing. Huh? So now just find n by 2. That will be 50. So 50 के लिए कौन सी ऐसी क्लास है such that it has its जो भी हम लोग उसकी frequency check करेंगे, it should be matching according to 50. So I want the cumulative frequency to be greater than exactly n by 2. So find out that class whose cumulative frequency is greater than 50. That will be this class, beta. Its cumulative frequency is greater than 50. So now I have got all values that my median class will be 40 to 50. Sometimes in MCQs, they will directly ask you median class. They won't go beyond that. ठीक है जी? तो अच्छा कभी कभी क्या होता है ना, जैसे मीडियन क्लास बेटा अगर 40 से 50 के बीच में है, इससे मुझे एक आइडिया मिल गया कि जो भी मेरा मीडियन होगा, it must lie between 40 to 50 because वही मेरी मीडियन क्लास है. So supposedly they ask you to find the median and they have given you 4 options: 42, 57, 38, 26. Suppose ऐसे कोई options दिए हैं and they're asking you find the median. So beta, I know that my median class is 40 to 50. That means my median has to lie between 40 to 50. So I can simply eliminate these 3 options and say that the median will be 40. So you can also do this if there is only one option in the median class. Okay. अच्छा, so median class is 40 to 50. So L हो जाएगा 40, lower limit. ठीक है. Frequency median class की हो गई 28. Class की width हो गई 10. और cumulative frequency formula में लेते हैं of the previous class. So previous class की cumulative frequency हो गई 32. Just put this in the formula and you should be able to get the median. So median will be 40 plus 10 by 28, 50 minus 32. Correct, beta. The median will be 46.4. That's the answer to your question. Okay. Now, we are going to go ahead and we are going to take one more question for the median, and I'm going to just tell you how to solve this. Then later you can just try to do it yourself. So let's say, beta, that you're given a question where the median data is not continuous. So for example, you're given, let's say, 92 to 97, 98 to 103, 104 to 100 and, let's say, not 103, let's say 102. 102 to, let's say, 108. ऐसा कुछ data दिया हुआ है आपको. But this data set that is given to you is not continuous. You see that this is 97, then this starts from 98. This is 102, and then this suppose starts from 103. ऐसा कुछ data set दिया हुआ है. So whenever you are given a data set which is not continuous, before you calculate the median or even mean, you must convert this into a continuous data set. How do I convert this into a continuous data set? So what will you do is you will check the gap between these two. So the gap between two is 98 minus 97. That means 1. And you can go ahead and you can just find the average of the gap. That means it is going to be 0.5. That is going to be my average. What you will do is from the upper limit, you're going to just add this, right? And from this lower limit, you can just subtract this. And you can convert this into a continuous data set. So what will happen is your data set will look like this: 92.5 to 97.5, 97.5 to 102.5, something like this, 102.5 to 107.5. Suppose this is 7, and so on. So basically, if you have a discontinuous data set, you must first convert that into a continuous data set before you can go ahead and before you can solve it. That is what is important. Okay? Otherwise, the process is the same. Okay. So just a homework question before I go to mode. Please try and do this. So you're given sales and you're given frequency. You're given sale less than 10, less than 20, 30, 40, 50, 60. And you're given frequency 4, 20, 35, 55, 62, 67. ठीक है, ऐसा दिया हुआ है. The question is find the median, right? And I'm telling you that the answer that you should be getting, please verify, you should get median as 29. That should be your answer. Okay. Now what we will do is we will go back to the characteristics that we had studied yesterday, beta. So if you remember the features that I had studied, the first feature was that it should be rigidly defined. This is what the first feature of median central tendency said. So the question is median rigidly defined? Yes, I have a fixed formula for median, so that is correct. But the second feature was that it should be easy to understand. Is median easy to understand? Yes, the formula is pretty simple. The third feature was beta, it should be based on all observations. Is median based on all observations? No. देखो कैसे all observation पे based नहीं है, क्यों नहीं है? क्योंकि ध्यान से देखो कि ये observation बेटा, ये जो 8 है, अगर इस 8 को मैं 80 भी बना दूं, it does not matter. It is just based on the position. It does not matter what other observations come out to be. Suppose your observation minus 100 भी होती, it does not matter. My median will always be the third position because there are 5 observations. So it is not based on all observations. So we are going to go ahead and say that no, it is not based on all observations. Fourth, beta, is it suitable for further mathematical or statistical theory? So partially. Why partially? Because very rarely you will see median being used further. एक median deviation करके निकालते हैं, but otherwise you will not see median a lot. चाहे variance निकालना हो, चाहे standard deviation निकालना हो, या और कुछ भी hypothesis testing करना हो, most of the time everything is done on mean. A lot is not done on median, so it is not being used too much for the mathematical or statistical theory. Then beta, fifth, is it affected by outliers or sampling? Beta, it is not affected by outliers. It is not affected by outliers. क्यों? क्योंकि exactly this is what I explained you, that when you make this number very extreme also, suppose it's 80,000 भी कर दो, my median will still be 5. It is not being, it does not change by your extreme observations, right? So in fact, this is the best merit of median, that median is a positional average. It is not affected by extreme observation. इसको extreme observation से कोई फर्क नहीं पड़ता. पर disadvantage भी यही है कि वो हर observation को consider ही नहीं करता और सिर्फ कुछ observation को consider करता है. Right? One more thing which I wanted to highlight yesterday, beta, which we did, that median can also be calculated for qualitative data set. है ना? जैसे आप मेरे पास एक डेटा लेके आओ और आप बोलो कि मैम लोग मेरे पास ऐसे, I have 10 students. The first one has low IQ, medium IQ, medium IQ, medium IQ, high IQ, high IQ. ऐसे करके आपने एक डेटा सेट दे दिया मुझे. Now you ask me, ma'am, what is the median of this data set? So I will just calculate observation 1, 2, 3, 4, 5, 6, 7. That means the one here is the median. There are 3 below this and 3 above this. So we can get some idea about the data set that 50% of the students have medium IQ. More, 50% have more than medium, 50% have less than medium. So median can still be used for finding some analysis even on the qualitative data set, which mean cannot be used. Many कह सकती on an average you have medium IQ. Now, I cannot talk about mean that way, but I can still do some analysis, some qualitative analysis using median. Okay, beta. Now, let us go to mode. So when I talk about mode, what is mode? It is the value that occurs more frequently or most frequently in the data set. So जो भी वैल्यू सबसे ज्यादा फ्रीक्वेंटली आ रही होगी उस वैल्यू को हम मोड बोलेंगे. Now, beta, I can only, so there are multiple methods of mode. The first method that I'm going to teach you, I can only apply that method if I have a uni-model data set. So please write down number 1, uni-model data set. What do I mean by uni-model data set, beta? Uni-model means that there is only one observation with the highest frequency. Just an example. Look. So I tell you that I have a data set 1, 2, 3, 4, and 5. And let's say I'm given frequency of each of this. So beta 1 की frequency दी हुई है 13, let's say 62, let's say 40, let's say 37, let's say 28. So we know that 2 occurs maximum number of times. There are 62 times that 2 is coming in the data set. So data set कुछ ऐसा रहा होगा. 1, 1, 1, 1, 1, 1, 13 times आ रहा होगा. फिर 2 आ रहा होगा, 2, 2, 2, 2, 2. ऐसे 2 62 times आ रहा होगा. फिर 3 आ रहा होगा 40 times and so on. So beta, because 2 is occurring the maximum number of times, we know 2 is the mode. But suppose यहाँ पर भी 62 होता, right? Up there are 2 observations with highest frequency. Then I cannot apply the usual way of finding mode. फिर मैं नहीं बोल सकती कि 2 and 4 are both mode of the class. No, I can't do that. So I can only say by looking into the data that that is the mode if it is a uni-model data set. If there is only one observation with highest frequency, only then I can apply that. Okay. So abhi ke liye, the first thing that I am starting with, I am only working first of all with uni-model data sets, beta. So let us take the formula now. So if you have grouped or continuous data set, ungrouped का तो simple है, जिसकी highest frequency होगी वो mode हो गया. But if you have grouped data set, then beta mode will be L plus H F1 minus F0 upon F1 minus F0 plus F1 minus F2. This is the formula of mode. Let me write down all the meaning. So L is your lower class. Beta H is the width. F1 is the frequency of model class. F0 is the frequency of preceding class. And F2 is the frequency of succeeding class. Let us take an example. So supposedly, let's say that you have age given to you. And you have some frequency also given. So age is given as 0 to 10, 10 to 20, 20 to 30, 30 to 40, 40 to 50, and 50 to 60. And beta, you're given some frequencies also. 8, 12, 10, 8, 3, and 2. सबसे पहले you will identify the model class. Model class मतलब कौन सी वो class है जिसकी highest frequency है. Which class has highest frequency? So as I can see, This is the class that has highest frequency. So this is called my model class. The frequency is 12 here, highest. Now just go ahead and try to apply the formula on this. So what will be my formula? L plus H F1 minus F0 upon F1 minus F0 plus F1 minus F2. So L, the lower one, is going to be 10. H, that means the width of the class, but this will be 10. F1 means the frequency of this class. This will be 12. F0 is the frequency of the preceding class. That means 8 upon 12 minus 8 plus 12 minus 10. So beta, this will come out as 10 plus 10, 4 upon 4 plus 2. So just solve this. You will get the answer as 16.67. So this is going to be the mod of your data set. Class. We talked about mean, median, mode. Then we talked about geometric mean, harmonic mean. Today we are going to go ahead and we are going to talk about what are the measures of dispersion. Then I will take you through skewness and kurtosis. There are four main measures of dispersion that we have: range, quartile deviation, mean deviation, and standard deviation. Let's talk about the first one. This is called range. When I talk about range, range is the gap between upper and lower limit. So let's say that I have a data set. And suppose I just go ahead and sort this data in ascending order. So, initially my data was 4, 8, 3, 2, 10. I sort it in the ascending order and I get 2, 3, 4, 8, 10. The upper limit of my data set is 10. The lower limit of my data set is 2. And the range is 8. So the highest minus the lowest value of the data set, that is called range of the data. It helps us to understand what's the variation in between, what's the highest most value and the lowest most value. The second thing that you should understand is called quartile deviation. Quartile deviation is half Q3 minus Q1. Now, in order to understand this, we must know what is Q3 and what is Q1. So just try and see here. Let's say I have this data set with me. I know that if I want to go to its middle value, this would be median. Median would be such that the 50% of the data set would be above this value and 50% of the data set would be below this value. Now, what is Q1? Q1 is such that if I go ahead and divide the data set, 1/4 of the data set would be above and 3/4 of the data set would be below. This value would be called as Q1. Similarly, what would be Q3? If I go ahead and I put a break here, such that 3/4 is above and 1/4 is down, then it would be Q3. Now, if you would have remembered, the formula of median that we studied was L plus N by 2 minus CF upon F into H. This is the formula of median for class intervals. What I can do is, instead of writing N by 2, I can rewrite this as 2n by 4. I am imagining that my data set is divided in 4 parts. 1, 2, 3. These are the 4 parts of the data set. First, second, third, and fourth. This is my entire data set that I have. And median is exactly half of the data set. So it is 2 by 4. 2 portions here and 2 portions here.
Then quartile 1 would be here. It would be where 1/4 is here and 3/4 is here, which means I want to go ahead and divide my data set such that I pick the first 1/4 of the observation. So for Q1, I will, instead of having 2/4, have here 1/4. If I write it like this is the formula for Q1. Similarly for Q3, instead of writing this as 1/4, I just have to write this as 3/4. Then the formula will change into the formula of Q3. So for Q2, it is 2/4. Q2 is nothing but the median, second quartile, 2 above and 2 below. Q1 is 1 above and 3 below. Q3 is 3 above and 1 below. This is how you find quartiles. So in the most simple term, quartile is formulated from quarters. Quarter means dividing the data set in 4 parts. When you divide the data set in 4 parts, then the first part is called Q1. The first 3 parts, if I have that way, it's Q3. And now we define quartile deviation as the gap between Q3 and Q1 divided by 2. So quartile deviation is like the average gap between Q3 and Q1. You can rewrite this as average gap between Q3 and Q1. It's like saying, I found out what's the gap between Q3 and Q1. I am trying to go ahead and average that out. That will be quartile deviation. Achha, many books define something which is known as decile deviation also. Or at least they define something which is known as decile. Very simple on very similar basis. I have a data set and I am dividing this data set in 10 parts. So 1, 2, 3, 4, 5, 6, 7, 8, and 9. There are 10 equal parts that I have. And now I am saying, look, if I go ahead and take 5 portions here and take 5 portions here, this should be exactly half of my data set. I should have 5 portions here and 5 portions here. This is half of my data set. This half of the data set was called median. But if your data, instead of getting split in 2, is getting split in 4, then it becomes Q2. And if this data is getting split in 10, then this becomes D5, decile 5. 5 portions of the data set on one side and 5 portions of your data set on the other side. Now you can again find out, if I ask you find D1, it means you are saying that I want 1/10 of the data here and I want the remaining 9/10 of the data here. So instead of 1/4, what will you have? You will have here 1/10, and this will be now D1. You can find D1, D2, D3, D4, D5, D7, D10, whatever you want, right? So if you ask me D9, I want 90% of the data set, 9/10. If you ask me D5, 5/10, but 5/10 will be n/2. That's the formula of the median. So I can divide my data set in 10 parts and just change this part. And accordingly, I will get the value. Same goes with something called as percentile also. Just you can note all of this. I don't have these in my notes, but just make a note of this also. Percentile is dividing the data set in 100 parts. Again, the formula is the same. You can find P10, P90. P10 will be n into 10/100 here in the formula. So whatever n is getting multiplied with, if I'm finding P10, it means there are 100 parts. And I'm finding what is first 10 parts versus the 90. So 10/100. If you ask me to find P90, it will be 90 by 100. P50, 50 by 100. That will be median, n by 2. So you can divide your data set in just 2 parts using median, 4 parts quartile, 10 parts decile, 100 parts percentile. Just write down here. You can have median, you can have quartile, you can have decile, you can have percentile. Okay, if you ask me quartile deviation, Q3 minus Q1 by 2. Decile deviation, 10.9 minus 10.1 by 2. Percentile deviation, P90 minus P10 by 2. You ask me, I will just give you the extreme value ranges, subtract that and divide that by 2. This is how you can go ahead and find these values. Now, let's talk about the next one, which is called the mean deviation. Now, there was one formula that we had read, that the summation of mean deviation, that's 0. Which means if I find deviation of each value from its mean and I add that together, it will always give me 0. But if I want to find mean deviation, I must first find its absolute value. That will not be 0. Take an example. So for example, let's say I have a very simple data set, 1, 2, 3, 4 and 5. Let's say this 3 is my mean. So I start finding xi minus x bar. So 1 minus 3 will be minus 1. 2 minus 2, sorry. 2 minus 3 minus 1, 0, 1 and 2. If I add this together, I will get 0. That's the rule. Sum of deviation from mean is 0. But if I find its absolute value, then this will be 2, 1, 0, 1, 2. Now this is not 0. I can add this together. So it will be 6. That is what this is doing. What mean deviation is doing. It's saying you find the deviation from mean, but you find its absolute value, you sum that over, this is what we are getting here, and divide it by the number of observation, that will be your mean deviation. You can also get frequencies here. Then you will multiply each by its frequency. So for example, here after I find the absolute value of mean deviation, someone tells me the frequency. So it says me frequency is 1, 2, 3, 1, 2. Then I will multiply these two together. So 2, 2, 0, 1, 4, 9. This will be summation fi xi minus xy. I have multiplied each deviation by the frequency. And I get this and I sum that over. Now I will not divide by number of observation. I will divide it by the total frequency. So what is my total frequency? 9. Right. So I will divide it by summation f. So this n here will be summation fi. Don't divide it by 5. Don't divide by number of observation. If you are given frequency, it means numbers are repeating. So the numbers are not just 5. 1 got repeated 1 time, 2 got repeated 2 times. So they're more than 5. I will divide it by the total frequency. That is mean deviation. Now come to the next one. This is called standard deviation and sample variance also I will explain. So this was a confusion among many students. See, usually the standard deviation and variance of population, they are represented by sigma square or sigma. And that of a sample standard deviation or variance, they are represented by S or S square. Unless, they specify in the question that this is population and this is variance. Sometimes most of the Indian authors especially will use them interchangeably. They will just say prove S square is summation X square by N, something like that. So they will use this S square and sigma square interchangeably in the Indian books, unless it's a question of hypothesis testing, where sample and population are of use. But foreign authors will make sure that you see this difference. Now, what happens if in exam they give you this S square? How will you judge whether it is a sample or a population if it is not mentioned in the question? Then just try to figure it out with the help of sample size. If your N is 10, 11, 12, small number up to 30, consider it as a sample. It's a small value, no? It cannot be the entire population. More than 30, consider it fine. Consider it like a population. Now, here is the thing why I'm saying this. Imagine that, so sigma square, this is summation xi minus x bar whole square by n. And sample ka, it is summation xi minus x bar whole square by n minus 1. Now let me use capital N only to avoid confusion. Now imagine that my n is 100. Suppose. In this case, the sum that I'm getting is 1000. So one will be 1000 by 100 and the other will be 1000 by 99. For very large values of n, these will be very close to each other. You can find the value and check. They're very, very, very close to each other. This will be 9 point something, something, something. This will be exact 10. So because they are very close to each other, we assume that even when it would have been a sample and maybe I misunderstood it as a population, the final testing will work well. Nobody is asking me to find sigma square actually. They will ask me to do something with sigma square. So whether I take n or I take n minus 1, most of the time, 99% of the time, my t test, z test, f test will work fine. So for large enough size of n greater than 30, it is fine whether you use this formula or this. If you don't know, but if the question clearly mentions, take this sample, then use this formula. If the question mentions, take this population, use this formula. If they clearly give you sigma square, definitely population, right? If they give you S square, it's a good idea to take sample. But I am telling you, if your n is large enough and you solve with this formula, it is fine. That's all that we are discussing. Now let's just go back to this point. So I have to go ahead and I have to check what is my standard deviation. It will be summation x minus x bar whole square multiplied with the frequency divided by the size. No, it's mean xi minus x bar, not assumed mean, the actual mean value that you have. Only that is why I said that if you don't take the absolute value, you will get the answer as 0. So it's the actual mean. So you can actually write this if you want to avoid confusion. A is the actual mean, x bar. Okay. Small n should technically come in S square formula, right? Why the big N? Achha, so ideally, when I talk about N is something which is very, very misrepresented. N just means the size of whatever observations I have. This N can be sample, it can be population. So many times I will show you, in fact, in the past year questions, they will say consider N is equal to 6. Now this cannot be my population. This has to be sample, but I will use capital N if it is given in the question. So the representation of N can always be questioned. If you feel that you have to go ahead and change between small and capital N, you can go ahead and take this as population and this as sample. It is only relevant to distinguish between population and sample if you do hypothesis testing. That's my last topic that I would be doing. When we do this, then it will make sense to distinguish between the two. Here in the formula, it will not make sense, but if you want to distinguish, you can say that, this should be n minus 1 upon summation xi minus x bar whole square. Because if you start distinguishing that way, then you will realize that actually in population, mean is not written by x bar. Mean is written by mu. In sample, mean is written by x bar. So we have to start distinguishing between what is a parameter, what is a static. In दोनों में distinguish होना would be important. We are not doing that for now. So we are not deep diving into why यहाँ पर mu लिखना जरूरी है और यहाँ पे x bar, why small n and big N. We are just saying that if it is a sample variance, you will subtract 1 from the denominator. Otherwise, you will not subtract 1. And someone may ask why. Absolutely, we can use them interchangeably. One more thing. The question is why. Why the denominator will be n minus 1 and not n. This is because of something which is known as the degrees of freedom. Now, when we talk about the degree of freedom, in sample, we always have lesser degrees of freedom, which is n minus k. Let me give you an example. Suppose I tell you that the sum of 5 number is 20. Find these 5 numbers. What will you do? You will say, okay, I have to fill these 5 gaps and I want the sum to be 20. I can take the first number as 1 maybe, then I'll take 2, then I will take 3, then I will take 2. I see randomly I can pick any numbers. But I can only pick 4 numbers randomly. The 5th number is dependent on what the first 4 numbers are. This is not free to be chosen because I want the sum to be 20. So if this sum is 8, then I want that this number should be 12 if I want to go ahead and satisfy this. So how much is the freedom that you are giving me in this case? You are giving me the freedom to choose only 4 numbers. I cannot choose the 5th number on my own. So the degrees of freedom that I have is the number of numbers you want me to choose less 1. Now this is a very, very simple concept here. So just remember that when I talk about the degrees of freedom, the question is how free I am to choose things. And when I talk about the sample, I have one less degree of freedom because of the parametric value that I want to tend it to. I will talk about this in hypothesis testing. For now, only understanding the basic of it, that you're dividing by n minus 1, is enough. Okay, now let's just have a look at this question here. So just consider, I'm given the age group and I'm given the frequency. So I take the middle value of the age group for each of this. So 20 to 30, 25, 30 to 40, 35, 45, 55, and so on. Then I take one assumed mean. So this is my assumed mean. I subtract assumed mean. So 25 minus 55 will be minus 30. 35 minus 55 minus 20, and so on. I see that the common factor is 10. So I take h to be 10. And I also simultaneously divide by 10. So I get this as my final D. Minus 3, minus 2, minus 1, 0, 1, 2, and 3. Now I just do F into D. So I get these values. And I do F into D square. And I get these values. So F into D. And then I am finding D square and multiplying F with that D squared. Mean formula we know from the last class. It is A bar plus H summation FD by N. So A is assumed mean 55. H is the gap 10. Then FD is minus 15. And the sum of the frequency is 542. I just put these values and I get 54.72. Always make sure that whatever assumed mean you're taking, it is the middle point. Aisa don't do ki ye assumed mean later. Answer will come, but you should always try to take the center point as the assumed. Now here is the formula for your sigma square. One formula what we did was this. Summation xi minus x bar whole square by n. Then I gave you another formula that you can write this as summation fi xi minus x bar whole square by summation fi. Now, if you go ahead and you are using the shortcut method of assumed mean, then you can also go ahead and use this formula. Very, very important. Okay, I want you to think in your mind. See, this is working on the deviations, huh? I didn't take the value of A anywhere. So the question I'm asking is why there is no presence of assumed mean in this formula. Just think about this once. From assumed mean, I found deviation. Somewhere I should have used that assumed mean. I am using that assumed mean here to find the mean value. Why am I not using the assumed mean in this formula? How is this formula working absolutely correctly without the assumed mean value? I just want you to think through that once. So the formula is this. It says summation fd square by n minus 1 by n summation fd whole square into h square. Just take this into consideration once. See, when I find summation fd by n, and I'm multiplying this by h also, no? So suppose I open this up. Let's open this up once. What will we get? We'll get h square 1 by n summation fd square minus h by n summation fd whole square. Okay. Notice that this part, this is actually this part only. It is everything of the mean value except the assumed mean. So actually this part that I have here, this is nothing but x bar minus a whole square. Right? Now, from this, if you start solving this part, there is another very important relevant formula that you will get, that sigma square is summation xi square by n minus summation xi by n whole square, which is nothing but summation xi square by n minus mean whole square. This will also be your sigma square. So just notice here, I have deviations here. Deviation was nothing, but how did you define deviation? Deviation was this, right? Deviation was xi minus assumed mean by h. That was your deviation. So if you take back the value of your deviation here, your entire thing will be in xi's and a's. That a will get cancelled out with this a, and you will get your formula only in terms of xi's and x bar. Now, absolutely, you're very, very correct. Because of the change of origin does not matter. Correct. It's absolutely correct answer. Okay. So now just have a look here. I want to go ahead and define something which is known as expectation. I will do this a lot in probability, but just for now, I'll take complete class on expectation in stats. But just understand, expectation of any variable x is when you sum that and divide by n. मतलब mean निकालो किसी का तो वो उसकी expectation. Whenever you find mean of something, it's its expectation. So if I am adding all the xi square together and I am dividing by n, जहां पे भी you see this part together, ऊपर sum and नीचे n, you can rewrite that as expectation of xi square. So which means here also I'm finding this sum by n, here also I'm finding this sum by n. So sigma square can be rewritten as expectation of xi square minus expectation of xi whole square. This is the formula which comes in exam. Very, very important. You may mark this down. Most important. Throughout, we are going to go ahead and use this. So expectation of xi square, matlab you have a data of x, you find x ka square, and then you add all of these together and divide by n. And here you are first adding all of these together and dividing by n and then squaring it. This is this value. If you subtract the two, that is your sigma square. So just come back here. I'm using this formula here to find sigma square. So summation fd square. Don't get confused between f into d square and fd whole square. This is first multiplying f with deviation, dividing it by n. Mane it is finding the expectation of fd and squaring that. This is first squaring d square and then multiplying with f and then summing those over and dividing by n. So this is this part. Summation fd square. First finding d square, multiplying by frequency and adding that out. This is fd summed up. If you just... The coefficient of variation helps us to compare data and their corresponding risk or variation. ये एग्जाम में डेफिनेटली आ सकता है. Let me give you an example. So they will use words like this, which has less risk, which is more consistent, which has less dispersion. अलग अलग words use कर सकते हैं. Now, whenever they ask you that which of the two player is more consistent, which of the two portfolio is less risky, that means that you need to compare the coefficient of variation between the two data sets. So for example, if I tell you that there are two stocks, stock A and stock B, and आपको stock A का average earning दिया हुआ है and stock B का भी average earning is given to you. You're also given the variance of stock A and variance of stock B. So you need to find that which stock is less risky. Any stock which will have less coefficient of variation, that stock will be less risky. Or which stock is more consistent? Any stock which has less coefficient of variation, that stock will be more consistent, right? No, coefficient of variation and covariance are not the same thing. They're very different. So we are talking about coefficient of variation. Okay. So we are saying that whichever will have less variation, जिसका भी ये CV कम होगा, that will be more consistent, that will be less risky. Now, just try to see here. So let me give you one example here. So here, suppose something like this is a question given to you. So it says there are three batsmen A, B and C in the same series of 7 innings and उनका score दिया हुआ है 50, 48 and 12. तो आप just by looking at data आपको लगेगा कि the third player is doing horribly because he just scored 12 on an average, and the first player is doing very well because he has scored 50 on an average. But you're also given their standard deviation, and their standard deviation on 50, 12 and 2. माने जो first player है, he scores 50, but he can go below or average 50 by a huge amount. The deviation is by 15. The second player is scoring 48, but he can go below or average again by 12. The third player is scoring 12, but he can go below or above the average by 2. So we cannot just directly look at numbers and tell which player is more consistent. To know which player is more consistent, we need to go ahead and find the coefficient of variation. So coefficient of variation के लिए simple, you will go ahead and do sigma, that means standard deviation by mean into 100. Okay. So in the first case, it will be 15 by 50 into 100. In the second case, it will be 12 by 48 into 100. In the third case, it will be 2 by 12 into 100. So you will notice that the lowest coefficient of variation is coming out here. That means the player 3, he is actually most consistent क्योंकि उसमें सबसे कम variation है, right? So this player comes out to be the most consistent player. So whenever in exam, instead of players, they could have told you that these are 3 stocks, A, B and C. Right? And they would have so told you that you are given the average earning of the stock. Okay? And they're asking you which stock is more consistent or which stock is least risky. Same baat hai. Whichever will have the lowest coefficient of variation, you will go with that stock. वो stock best stock होगा. You need to go ahead with that stock. Right? So this is why coefficient of variation is very Hello, good evening, everyone. Beta, welcome to the next lecture. Or we are going to today talk about Z score and Chebyshev's inequality. आज हम Z score और Chebyshev's inequality की बात करने वाले हैं. सबसे पहले let us go ahead and let us try to think about some diagrams. देखो ध्यान से समझो. Suppose if I go ahead and if I make a diagram like this, मैं अगर एक ऐसा diagram बनाती हूँ. ठीक है. एंड इफ आई ज्वाइन द मिड पॉइंट्स, मैं इसके मिड पॉइंट्स को ज्वाइन करती हूँ. ओके. तो दिस इज कॉल्ड अ स्क्यूड डेटा सेट. वाई स्क्यूड डेटा बेटा? क्यों इसको हम स्क्यूड डेटा क्यों बोलते हैं? क्योंकि एक अनस्क्यूड डेटा सेट या एक सिमेट्रिकल डेटा सेट लुक्स समथिंग लाइक दिस. मतलब द एरिया ऑन द लेफ्ट हैंड साइड and the area on the right hand side is actually equal. If this is 50%, अगर 50% एरिया यहाँ पर है, so this will also be 50%. 50% एरिया यहाँ पर होगा. So the area on the left and the right side will be equal. अगर वो हो रहा है, if it is like this, then it is called as symmetrical data set. इसको हम एक symmetrical data set बोल सकते हैं. Now, when this is not happening, you see this. This is left side. This is right. So this is called as a skewed data set. कौन सा skewed है बेटा? This is skewed to the left. ठीक है. अब similarly, if I look at the data like this, और मैं इसके मिड पॉइंट्स को ज्वाइन करूं ऐसे, तो दिस इज अ राइट स्क्यूड डेटा सेट. ये जो डेटा है, दिस इज स्क्यूड टू द राइट. ये राइट स्क्यूड डेटा सेट है. ठीक है. तो एक लेफ्ट स्क्यूड डेटा है और एक राइट स्क्यूड डेटा. ये बात समझ में आती? इज इट मेकिंग सम सेंस? ठीक है. नाउ व्हाट वी आर गोइंग अहेड एंड वी आर सेइंग इज कि अ डेटा मे बी सिमेट्रिक या फिर अ डेटा कैन बी अ स्क्यूड डेटा सेट. डेटा कुछ भी हो सकता है, वो सिमेट्रिक भी हो सकता है और वो स्क्यूड भी हो सकता है. राइट. मतलब आई हैव गिवन यू एग्जांपल्स इन द प्रीवियस क्लास ना कि डेटा सिमेट्रिक भी हो सकता है और स्क्यूड भी हो सकता है. तो स्क्यूनेस का मतलब ही क्या है? व्हाट इज द मीनिंग ऑफ स्क्यूनेस? इस स्क्यूनेस का मीनिंग ही क्या है? सो स्क्यूनेस बेसिकली इज नथिंग बट एसिमेट्री ऑफ अ डिस्ट्रीब्यूशन. अगर एक डिस्ट्रीब्यूशन एसिमेट्रिकल है, सिमेट्रिकल नहीं है, if a distribution is not symmetrical then it is skewed. Skewed का मीनिंग हो जाता है that the distribution is either tilted towards left side or tilted towards right side. तो स्क्यूनेस का क्या मीनिंग है बच्चा? कि either the distribution is left tilted या right tilted, दोनों में से एक साइड पे it is tilted. Right. Skewness also goes ahead and tells us कि how far distribution deviates from symmetry. सिमेट्रिकल डेटा के कंपैरिजन में हाउ फार इज द डिविएशन, हाउ फार इज द डिविएशन, कितना डिविएशन है, हाउ फार इज द डिविएशन एज कंपेयर टू सिमेट्री। ठीक है। अब व्हेन वी टॉक अबाउट लेफ्ट स्क्यूड डेटा, जब हम इस लेफ्ट स्क्यूड डेटा की बात करते हैं, देन दिस इज कॉल्ड एज नेगेटिव स्क्यूनेस। A left skewed data is called as negative skewness. Negative skewness माने यहां पर the skewness when we will calculate इसका value it will come less than zero. और negative skewness का मतलब है कि most of the observation are on the right. ज्यादातर जो ऑब्जर्वेशन है वो राइट साइड पे है। मोस्ट ऑफ द, आप देख रहे हो हाईएस्ट फ्रीक्वेंसी की जो ऑब्जर्वेशंस हैं, सपोज बेटा यहाँ पे मैं 10, 20, 30, 40, 50, 60, तो 40 की फ्रीक्वेंसी कितनी ज्यादा है, मतलब डेटा में 40 विल बी कमिंग वेरी ऑफन, 50 विल बी कमिंग वेरी ऑफन, 60 विल बी कमिंग वेरी ऑफन। तो जो ऑब्जर्वेशन ज्यादा दिखती हैं, दोज ऑब्जर्वेशंस विच आर सीन मोर ऑफन, दे आर एक्चुअली टू द राइट हैंड साइड, वो राइट हैंड साइड पे है। इज इट क्लियर? अब हम बात करते हैं व्हाट डज दिस मीन। इसका मीनिंग ये आ जाता है दैट इन दिस केस यू विल नोटिस दैट योर मीन इज लेस देन मीडियन, इज लेस देन मोड। मोड माने व्हाट इज मोड बेटा? मोड इज ऑब्जर्वेशन विथ हाईएस्ट वैल्यू, हाईएस्ट फ्रीक्वेंसी, है ना, हाईएस्ट फ्रीक्वेंसी। सो मोड यहां कहीं है, सपोज यहां पे 50 की हाईएस्ट फ्रीक्वेंसी, सो दिस इज मोड। मीडियन माने जो डिस्ट्रीब्यूशन को 50-50 कर रहा है, मतलब यहां कहीं होगा 50% डेटा हियर, 50% हियर, तो मीडियन यहां कहीं होगा। मीन एवरेज है वो यहां कहीं होगा। सो मीन इज लेस देन मीडियन इज लेस देन मोड। ये क्लियर है? चलिए, नाउ वी टॉक अबाउट राइटली स्क्यूड डेटा। राइट स्क्यूड इज ऑल्सो कॉल्ड एज पॉजिटिव स्क्यूनेस। इसको हम पॉजिटिव स्क्यूनेस भी बोलते हैं। दिस इज ऑल्सो कॉल्ड एज पॉजिटिव स्क्यूनेस। और पॉजिटिव स्क्यूनेस का मतलब है कि जो हमारा टेल होगा वो राइट साइड पे होगा, राइट? सो टेल एक्सटेंड्स राइट साइड, राइट? बट मोस्ट ऑफ द ऑब्जर्वेशंस लेफ्ट साइड पे होंगे। मोस्ट ऑफ द ऑब्जर्वेशंस आर ऑन द लेफ्ट। तो आप देखोगे कि जो लेफ्ट साइड के ऑब्जर्वेशंस हैं, दे हैव हायर फ्रीक्वेंसी। मोस्ट ऑफ द ऑब्जर्वेशंस आर ऑन द लेफ्ट। ठीक है। अच्छा, इस केस में व्हाट डू वी गो हेड एंड व्हाट डू वी ऑब्जर्व? सो वी ऑब्जर्व दैट द मीन इज ग्रेटर देन मीडियन, इज ग्रेटर देन मोड। मोड सबसे कम है, मतलब सपोज ये 10 है, ये 20, ये 30, तो मोड सबसे पहले ही आ जाएगा। मोड विल कम फर्स्ट, जिसका हाईएस्ट फ्रीक्वेंसी है दैट ऑब्जर्वेशन विल कम फर्स्ट। सो मोड इज लेस देन मीडियन, मीडियन इज लेस देन मीन। ठीक है, ये बात क्लियर होती है बेटा आपको? चलिए, अब हम बात करते हैं जीरो स्क्यूनेस की, विच इज दिस डेटा, सिमेट्रिकल डेटा। ऑफ कोर्स यहाँ पे हमारा जीरो स्क्यूनेस है ना, और मीन, मीडियन, मोड, दीज थ्री आर इक्वल टू ईच अदर। ये तीनों ही एक दूसरे के साथ इक्वल है। इज इट क्लियर? एवरीवन इज क्लियर बेटा? चलिए, अब अगर हमें ये बात समझ में आ गई है, दिस इज क्लियर टू ऑल ऑफ यू, तो इसके बाद अब हमें ये समझना होगा कि यू नो व्हाट इज अ जेड। अच्छा सॉरी, सो स्क्यूनेस का फॉर्मूला फॉर सैंपल डेटा, प्लीज राइट दैट डाउन बेटा। फॉर्मूला ऑफ स्क्यूनेस। बच्चे ये हो जाता है n अपॉन n-1 n-2 सब्मिशन xi माइनस x बार बाय s टू द पावर 3 टू द पावर 3। क्लियर है ये बात? तो दिस इज द फॉर्मूला फॉर स्क्यूनेस। ठीक है जी, इज इट क्लियर ऑल ऑफ यू? वेयर एस इज द स्टैंडर्ड डिविएशन, ऑफ कोर्स हाँ बेटा, एस स्टैंडर्ड डिविएशन है। ठीक है, चलिए अब हम आज बात करने वाले हैं एक बहुत इंपॉर्टेंट एस्पेक्ट की। वी आर गोइंग टू गो अहेड एंड टॉक अबाउट समथिंग वेरी वेरी इंपॉर्टेंट, and that is basically called as Z score, right? What is this called as? It's called as Z score. बहुत important है, very very important from the point of view of your exam. ये समझना कि what is a Z score. Okay, so let's begin. चलिए लिखिए Z score। बेटा लिखोगे नहीं तो आएगा नहीं, you have to write with me. If you don't write you will never understand. Z score क्या है? Z score basically it measures relative position of a value in a data set. Z score क्या करता है? वो relative position को मेजर करता है किसी भी वैल्यू की डेटा सेट में। मतलब बेसिकली एक तरीके से वो ये बताता है कि कोई भी वैल्यू एवरेज वैल्यू से कितना पास या कितना दूर है। इट टेल्स अस हाउ फार और हाउ क्लोज एनी वैल्यू इज फ्रॉम द मीन। सो इट टेल्स how far or close is a value from the mean। वो जब भी हम z वैल्यू निकालते हैं we always 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 measure it in units of standard deviation। अभी समझ में आ जाएगा, 2 मिनट दे दो, you will understand it। give me a minute, हाँ। तो ध्यान से देखना, whenever I have to talk about formula of z score, तो zi होता है बेटा xi माइनस एक्स बार अपॉन स्टैंडर्ड डिविएशन। ये z का फॉर्मूला है। zi इज xi माइनस एक्स बार अपॉन स्टैंडर्ड डिविएशन। ठीक है, तो व्हाट वी आर डूइंग, देखो पहला हम बता रहे हैं कि कोई भी ऑब्जर्वेशन मीन वैल्यू से कितने डिस्टेंस पे है। फर्स्ट वी आर टेलिंग हाउ मच इज एन ऑब्जर्वेशन अबव मीन वैल्यू, और दूसरा हम उसको स्टैंडर्ड डिविएशन से डिवाइड कर रहे हैं ताकि वी गेट इट इन टर्म्स ऑफ स्टैंडर्ड डिविएशन, राइट? ताकि वी गेट इट इन टर्म्स ऑफ स्टैंडर्ड डिविएशन, इसलिए हम उसको स्टैंडर्ड डिविएशन से डिवाइड कर रहे हैं, राइट? सो बेसिकली बिकॉज वी आर डिवाइडिंग इट बाय स्टैंडर्ड डिविएशन, जब भी हम एक z वैल्यू निकालते हैं, whenever we divide a z, whenever we find a z value, it is called as standardized value। इट इज कॉल्ड एज स्टैंडर्डाइज्ड वैल्यू। इसको हम स्टैंडर्डाइज्ड वैल्यू भी बोलते हैं। वी ऑल्सो कॉल दिस एज स्टैंडर्डाइज्ड वैल्यू। और क्यों बोलते हैं इसको स्टैंडर्डाइज्ड वैल्यू बेटा? बिकॉज जेड वैल्यू इज इंटरप्रेटेड इन टर्म्स ऑफ नंबर ऑफ स्टैंडर्ड डिविएशन फ्रॉम द मीन। हम इसको स्टैंडर्ड डिविएशन के टर्म्स में निकाल रहे हैं। वी आर फाइंडिंग इट इन टर्म्स ऑफ स्टैंडर्ड डिविएशन, दैट इज व्हाई इट इज ऑल्सो कॉल्ड एज स्टैंडर्डाइज्ड वैल्यू। इसीलिए इसको हम स्टैंडर्डाइज्ड वैल्यू भी बोलते हैं। अच्छा एक बात बताओ मुझे, we know standard deviation is always positive because it is under root of variance, तो हमेशा हम उसका पॉजिटिव वैल्यू लेते हैं। सो वी नो दैट स्टैंडर्ड डिविएशन इज ऑलवेज पॉजिटिव। स्टैंडर्ड डिविएशन हमेशा ही पॉजिटिव होता है। सो सिंस स्टैंडर्ड डिविएशन इज ऑलवेज पॉजिटिव, सो डिनोमिनेटर पॉजिटिव है, सो इफ द न्यूमरेटर इज पॉजिटिव जेड वैल्यू विल बी पॉजिटिव। if the numerator is negative, क्योंकि denominator तो positive ही है, z will become negative, and if the numerator will be 0 तो z value will become 0। सो वैल्यू z का क्या रहेगा वो इस बात पे डिपेंड करेगा कि न्यूमरेटर क्या है, क्योंकि डिनोमिनेटर तो हमेशा ही पॉजिटिव है। तो अगर पॉजिटिव न्यूमरेटर होगा तो पॉजिटिव बाय पॉजिटिव पॉजिटिव है, अगर न्यूमरेटर नेगेटिव है तो नेगेटिव बाय पॉजिटिव नेगेटिव है, अगर न्यूमरेटर जीरो है तो जीरो बाय पॉजिटिव जीरो है। सो बेसिकली इट विल डिपेंड ऑन व्हाट योर न्यूमरेटर इज। ये बात हमें क्लियर होती है? इज इट क्लियर एवरीवन? तो ये इस बात पे डिपेंड करता है, इट डिपेंड्स ऑन द फैक्ट दैट व्हाट इज योर न्यूमरेटर, आपका न्यूमरेटर क्या है। सो नाउ थिंक अबाउट इट, व्हेन विल न्यूमरेटर बी पॉजिटिव? बच्चे ये पॉजिटिव कब होगा? व्हेन xi विल बी ग्रेटर देन x बार। व्हेन विल दिस बी नेगेटिव बेटा? व्हेन xi इज लेस देन x बार। इसको यहां ले जाओ। When will this be zero beta? When xi is equal to x bar. So if xi is greater than x bar, अगर xi x bar से greater है तो numerator will be positive. अगर xi x bar से कम है then numerator will be negative. If xi is equal to x bar then numerator will be zero and so will be z score. ये बात समझ में आती है? चलिए we'll take an example. आइए आज एक example ले लेते हैं। सो वी हैव स्टूडेंट्स मार्क्स और ये दिए गए हैं 46, 54, 42, 46, 32। चलिए बेटा फाइंड द मीन। तो मीन हो जाता है 46 प्लस 54 प्लस 42 प्लस 46 प्लस 32 डिवाइडेड बाय 5। चलिए बेटा टेल मी की क्या वैल्यू होगा। 10, 16, 17, 18, 19, 20, 4, 6, 8, 9, 10, 18, 180 बाय 5। ठीक है जी, इज इट क्लियर? हम्म, देख लो एक बारी, इफ आई हैव मेड अ मिस्टेक। ना ये 200 हो जाएगा ना कंप्लीट, सॉरी 200 बाय 5। ठीक बात है, एक बारी देख लो। 6, 7, 8, 9, 10, 20। सो 2 goes up, 4, 8, 12 and 8, 20, 220। दिस इज वॉट हैपेंस व्हेन आई एम इन अ हरी, कभी जल्दी नहीं करने का। 44 फाइनल। कभी कभी आई वॉन्ट टू रैप अप अ लेक्चर, सो आई विल बी वेरी क्विक। चलिए एक्स आई माइनस एक्स बार। 46 माइनस जी 44 हो गया 2 बेटा। 54 माइनस 44 हो गया 10 माइनस 2, 2 एंड -12। ये हो जाता है हमारा जेड स्कोर। अच्छा यहीं से वी कैन सी कि ये 46 है और ये 44 है मीन, मतलब 46 इज मोर देन 44। तो हमें पता है कि जो z का वैल्यू आएगा इट शुड कम पॉजिटिव। यहाँ पे पॉजिटिव आना चाहिए। 42 इज लेस देन 44 तो नेगेटिव आना चाहिए। 46 इज मोर देन 44 तो पॉजिटिव आना चाहिए। 32 इज लेस देन 44 तो नेगेटिव आना चाहिए। सो ऑलरेडी वी नो कि z पॉजिटिव होगा या नेगेटिव होगा। नाउ टू फाइंड द z स्कोर आई नीड स्टैंडर्ड डिविएशन। तो चलिए स्टैंडर्ड डिविएशन निकाल लेते हैं। सबमिशन एक्स आई माइनस एक्स बार होल स्क्वायर करते हैं बेटा। सो 46 माइनस 44 तो 2 आया था, इसका होल स्क्वायर हो जाएगा 4, इसका होल स्क्वायर हो जाएगा 100, होल स्क्वायर हो जाएगा -2 का 4, इसका होल स्क्वायर हो जाएगा 4 एंड 144। अब मैं जल्दी नहीं करूंगी, आराम आराम से करेंगे। 4, 8, 12 and 112 plus 144, 6, 5, 256। ठीक है जी, 256। बेटा मेरी नंबर ऑफ ऑब्जर्वेशंस हैं 5, क्योंकि मुझे मीन का स्टैंडर्ड डिविएशन निकालना है तो समेशन xi माइनस एक्स बार होल स्क्वायर अपॉन n माइनस 1 का अंडर रूट। तो 256 डिवाइडेड बाय 4 का अंडर रूट, सो 464 का अंडर रूट 8। ठीक है, स्टैंडर्ड डिविएशन आ जाता है 8। फॉर्मूला क्लियर है बेटा स्टैंडर्ड डिविएशन का? वी आर फाइंडिंग स्टैंडर्ड डिविएशन ऑफ द सैंपल। सैंपल में हमेशा n माइनस 1 विल कम इन द डिनोमिनेटर, राइट? क्लियर है? चलिए आगे बढ़ते हैं। अब व्हाट वी हैव टू गो अहेड एंड डू ना बेटा, कि अब हमें यहां पे निकालना होगा z वैल्यू। सो xi माइनस एक्स बार डिवाइडेड बाय स्टैंडर्ड डिविएशन, तो माने 2 डिवाइडेड बाय 8। बेटा 2 डिवाइडेड बाय 8 हो जाता है 0.25। 10 डिवाइडेड बाय 8 हो जाता है 1.25। माइनस 2 डिवाइडेड बाय 8 हो जाता है माइनस 0.25। 2 डिवाइडेड बाय 8 हो जाता है 0.25। माइनस 12 डिवाइडेड बाय 8 हो जाता है माइनस 1.50। ठीक बात है? चलिए, नाउ व्हाट वी विल गो अहेड एंड डू इज कि वी विल ट्राई टू इंटरप्रेट इसका मीनिंग क्या है। सो आई विल इंटरप्रेट वन ऑफ देम, किसी एक को इंटरप्रेट कर लेते हैं। तो सपोज इफ z इज 1.25, इसका क्या मीनिंग है? व्हाट इज द मीनिंग ऑफ z 1.25? z 1.25, so z is what? xi minus x bar upon standard deviation equal to 1.25। xi minus x bar equal to 1.25 into standard deviation। मतलब the gap between the observation एंड मीन और ऑब्जर्वेशन का जो गैप है वो 1.25 स्टैंडर्ड डिविएशन का है। मतलब मीन जो भी होगा, ऑब्जर्वेशन जो है वो 1.25 स्टैंडर्ड डिविएशन उससे ज्यादा है, राइट? सो वी कैन से दैट जो भी हमारा ऑब्जर्वेशन है xi इज 1.25 स्टैंडर्ड डिविएशन मोर देन द मीन वैल्यू। इज दिस क्लियर? ये बात समझ में आती है? इज दिस क्लियर ऑल ऑफ यू? ये इंटरप्रिटेशन क्लियर हो रही है? सो बेसिकली व्हाट वी आर डूइंग हियर, अब इसमें हमने एक तरीके से क्या किया, वी आर गिविंग अ रिलेटिव पोजिशन। हम रिलेटिवली बता रहे हैं कि हाउ द ऑब्जर्वेशन इज विद रिस्पेक्ट टू इट्स मीन वैल्यू, राइट? कि अपने मीन के कंपैरिजन में मीन से ऑब्जर्वेशन ज्यादा है क्योंकि ये पॉजिटिव है, राइट? इफ दिस वुड हैव बीन नेगेटिव मतलब इट इज लेस। जैसे अगर इफ xi माइनस एक्स बार बाय स्टैंडर्ड डिविएशन जो z स्कोर है, सपोज द z स्कोर इज नेगेटिव माइनस 1.25, ठीक है? सपोज इट इज माइनस 1.25, तो बेटा इसका मीनिंग तो सॉरी माइनस 1.25 नहीं है, माइनस 0.25 है। माइनस 0.25, तो बेटा xi माइनस एक्स बार हो जाएगा माइनस 0.25 इंटू एस। तो अब वी कैन गो अहेड एंड से कि क्योंकि द गैप इज नेगेटिव, तो जैसे 4 माइनस 5 माइनस 1 होता है, तो 4 इज लेस देन 5 बाय 1 यूनिट ना, तभी तो 4 माइनस 5 नेगेटिव आ रहा है। सो हियर वी कैन से, यहां पे हम बोल सकते हैं दैट xi इज लेस देन इट्स मीन by 0.25 standard deviation। 0.25 स्टैंडर्ड डिविएशन। सो इन अ वे हम ये बता रहे हैं कि व्हाट इज द रिलेटिव पोजीशन, किसी भी एक ऑब्जर्वेशन का पोजीशन क्या है, राइट? इज इट मोर देन मीन, इज इट हाइयर देन मीन, इज इट इक्वल टू मीन, क्या है उसका पोजीशन? सो वी आर बेसिकली गोइंग अहेड एंड सेइंग इन टर्म्स ऑफ स्टैंडर्ड डिविएशन हाउ डू यू स्टैंड विद रिस्पेक्ट टू मीन। बात समझ में आती है? अच्छा, अब एक बात बहुत अच्छी है कि व्हेन वी कन्वर्ट समथिंग इन जेड स्कोर, क्यों इंपॉर्टेंट है चीजों को जेड स्कोर में कन्वर्ट करना? बिकॉज वंस वी कन्वर्ट समथिंग इन जेड स्कोर, सो वी गेट अ कॉमन स्केल फॉर कंपैरिजन। ठीक है, एक जेड स्कोर जो होता है वो यूजुअली यूनिट फ्री होता है। देखो, सपोज फॉर एग्जाम्पल मैं बोल रही हूं कि एक्स आई इज द वेट ऑफ अ स्टूडेंट। ठीक है, तो एक्स आई माइनस एक्स बार, मतलब हमने कुछ केजी, सपोज सपोज किसी एक स्टूडेंट का वेट जो है वो 50 केजी है, और एवरेज जो है वो 45 केजी का और स्टैंडर्ड डिविएशन जो है वो सपोज 5 केजी है ना। तो जेड स्कोर क्या हो जाएगा बेटा, 50 - 45/5। अब व्हाट हैपेंस इज कि क्योंकि न्यूमरेटर इज इन केजी एंड डिनोमिनेटर भी केजी में है, सो केजी एंड केजी कैंसिल आउट, और जो ये जेड स्कोर दैट वी विल बी गेटिंग, ये हमारा जो जेड स्कोर आ रहा है, दैट विल बिकम यूनिट फ्री। ठीक है, इट विल बिकम यूनिट फ्री, एंड द मोमेंट इट बिकम्स यूनिट फ्री, देन आई कैन डू कंपैरिजन across डेटा सेट्स। फिर मैं कंपैरिजन कर सकती हूँ अलग अलग डेटा सेट्स का। देन आई कैन डू अ कंपैरिजन अक्रॉस डेटा सेट। समझ पाए? सो जेड स्कोर इज समथिंग विच इज यूनिट फ्री। सो observation in two different data sets with same z score means that they have same location। बात समझ रहे हो? सपोज बेटा, मुझे नहीं एक एक मैंने इकोनॉमिक्स का एग्जाम लिया, और एक मैंने मैथ्स का एग्जाम लिया, राइट? वंस आई टुक एन इकोनॉमिक्स एग्जाम एंड वंस आई टुक अ मैथ्स एग्जाम। ठीक है, एंड यहाँ पे एक स्टूडेंट का जेड स्कोर है 1.5, और यहाँ पे भी एक स्टूडेंट का जेड स्कोर है 1.5। सो इफ दिस जेड स्कोर इज सेम, अगर स्टूडेंट का ये जेड स्कोर सेम है, इफ दिस जेड स्कोर इज सेम, अगर एक स्टूडेंट का जेड स्कोर सेम है, देन दे हैव द सेम रिलेटिव स्टैंडर्ड। मतलब मुझे नहीं फर्क पड़ता कि यहाँ पे क्लास का एवरेज कितना आया, आई डोंट केयर यहाँ पे क्लास का एवरेज कितना है। शायद इकोनॉमिक्स एग्जाम वाज वेरी डिफिकल्ट, और यहाँ पे जो एवरेज रहा होगा आउट ऑफ 10 वो 5 रहा होगा। मैथ्स एग्जाम वाज इजी, यहाँ पे जो एवरेज रहा होगा सपोज वो 8 आउट ऑफ 10 रहा होगा, बट इट डज नॉट मैटर, मुझे फर्क नहीं है। दिस मीन्स कि रिलेटिवली ये स्टूडेंट दोनों ही एग्जाम में द स्टैंडिंग इज द सेम, बिकॉज उसका जेड स्कोर सेम है, तो वो एवरेज से जिस डिस्टेंस पे है उसके मार्क्स, इट इज द सेम। Are you understanding this? So both exam he has performed same. Okay, ये बात समझ में आ रहा है? सो जेड स्कोर सेम होने से उनका रिलेटिव पोजीशन अपने अपने डेटा सेट में becomes same. It becomes the same. क्लियर? ये बहुत इंपॉर्टेंट एस्पेक्ट है। जेड स्कोर हमें अलग अलग डेटा सेट्स के वैल्यू को फेयरली कंपेयर करने देता है। अलग अलग डेटा सेट में मीन अलग हो सकते हैं, स्टैंडर्ड डिविएशन अलग हो सकते हैं, यूनिट अलग हो सकते हैं, पर जब हम किसी चीज का जेड स्कोर निकालते हैं और अगर जेड स्कोर सेम आता है, तो इसका मतलब ये है कि उस डेटा में आप उस मीन वैल्यू से जिस डिस्टेंस पे हो वो सेम है दो अलग डेटा के लिए। जेड स्कोर बताता है कि आप अपने ग्रुप के एवरेज से कितने ऊपर या कितने नीचे हो, और अगर जेड स्कोर सेम आ रहा है तो दोनों अलग अलग सब्जेक्ट होते हुए भी आप बोल सकते हो कि आपकी रिलेटिव परफॉर्मेंस सेम है। नंबर अलग आ सकते हैं, दोनों में मार्क्स अलग हो सकते हैं, बट आपकी परफॉर्मेंस लेवल सेम है। यू हैव परफॉर्म द सेम इफ द सेट स्कोर इज द सेम। इज इट मेकिंग सेंस? सो जेड स्कोर इज हेल्पिंग अस नॉर्मलाइज डेटा सेट सो दैट वी कैन कंपेयर डिफरेंट डेटा सेट्स। ठीक है, तो जेड स्कोर हमें नॉर्मलाइजेशन करने में हेल्प करता है। I hope that this is making sense. ठीक है। ओके, सो विद दिस वी कम टू द एंड ऑफ जेड स्कोर, और ये बहुत बहुत इंपॉर्टेंट है एग्जाम पॉइंट ऑफ व्यू से बेटा। सो आई होप दैट ऑल ऑफ यू विल गो अहेड एंड ऑल ऑफ यू विल डू दिस वेल। अब इसी को मैं डॉट प्लॉट के थ्रू एक फाइनल एनालिसिस करना चाहूंगी यहाँ पे। सपोज बेटा मीन मेरा यहाँ पे 44 का है, एंड ऑफ कोर्स मीन के कॉरेस्पॉन्डिंग इस ऑब्जर्वेशन का जेड स्कोर 0 होगा, क्योंकि 44 में से 44 इज गेटिंग सब्ट्रैक्टेड, है ना। अगर मेरा ऑब्जर्वेशन जो है वो 44 है और मीन भी 44 है, तो जेड स्कोर ऑटोमेटिकली 0 हो जाता है। तो यहाँ पे मेरा जेड स्कोर 0 हो जाएगा। नाउ ऑल ऑब्जर्वेशंस विच विल बी हियर, जो मीन से ज्यादा होंगी, वहां पे मेरा जेड स्कोर पॉजिटिव रहेगा, एंड ऑल ऑब्जर्वेशंस विच विल बी हियर, जो मीन से कम होंगी, वहां पे मेरा जेड स्कोर नेगेटिव रहेगा। राइट, इज इट क्लियर? और अगर मुझे डॉट प्लॉट से दिखाना है तो व्हाट आई कैन शो, कि बेटा 32 ऑब्जर्वेशन का फ्रीक्वेंसी 1 था, 42 का फ्रीक्वेंसी भी 1 था, यही हमारे डेटा में था ना। 46 वॉज कमिंग ट्वाइस, कम बैक टू द डेटा सेट, देखो 46 दो बारी आ रहा था, 42 एक बारी, 32 एक बारी, 54 एक बारी, एंड 54 वॉज कमिंग वंस। और इफ आई हैव टू कन्वर्ट दिस इन टर्म्स ऑफ जेड स्कोर, तो यहाँ पे क्या हो जाएगा कि -1.25, -1.5 सॉरी, एक बारी। 42 के कॉरेस्पॉन्डिंग वैल्यू क्या थी, -0.25 वन टाइम। 46 की कॉरेस्पॉन्डिंग वैल्यू क्या थी, 0.25 टू टाइम्स। और 54 की जेड वैल्यू क्या आई थी, 1.25 वन टाइम। तो नाउ वी हैव कन्वर्टेड दिस इन टर्म्स ऑफ अ डॉट प्लॉट, इसको हमने डॉट प्लॉट की तरह एक्सप्लेन कर दिया। ठीक है, we will stop here for today. Our next session में we will continue this and we'll talk about Chebyshev's inequality. ठीक है, ओके बेटा, थैंक यू। थैंक यू सो मच बेटा, थैंक यू फॉर योर एप्रिसिएशन। हेलो बेटा, today we are going to go ahead and talk about Chebyshev's inequality. थोड़ा सा नेम से कितना डिफिकल्ट लगता है ना ये सुनने में, बट इट्स वेरी इजी, सो इफ यू अंडरस्टैंड दिस वेल, बहुत ही इजी कॉन्सेप्ट है एंड यू विल लव द कॉन्सेप्ट। चलिए समझते हैं। We have already gone ahead and we have already talked about what is a Z score in detail. ठीक है, हमने बात की कि Z score क्या होता है, हाउ टू फाइंड Z score, why Z score is unit free, why Z score is a good thing to use and where it can be used. ठीक है, अब हम शेबिशेव्स इनइक्वालिटी की बात करते हैं। शेबिशेव्स इनइक्वालिटी नहीं, एक्चुअली आई शुड बी कॉलिंग दिस एज शेबिशेव्स थ्योरम। इनइक्वालिटी थोड़ा सा डिफिकल्ट कॉन्सेप्ट है, बट फर्स्ट लेट्स टॉक अबाउट शेबिशेव्स थ्योरम। ठीक है, Chebyshev theorem basically helps us understand, it helps us give statement about how many data values are within a specific standard deviation of mean. कितना proportion डेटा का कहाँ लाई करता है, राइट right? वो ये थ्योरम बताता है। सो आई एम राइटिंग द थ्योरम फर्स्ट। एट लीस्ट 1 - 1 by z square of the data values must be within z standard deviation of the mean, where z is any value greater than 1, where z is any value greater than 1। ठीक है, इसका implication देख लेते हैं. तो suppose if I take z as 2. ठीक है. So 1 minus 1 by 2 square, 1 minus 1 by 4, 1 minus 0.25, 0.75. If I have to convert this in percentage, तो 100 से multiply कर लो 75%. So what we are saying? 75% of the data. Z का वैल्यू क्या था बेटा? 2. Must be within 2 standard deviation from mean. ठीक है. Suppose if I tell you कि Z is 3, तो क्या वैल्यू आएगा बच्चे? 1 minus 1 by 3 square, 1 minus 1 by 9, 8 by 9, right? So if I do 8 by 9, so had it been 0.81, तब तो मैं डायरेक्टली बोल देती that this becomes your 0.9, 90%. अभी के लिए 0.8, so minus 72, 80, 0.88, 8 and something like this. So approximately 0.89 ले लेते हैं. So 89% of the data is within 3 standard deviation. ठीक है. तो कैसे लिख सकते हैं? 89% of data values must be within 3 standard deviations of the mean. ठीक बात. चलिए अब सपोज इफ आई टेक z as 4, मतलब करते रहो. आई होप यू हैव अंडरस्टूड द प्रोसेस, right? So this will come approximately 0.94. So 94% of the data is within 4 standard deviation of the mean. ये बात समझ में आती है? So this is called as Chebyshev's theorem. This requires z to be greater than 1, but it does not mean that z has to be an integer. Z can be 4.5 also, z can be 4.3 also. Z का integer होना जरूरी नहीं है, right? Z can be a decimal also, but of course what we require for sure is that z has to be greater than 1. Z का value more than 1 होना जरूरी है, right? Is it clear? चलिए. So this, now let's talk about empirical rule, जिसमें आपको यूज करने की जरूरत ही नहीं है Chebyshev's. You can directly remember these 3 value, that about 68% of data is within 1 standard deviation, about 95% of data is within 2 standard deviation, about 99% of data is within 3 standard deviation of me. So this is your empirical rule. मतलब इसमें आपको you don't have to find it. और एक बहुत इंटरेस्टिंग बात है यहाँ पे, वन ऑफ द एडवांटेजेस ऑफ Chebyshev's theorem, जो आपको बाद में रियलाइज होगा, is that this Chebyshev's theorem, this can apply to any data irrespective of the distribution. इसके लिए जरूरी नहीं है कि डिस्ट्रीब्यूशन नॉर्मल डिस्ट्रीब्यूशन हो, skewed left हो, skewed right हो. डिस्ट्रीब्यूशन कैसे भी हो, वट एवर मे बी द डिस्ट्रीब्यूशन, रिगार्डलेस ऑफ द शेप ऑफ द डिस्ट्रीब्यूशन ऑफ द डेटा, कुछ भी शेप हो सकती है डेटा की, राइट? माई डेटा कैन वेरी वेल बी डिस्ट्रीब्यूटेड लाइक दिस, My data can very well be normally distributed. My data can very well be distributed like this. My data can very well be distributed like this. Whatever be the distribution of the data, Chebyshev's theorem can be applied to any data. शेबिशेव की थ्योरम हम किसी भी डेटा सेट पे लगा सकते हैं, किसी भी डेटा पे अप्लाई कर सकते हैं, रिगार्डलेस ऑफ द शेप ऑफ द डिस्ट्रीब्यूशन ऑफ द डेटा. इससे फर्क नहीं पड़ता कि डेटा का डिस्ट्रीब्यूशन क्या है. व्हाट इज द डिस्ट्रीब्यूशन ऑफ द डेटा सेट. इज दिस क्लियर एवरीवन? ठीक है. एंड सेम गोज विद द एम्पेरिकल रूल. ठीक है. जब हम एम्पेरिकल रूल की बात करते हैं, अब व्हेन वी गो अहेड एंड व्हेन वी टॉक अबाउट द एम्पेरिकल रूल, ये तीन, देन वी गो अहेड एंड वी स्पेसिफिकली अप्लाई दिस. यूजुअली अगर आप देखोगे, वी अप्लाई दिस टू अ नॉर्मल डिस्ट्रीब्यूशन, सिमेट्रिक डिस्ट्रीब्यूशन. ठीक है. सिमेट्रिक माउंड अबाउट या बेल शेप्ड डिस्ट्रीब्यूशन पे यूजुअली एम्पेरिकल डेटा हम लगा के चलते हैं. सो एम्पेरिकल रूल जो है, द एम्पेरिकल रूल दैट वी हैव, ये वाला, दिस इज फॉर अ बेल शेप्ड डिस्ट्रीब्यूशन. ठीक है. दिस इज फॉर अ नॉर्मल डिस्ट्रीब्यूशन. मतलब ये सिमेट्रिक डिस्ट्रीब्यूशन के लिए होता है, जहां 50% इज हियर एंड 50% इज हियर. This empirical rule is for a normal distribution, but usually जो overall Chebyshev's theorem है, the Chebyshev's theorem applies very well to any data set, regardless of the shape of distribution. Distribution of data set कैसा भी क्यों ना हो, आप Chebyshev theorem को apply कर सकते हो. And this is the advantage of Chebyshev's theorem. यही Chebyshev's theorem का advantage है. Is it clear? ये बात समझ में आती है? ठीक है. So now एक चीज और है which I want to kind of highlight here, which is called as the process of outliers. बहुत डिटेल में नहीं पढ़ना है, बस थोड़ा सा समझ लो. अ डेटा सेट कैन हैव सम वेरी अनयूजुअल ऑब्जर्वेशन. हर डेटा सेट में कुछ ऑब्जर्वेशंस होती हैं जो बहुत ही ज्यादा अनयूजुअल होती हैं, बहुत ही अलग सी वियर्ड लगती हैं. माने सपोज इफ आई टेल यू कि आई एम राइटिंग अबाउट द मार्क्स ऑब्टेन्ड in a class of 10 students, and marks ऐसे हैं 5 5 6 6 7 8 5 9, और मार्क्स है क्या 100, एंड आई एम टेलिंग कि ये मार्क्स हैं ही आउट ऑफ 10, तो क्लियरली एक आउटलायर है. दिस इज एन अनयूजुअल ऑब्जर्वेशन. तो समटाइम्स जो एक बहुत अनयूजुअली लार्ज या अनयूजुअली स्मॉल ऑब्जर्वेशन होती है, वी एज्यूम देम टू बी आउटलायर्स. एंड statisticians have to be very careful around outlier. अगर आपको अपने डेटा में एक आउटलायर दिखता है, if you find an outlier in your data set, so you have to be very very careful with it. आपको उसके अराउंड बहुत ही ज्यादा केयरफुल रहना पड़ता है regarding that outlier, right? So this is what basically we are going ahead and we are saying that whenever we go ahead and whenever we talk about any data set, जो भी unusually large या unusually small observations होंगी, they will be called as your outliers. ठीक है. Now जो हमारा standardized Z score है, we can go ahead and we can use it to identify these outliers. इन outliers को हम अपने standardized score में निकालने की कोशिश कर सकते हैं, आइडेंटिफाई करने की कोशिश कर सकते हैं. कैसे कर सकते हैं बेटा? So what we go ahead and what we see is we find one lower limit and upper limit. जो हमारा lower limit होता है वो होता है quartile 1 minus 1.5 interquartile range, and our upper limit is quartile 3 plus 1.5 interquartile range. If our data is not in this range, अगर वो इस values में नहीं है, right, तो हम उसको आउटलायर बोलेंगे. सिमिलरली इफ वी हैव फाउंड द जेड स्कोर, अगर हमने अपना जेड स्कोर निकाल लिया है, तो कोई भी ऑब्जर्वेशन हुज जेड स्क्वायर इज नॉट बिटवीन -3 एंड +3. ठीक है. अगर स्टैंडर्डाइज्ड वैल्यू -3 और +3 के बीच में नहीं आ रही है, इट इज कमिंग -3.5 -4 या 3.74, माने -3 एंड 3 के बीच में नहीं है, then there are chances that it can be an outlier. So in terms of Z value, जब आप एक standardized value निकाल लेते हो, when you find a standardized value, if the value is not within -3 and 3, then we go ahead and we say that it is basically an outlier. एंड अनदर वे टू फाइंड आउटलायर इज बेस्ड ऑन क्वार्टाइल. क्वार्टाइल मैंने आपको बता दिया है. व्हाट इज अ क्वार्टाइल? व्हेन यू गो अहेड एंड डिवाइड द डेटा सेट इन 4 पार्ट्स. ये एग्जैक्टली सेकेंड क्वार्टाइल है जिसको हम मीडियन बोलते हैं. ये क्वार्टाइल 1 है वेयर 25% डेटा यहाँ है एंड 75% यहाँ है. एंड ये क्वार्टाइल 3 है. सो क्वार्टाइल 1 एंड क्वार्टाइल 3 के बेसिस पे वी कैन गो अहेड एंड वी कैन फाइंड द लोअर एंड अपर लिमिट. अगर डेटा लोअर एंड अपर लिमिट के बाहर जा रहा है, इफ द डेटा इज गोइंग आउटसाइड लोअर एंड अपर लिमिट, देन वी गो ahead and we can say that it is an outlier. Now what is an interquartile range? ये भी मैंने आपको समझाया है. What is IQR? You remember this? So what is an interquartile range? ये actually you should be doing this from I think class 12th में करवाते हैं क्या ये? I've forgotten if this is ever done in class 12th. हाँ. So when we talk about interquartile range, तो interquartile range कुछ नहीं होता है. It tells us the spread of the data set. So IQR कुछ नहीं है, but IQR is Q3 minus Q1. Difference between quartile 3 and quartile 1 is called as interquartile range, जिसको हम IQR भी बोलते हैं. ठीक है. तो once you go ahead and you have interquartile range, quartile 1 and quartile 3 का वैल्यू, उसके बेसिस पे आप अपना लोअर लिमिट एंड अपर लिमिट निकाल सकते हो. एंड एनी डेटा विच इज बियॉन्ड लोअर एंड अपर लिमिट, अगर कुछ भी लोअर या अपर लिमिट के आगे पीछे जा रहा है, इफ इट इज गोइंग बियॉन्ड लोअर और अपर लिमिट, देन वी कैन गो अहेड एंड से दैट इट इज एन आउटलायर. तो हम उसको आउटलायर बोल सकते हैं. क्लियर? चलिए, सो विद दिस वी एंड द क्वेश्चन एंड आई एम गिविंग वी एंड द क्लास. एक क्वेश्चन है, ले लो जरा थोड़ा सा. ट्राई टू डू दिस क्वेश्चन. सो देर इज अ सर्वे विच वी डिड in which we found out that the average sleep of an individual is 6.9 hour per night. एक कोई भी इंडिविजुअल 6.9 आवर्स पर नाइट को सोता है. ठीक है. एंड हमने ये भी देखा दैट द स्टैंडर्ड डिविएशन इज 1.2 आवर्स. ठीक है. सो यूज शेबिशेव्स थ्योरम to calculate percentage of individual who sleep. बेटा मैं शॉर्ट फॉर्म में लिख रही हूँ. हाँ. who sleep between 4.3 and 4.5 and 9.3 hours. मैं एक बार रीड कर देती हूँ. आई हैव रिटन इट इन अ वेरी बैड हैंड राइटिंग, तो आई शुड बी रीडिंग इट आउट. व्हाट द क्वेश्चन इज सेइंग कि हमें दिखाई कि एवरेज स्लीप इज 6.9 आवर पर नाइट. ये एवरेज स्लीप दिया हुआ है आपको. एंड आपका स्टैंडर्ड डिविएशन दिया गया है 1.2 आवर्स का. आपको शेबिशेव्स इनइक्वालिटी को यूज करना है बताने के लिए द परसेंटेज ऑफ पीपल हु स्लीप बिटवीन 4.5 एंड 9.3 आवर्स. कितने लोग 4.5 से 9.3 आवर्स के बीच में सोते हैं. यू हैव टू गो अहेड एंड टेल दैट. गिव इट अ ट्राई क्विकली बेटा एवरीवन. क्वेश्चन कोशिश करो करने का. चलिए लेट्स स्टार्ट. सो सबसे पहले हम निकालेंगे z वैल्यू, क्योंकि z से ही तो हम आगे का निकाल सकते हैं. सो फॉर 4.5 हमारा जो z वैल्यू हो जाएगा, z विल बी डिस्टेंस ऑफ 4.5 फ्रॉम मीन. राइट. डिस्टेंस ऑफ 4.5 फ्रॉम मीन and divided by standard deviation. So when you will find this out, तो आ जाएगा -2.4 divided by 1.2, माने you will get the answer as -2. एंड जब हम 9.3 का निकालेंगे z वैल्यू, सो डिस्टेंस ऑफ 9.3 फ्रॉम इट्स मीन डिवाइडेड बाय स्टैंडर्ड डिविएशन, तो ये भी आ जाएगा बेटा 2.4 डिवाइडेड बाय 1.2 माने +2. So we have got z value as -2 and +2. अब शेबिशेव्स इनइक्वालिटी के थ्रू, शेबिशेव्स थ्योरम के थ्रू, 1 minus 1 by z square, 1 minus 1 by 4, 3 by 4, that means 75%. 75%. ठीक है. So final answer will be 75%. So those people who sleep between 4.5 to 9.3 hours, that is basically 75% of the people. ये बात समझ में आती है? So individuals who sleep between 4.5 and 9.3 hours according to Chebyshev's inequality will be 75%. I hope this question is clear to all of you. ठीक है? Okay, beta. Thank you.
Morning, everyone. Beta, in today's lecture, I am going to go ahead and begin with a very, very important topic for the day, which is called probability. The next few modules that we do, these are fully going to be based out of probability. And even the chapters that we do in the coming modules, like I was talking about it, the distributions, those distributions also require you to gain some knowledge of probability. So probability is something which is super important. Okay. To begin with, let us try to understand two types of situations. So I can go ahead and I can say that there are two types of situations. The first situation is called an outcome, which is unique. And the second situation is called an outcome, which is not unique. Now, think about an outcome which is unique. Like, for example, I tell you that, velocity is equal to u plus at, right? Or force is equal to mass into acceleration. That means I am going ahead and I am giving you a particular formula to determine something. And I know that this will not deviate. It will always and always remain like this. The formula will never ever change. If you give me mass and if you give me acceleration, I can find force. So such phenomena, they are called as deterministic outcome. Deterministic formula. Deterministic matlab I can determine exactly what will take place. So that becomes deterministic in nature. The second one, as I mentioned, is one which is not unique. When I say something is not unique, it means that it can have several possible outcomes. It can have several possible outcomes. So, better, for example, tossing a coin. It can give me heads also, it can give me tails also. For example, weather. It can rain, it can be summery, it can be wintry, anything. So, any phenomena which has multiple possible outcomes, that is known as a probabilistic outcome. That is known as a probabilistic outcome. So I have a deterministic outcome and a probabilistic outcome. In probabilistic outcome, you can have multiple examples like tossing a coin. Now, we are not interested in deterministic outcome. There is nothing to find out there. You already know everything there. So what we are interested in doing is called as a probabilistic outcome. I can only do things around that. There, I have to go ahead and do multiple definitions with you today. So please write down definitions. So beta, when I talk about definitions, the first definition that I want to discuss with you is called trial and event. Consider an experiment. What is an experiment, Pele? An experiment is whatever you do. Toss a coin, that's called an experiment, right? Organize an event in which there can be a rain or no rain. Organizing an event is called an experiment. Whatever you do, throw a dice, that's an experiment. That's what you're doing. So an experiment is what you do. And an experiment itself is called a trial. Okay, so we can go ahead and say that consider an experiment. So as I mentioned, this experiment can be thought of any event like tossing a coin, like throwing a dice. These are all experiments. And what happens is we are assuming such experiments which whenever repeated will not give the same result. Mane, if I toss the coin once, it gives me head. If I toss it again, it may give me head, it may give me tail. So when I go ahead and when I repeat the same experiment again, it will not give you a unique result. It will not give you the same result. It may end up giving you a different result. So you are saying which can be thought of being repeated, but not giving unique outcome. So every time you repeat, you get a different result. Such experiments which give you different outcome, they're also called as trial. So what we can go ahead and say that such experiments are called trials. Now, once you have a trial, the outcome of the trial, just when I throw a dice, I can either get 1 or 2 or 3 or 4 or 5 or 6. So throwing a dice can be called an experiment or a trial, but the outcomes of it, 1, 2, 3, 4, 5, 6, they can be called outcome or event. So we can say that the outcomes are called events. So you have to remember these keywords better. So what am I saying? I am saying that when you throw a dice, better this is trial, and getting any number, say getting a 1, this is one of the event that I have. Ki result hai iska, outcome hai iska, that I am getting a 1. Second definition. The second thing that you must understand is called exhaustive events. Now, when I talk about exhaustive events, what am I saying? Any event such that it exhausts your entire sample space, that is called as an exhaustive event, right? So what can we say? That the total number of possible outcomes in any Achha, now I'm going to use another word. I can write trial, but sometimes books will use a term called sample space. Sample space is when I write all possible events. So for example, when I toss a coin, I can either get head or tail. This is my sample space. So when I go ahead and throw a dice, I can get 1, 2, 3, 4, 5, 6. This is my sample space. If I write all possible outcomes of my sample space, it means I am exhausting everything. I am taking into consideration all possibles. I'm going ahead and taking into consideration all possible outcomes. But a sample space is nothing but the outcomes that you get. If you write it in form of a set like this, it is called a sample space. Okay. So it is just all possible outcomes that I write. That is my sample space. So suppose I tell you that I'm organizing a fair, and it can rain or it can not rain. So that is my sample space, raining, not raining. And exhaustive event is also the same. All possible outcomes, if I mention all possible outcomes, सारे के सारे outcomes अगर मैं लिख लूं, then it is exhausting my sample space. I'm writing everything down. Exhaust मतलब खत्म करना. So it is, I'm writing every possible outcome. So that becomes an exhaustive event. But the third one, it is called as mutually exclusive event. This is the third one. What is a mutually exclusive event? Read the word. Exclusive. Exclusive मतलब दूसरे को exclude करके अकेला रहना. So when I say mutually exclusive event, it means that if an event precludes the happening of the other events. For example, when head happens, when I toss a coin and head comes, तो tail नहीं आ सकता क्योंकि head आया है. If I toss a coin and tail comes, तो head नहीं आ सकता क्योंकि tail आ गया. So they are mutually exclusive events. They exclude each other. अगर rain है तो no rain नहीं हो सकता, no rain है तो rain नहीं हो सकता. Both things cannot take place together. Then they are said to be mutually exclusive events. So those events which preclude the happening of the other event, अगर वो हो रहे हैं तो कुछ और नहीं हो सकता, which don't have anything in common, that is called a mutually exclusive event. So we can say that अगर मेरे को इसको diagrammatically दिखाना हो, so I can say, see, if this is event A and this is event B, then beta they have something in common here. Then they are not mutually exclusive. Just I say that A is defined as when you throw a dice, it represents the possibility of even numbers. And I say that B represents that when I throw a dice, it represents the possibility of first four numbers. So beta even number will be 2, 4, 6. And first four numbers will be 1, 2, 3 or 4. So if you notice, they have something in common. Event A and event B have something in common. What is common? Two numbers. 2 also and 4 also. These are common numbers. Then they are not exclusive of each other because they have something in common. But when I say mutually exclusive events, it means if this is A and this is B, there should be nothing common between them. Like for example, I can say, ma'am, that A is nothing but all possibilities of even numbers when you throw a dice. And but a B can be all possibilities of odd numbers when you throw a dice. Now they have nothing in common. A will be 2, 4, 6. And B will be 1, 3, and 5. So are they mutually exclusive? Yes, they don't have anything in them. They don't have anything common. Yes, the intersection is 0. So they are mutually exclusive even. Are they mutually exhaustive also? Yes, they are mutually exhaustive. When I do A and B together, so I get 2, 1, 2, 3, 4, 5, 6. So A and B together exhaust the entire sample space. अगर मैं A और B को ले लूं तो मेरे को सारे के सारे outcomes मिल रहे हैं sample space के. I am not left up with anything. So in this case, they are not only mutually exclusive, ना ही वो एक दूसरे को exclude करते हैं, but they are also mutually exhaustive. यहाँ पे are A and B exhaustive? Let's see. When I include A and B, do I get everything? 1, 2, 3, 4, 6. No, ma'am. 5 is left. So they are not exhaustive, but they are not exclusive also. So when you have to check exclusiveness, you are checking for A intersection B. If this is nothing, if nothing is common between them, then they are exclusive. And when you have to check exhaustive, but you are checking A union B. And if A union B is entire sample space, if they exhaust the entire sample space, if they give you all possible outcomes of the sample space, then yes, they are exhausting the entire sample space. So these are the two things that you have to understand. They often come in exam, especially the MCQs will always ask you such questions. So we can say events are said to be mutually, you've already understood, but let's write down, exclusive if the occurrence of one event precludes the occurrence of the other event. So if occurrence of one event precludes the happening of the other event, then they are said to be mutually exclusive. Okay, beta. Now let's talk about the favorable events. So what are favorable events? Events are said to be favorable, but both can happen together now. If you're asking if mutually exclusive and exhaustive can happen together or not, yes, I just proved this example to you. These two don't have anything in common, so they are exclusive, but together they exhaust the entire sample space, so they're exhaustive also. So both things are happening together. Yes, beta, you're right. Disjoint sets are mutually exclusive. Disjoint means they don't have anything in common. So yes. Okay. So yes, exclusive and exhaustive can happen together. Okay. Next we have favorable events. Favorable events is the event you want that to occur. Hai na? So for example, when I say what is the probability of head? So head is my favorable event, right? So when I say what is the probability of going ahead and rain? So rain is my favorable event. So the number of favorable cases of an event is those events which you entail that they should happen, which you want them to happen. So those become my favorable events. So here, for example, when I said I want only even numbers, so getting even number is a favorable event. When I want all odd numbers, so getting odd number is a favorable event. So whatever event you want to happen, you want it to happen, that becomes your favorable event. So very simple. So we can say that the number of cases favorable to an event are which you entail happening. So which I want them to happen, then they become my favorable events. The next one that I have, beta, they are called as equally likely events. Now, what do I mean by equally likely? Equally likely means they have equal chance of occurrence. So equally likely events. So those events which have equal chance of occurrence become equally likely events. Again, example, tossing a coin. So probability of head is also half and probability of tail is also half, 50-50%. Probability of rain is half and probability of non-rain is half, then they are equally likely. Probability of 1 when you toss a coin is 1/6. Probability of 2 is 1/6. Probability of 3 is 1/6. Probability of 4 is 1/6. 5 is 1/6. 6 is 1/6. So when you when you throw a dice, कोई भी एक number आ सकता है. 1, 2, 3, 4, 5, 6. So all of them, 6, all of them have equal chance of occurrence. So they become equally likely events. Okay. The sixth one that I have, that is called as an independent event. ये सबसे tricky है. People always confuse independent with exclusive. Independent और exclusive दो अलग बात है. Independent event says that when the occurrence of my event is not affected by the occurrence of the other events, then they are independent events. For example, I give you a coin, but I ask you to toss this coin. You may get head, you may get tail. Suppose you get a head. Now I again ask you to toss this coin. Will it be affected with what happened earlier? No. इस बार फिर से head भी आ सकते हैं और tail भी आ सकता है. It does not matter that last time head came. So this time, whether I get head or tail, it is unaffected by whether last time I got head or tail, what I got in the first toss. So this is independent event. It is independent of the outcome of the last event, right? So any event is called as independent if it is affected by other events. If it is not affected by other events. Take an example, take more examples. Let's say that beta someone has got, let's say fever, right? Then will that person get cough? Maybe he can get cough. It can be dependent on getting fever. So then they are not independent of each other. The probability of cough will be affected with the probability of getting fever, right? But now, if I tell you that, beta, I go to a metro station and I have been able to reach on time at a particular place using metro. Will I be able to go ahead and do the same tomorrow? Maybe yes, maybe no, I don't know. If the metro runs at the same speed, yes. If the metro has some problem or if it stops, then no. So if the occurrence of the event is unaffected by the other event. So if there are two cricket players, if the first played well, will the second also play well? No. So they are independent of each other. And if the first plays well, the other also will play well, because we can give some reasoning to it that maybe the pitch is good or something like that. Then they're dependent on each other. So independence or dependence, it depends on whether a particular event is affected by the other event or not. So we should write this down. Mathematically, of course, हम बाद में पढ़ेंगे इसे. But अभी के लिए just a theoretical aspect. So events are said to be independent if occurrence of one event does not affect the occurrence of the other event. Right? Now, once we know the different types of events, we must talk about the actual definition of probability. So when I talk about the definition of probability, what is probability, beta? Probability is nothing but the number of favorable cases upon the total cases. So usually we represent favorable cases by M, and But it is different from exclusive because they may not exclude each other. Exclusive is when there is no commonality between the two. So, for example, I can tell you mathematically, but I don't want to go there for now. When we speak mathematically, we will talk about it again later. When I say that two events are exclusive of each other, it means that they have nothing in common. So if I have nothing in common, it means that they are disjoint. In a way, there is nothing common between this. This is A and this is B. This is how I can represent this diagrammatically. But when I say that two events are independent of each other, it means probability of A given B is simply probability of A. That means A is not affected by the fact that B has already occurred. It is the same as saying that B never occurred. B के होने से A को फर्क नहीं पड़ेगा. So for example, when I say that it will rain and not rain, these have nothing in common, right? But suppose I tell you that B is that it rained yesterday and A is that it rains today. तो बेटा they can be dependent on each other ना, क्योंकि अगर एक दिन बारिश हो रही है तो maybe it is creating some weather conditions that it can rain tomorrow also. It rained yesterday, तो weather forecasting में ये चीज बहुत important है that if it rained yesterday, it can rain today. So rain yesterday is affecting rain today. So they are dependent on each other. But they don't have anything in common. They are still excluding each other, right? So these are two very different things mathematically. When I say this, it means they have nothing in common. And when I say this, it means that given B has occurred, whether A will occur is simply that A will occur. A को B के होने से अगर फर्क ना पड़े, then they are said to be independent. So we will do mathematical analysis also. But for now, just understand that the two are very different things from each other. Okay. So let us take some examples for the day on probability. So take the first one. I am saying there are two unbiased dice that are thrown, right? You have to find the following probabilities. First, both dice show the same number. Second, first die shows 6. Third, total of the number on dice is 8. So, well before we do these questions, we will go ahead and make the entire sample space of dice. So, beta, what will happen in the sample space? When I throw just one dice, I can get 1, 2, 3, 4, 5, and 6. So there are 6 outcomes. When I throw 2 dice, so पहली बारी 1 आया, दूसरी बारी I can get 1, 2, 3, 4, 5, 6 में से कुछ भी. या पहली बारी 2 आया, I can get 1, 2, 3, 4, 5, 6 में से कुछ भी the second time. So when you throw a dice 2 times, the total number of outcomes that you will have will be 6 to the power 2. That means 36. Similarly, when you throw a dice 3 times, then you can have 6 to the power 3 outcomes. When you throw a dice 4 times, 6 to the power 4 outcomes, and so on. So whatever number of outcomes you get with one event, you just have to take it to the power n, where n represents the number of times it is repeated to get the total number of outcomes, right? So I can say that the total number of outcomes, that will be always the outcomes in one event to the power n. So when I go ahead and I say that, suppose let's talk about something else. Say I'm talking about maybe tossing a coin. So when I toss the coin once, I get two outcomes, na, head or tail. So if I will toss it twice, it can be head, 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 tail, tail, head, tail, tail. So it means it will be 2 to the power 2. When I toss it thrice, I will get 2 to the power 3. That means 8 outcomes, and so on. So what is happening in this case is, whatever number of outcomes you get in one trial, to the power n, where n represents the number of times it is repeated, that is your total number of outcomes. So here I have to represent these 36 outcomes. So I can just go ahead and represent my sample space here. And that is going to be 1, 1, 1, 2, 1, 3, 1, 4, 1, 5, 1, 6. 2, 1, 2, 2. You can just write this down. 2, 6. Right? So just continue filling this up. 3, 1, 4, 1, 5, 1, 6, 1. 3, 2, 4, 2, 5, 2, 6, 2. 3, 3, 4, 3, 5, 3, 6, 3. And then 3, 4, 4, 4, 5, 4, 6, 4. 3, 5, 3, 6. 4, 5, 4, 6. 5, 5, 5, 6. 6, 5, 6, 6. These are all my outcomes that I have. But now what I'm saying, the first one says that both dice show the same number. Matlab 1, 1. And then I have 2, 2, 3, 3, 4, 4, 5, 5, and 6, 6. So there are 6 favorable outcomes where I see the same number. And there are 36 total outcomes. So my probability will be 1 by 6. Look at the second one. Second one says the first dice is showing 6. That means I'm here 6, 6, 6. The first die, it reflects 6. So there are ultimately 6 such outcomes where the first dice is showing 6. So my probability will be favorable events by total events. That means 1 by 6. Look at the third one. It says the total number is 8, which means the sum is to be 8. So just see here, beta. We understand that 6 plus 2 is 8. Let me mark it with a different color. So we understand that 6 plus 2 is 8. We understand that 3 plus 5 is 8. We understand that 4 plus 4 is 8. We understand that 5 plus 3 is 8. We understand that 6 plus 2 is 8. So there are 5 such events which are favorable where the sum is 8 divided by total number of events, which is 36. So this is how you can go ahead and you can find the probability.
The fundamental principle of counting. And the principle of counting basically goes ahead and says that whenever we have to go ahead and whenever we have to formalize pairs, जब हमें pairs बनाने हैं, we should be multiplying things. जैसे for example, if I tell you that there is an individual Mohan, जिसके पास he has 3 shirts and he has 2 pants. And I ask you how many ways can he dress up? right? So whenever we have to create pairs, ठीक है, तो of course he has shirt 1, shirt 2, shirt 3, pant 1, pant 2. So he can have shirt 1 with pant 1, shirt 1 with pant 2, shirt 2 with pant 1, shirt 2 with pant 2, shirt 3 with pant 1, shirt 3 with pant 2. So that means that there are 6 ways in which he can dress up. 6 तरीके. And if I look here, 3 shirts and 2 pants. So 3 into 2 also give me 6 ways. So whenever we have to go ahead and whenever we have to, find the number of pairs, the fundamental principle of counting ये बोलता है that we can go ahead and we can multiply, and that can go ahead and give us the pairs. So I'll give you another example. So suppose if I tell you that there is an individual A and he has 2 school bags, right? And I tell you that he has 3 tiffin boxes, and I tell you that he has 2 water bottles. And I ask you how many ways can he carry these items? कितने ways हैं कि he can go ahead and he can carry these items? So he can carry any of the 2 school bag. He can carry any of the 3 tiffin. He can carry any of the 2 water bottles. So there are 12 ways, right? You can do it by multiplying also. कि he can have suppose water bottle 1 या water bottle 2. अगर water bottle 1 carry करता है तो he can go ahead and he can carry tiffin 1, tiffin 2 और tiffin 2 कैरी करता है तो ही कैन हैव टिफिन 1, टिफिन 2, टिफिन 3. ठीक है. अगर टिफिन 1 कैरी करता है तो देन अगेन ही कैन गो अहेड एंड ही कैन हैव बैग 1 या बैग 2, बैग 1 या बैग 2, बैग 1 और बैग 2, एंड हियर आल्सो बैग 1, बैग 2, बैग 1, बैग 2, बैग 1, बैग 2. So you will find that you will get 12 ways. आपको 12 ways मिलेंगे. So this is the fundamental principle of counting. राइट. फंडामेंटल प्रिंसिपल ऑफ काउंटिंग सिंपल ये बोलता है कि इफ फर्स्ट थिंग कैन हैपन इन m ways and second thing can happen in n ways, so together they can happen in m cross n ways, right? So first thing can happen in some ways, this can happen in some ways, this can happen in some ways. So if you multiply, you will get the total number of ways. Okay. So let's take a question to do this. So the question says that you have to find the number of 4-letter words, right, with or without meaning, which can be formed from the alphabets rows. Okay. And it says that repetition is not allowed. You have to tell how many words can be formed without repetition being allowed. So give it a try. So I have to form 4-letter words. So 1, 2, 3, and 4. Now the first one can be, I can pick any of the 4 alphabets in the first one, right? So if I can pick any of the 4 alphabets, यहाँ पे any of the 4 alphabets can come into, because I have to multiply. Then in the second one, any of the 3 alphabets can come. जो भी बाकी 3 बचे होंगे. Then in the next one, any of the 2 alphabets can come, and in the next one, any of the 1 alphabet can come. So basically, because we have something like this, we can go ahead and we can say that the number of ways that we have will be 4 into 3 into 2 into 1. So you can go ahead and multiply this, whatever answer you get. So 12 into 2, there will be 24 ways. Okay. Now again, we can go ahead and we can take another question. So supposedly I go ahead and if I tell you, अच्छा, what if ये repetition के साथ होता? You could repeat the alphabets. You can take R any number of times. तो मतलब the first place can be filled with any of the 4. The second one can also be filled with any of the 4 क्योंकि repetition allowed है तो यहाँ पे भी कोई भी चारों में से आ सकता है. Third one can also be filled with any of the 4, and fourth one will also be filled with any of the 4. माने 4 into 4, 16 into 16, 256 ways. तो अगर हम विद रिपीटिशन करते हैं, इफ आई डू विद रिपीटिशन, सो आई विल गेट 256 ways, and I do without repetition, so I will get 24 ways. Okay. So let's take another question. Suppose the question says that you are given that there are 4 flags which are of different colors. Okay. You have to tell me how many signals can be generated if signal requires use of 2 flag, one below the other. मतलब कैसे बनेगा सिग्नल? सिग्नल विल बी समथिंग लाइक दिस. यहाँ पे फ्लैग 1 आएगा और यहाँ पे फ्लैग 2 आएगा. And how many flags do we have? In total, we have 4 flags. That's very simple. First position में any of the 4 flags can come. अब जो भी flag यहाँ पे आ गया, I'll be left up with remaining 3 flags. So in the second one, any of the 3 flags can come and I will have 12 ways. So we can go ahead and we can say there will be 12 number of ways that will be there. Okay. So we'll take another question. Suppose the question says, how many 2-digit even number can be formed from 1, 2, 3, 4, 5 if digits can be repeated. Even number. तो ध्यान से देखो. If I have to form a 2-digit even number, तो ये 2 digits हो गए. Even requires that here I should get either 2 or 4. तभी तो वो even होगा. So any of the 2 digits can come here. And repetition is allowed. मतलब यहाँ पे जो भी 2 digit आएंगे वो भी यहाँ पे आ सकते हैं. They can come in the first position. Whatever comes here, they can also come here. Repetition is allowed. So that means that in the first position, any of the 5 digits can come. Right? So you will have 10 such ways. Right? The multiplication principle will tell us that there are 10 numbers which can be created. Right? So this is the first thing. This is called as principle of counting. अब हम बात करते हैं permutation की. So permutation basically goes ahead and permutation basically tells us when we want to go ahead and we want to do arrangement in some order. So order is important. अभी तक तो we were just asking how many ways are there to create something. But permutation basically goes ahead and tells us that we want to go ahead and arrange things in certain order. And in that case, when we want to arrange something in certain order, तो उस टाइम पे हमारे पास एक फॉर्मूला आ जाता है NPR का, which is P, where P is permutation. But permutation समझने से पहले we want to understand what is called as a factorial. एक factorial क्या है? And factorial is nothing but n factorial is simply n into n minus 1 into n minus 2 and so on. So जैसे for example, if I have 5 factorial, it will be 5 into 4 into 3 into 2 into 1. If I have 7 factorial, ये हो जाएगा 7 into 6 into 5 into 4 into 3 into 2 into 1. 7 factorial can very well be written as 7 into, इस चीज को हम 6 factorial लिख सकते हैं. 7 factorial को भी हम 7 into 6 into इतने पार्ट को हम 5 factorial लिख सकते हैं. It can very well be written as 7 into 6 into 5 into 4 factorial. So it is up to us how we want to go ahead and we want to write. Okay. Now once we understand this, so we want to understand what is a permutation ka formula. So permutation is NPR, where we can open this up and say this is n factorial upon n minus r factorial. Okay. So let's go ahead and let us take an example. So let's say, सबसे पहले question number 1. It says that you have an alphabet which is So let me just give you the exact question. It says, find the number of permutation of the word Allahabad. Find the number of permutations of different letters of the word Allahabad. अब ध्यान से समझना है. It means I want to arrange the alphabets given here in different ways. मुझे इनका arrangement करना है. But whenever I have to do arrangement, suppose मैं ऐसे arrange कर देती हूँ A, L, L, A, H. So ये दो A में there is no distinction. दोनों A exactly same दिख रहे हैं. तो I cannot distinct कि भाई ये तो alphabet, this is A of the first position and this is A of second position. और फिर मैं बाद में इनको interchange करूँ. It does not make sense. Are you understanding? A is A only, right? So it does not matter to me कि ये वाला A फर्स्ट पोजीशन पे आ रहा है या ये वाला A फर्स्ट पोजीशन पे आ रहा है या ये वाला A फर्स्ट पे है, ये वाला A फर्स्ट पे. It does not matter to me which A is coming at the first position. A is A, right? So whenever we do arrangement, in arrangement, it does not matter to me कि what is similar things are. जो A है वो A ही है. It does not matter to me whether when I rewrite them in different ways, this A coming first or this A coming first does not make a difference. Similarly, when I am writing, suppose मैंने इससे permutation के बाद I created a word LALAHABAD. Suppose I created one of these words. So whether this is the first L या this is the first L, मैं can distinguish नहीं कर सकती हूँ. And this is just L. So in this case, when there are repetitions, the distinguishing is not possible. वो distinction नहीं आता है. So there are 4 A's, there are 2 L's, and these are repeated words. So in case of arrangement, जब हमें चीजों को arrange करना है, arrangement, we will simply go ahead and say that in total there are 1, 2, 3, 4, 5, 6, 7, 8, 9 alphabets in 9 factorial ways, divided by, since there is no way to distinguish these 4, so I must remove them, 4 factorial, 2 factorial. I am treating them as one object. मैं इनको एक object की तरह treat कर रही हूँ because there is no way to go ahead and to tell. There is no way to tell what is the first A and what is the second way. और यही एक theorem है कि if there are n objects and P1 objects are of same kind, P1 एक ही तरीके के दिख रहे हैं, P2 एक ही तरीके के दिख रहे हैं, so you will divide by that P1 factorial, P2 factorial and so on. Right? So that's the first thing which you have to do. These are the first kind of question, alphabet questions. अब जो दूसरा question आता है, that is basically to go ahead and to formulate numbers. So suppose I tell you how many 4-digit number can be formed using the digits 1 to 9 if repetition is not allowed. So I have to create numbers but my repetitions are not allowed. अब यहाँ पे you have to understand कि arrangement कितना important है. Try to think about it. जब हम principle of counting कर रहे थे ना तो arrangement important नहीं था. मतलब यहाँ पे any of the 4 flags can come. यहाँ पे any of the 3 flags can come. But यहाँ पे arrangement becomes important. क्यों? क्योंकि when we write 1, 3, 2, 4 and when I write 1, 2, 3, 4, these are two very different numbers. Although same numbers use हो रहे हैं, 1, 3, 2, 4, 1, 3, 2, 4, same numbers use हो रहे हैं, same numbers are used, but because of arrangement, the answer becomes different, right? So because here arrangement is important, the moment you change the arrangement, जैसे ही आपने 1 और 2 का arrangement change कर दिया, the answer will differ. You are picking the same digits. You picked up 1, 3, 2, 4 only. But the arrangement of these 4 digits changed the answer, changed the number you are getting. तो arrangement यहाँ important है, इसीलिए यहाँ पे permutation use होगा. So permutation will be that out of 9, I need 4. There are 9 numbers, I need 4. So you use the formula. So NP R का formula है n factorial n minus R factorial. So this is n factorial by 5 factorial. You can solve this 9 into 8 into 7 into 6 into 5 factorial by 5 factorial and you will get some answer यहाँ पे. Right? So this is how permutation is used. So we'll take another question. Suppose if I tell you how many numbers lying between 100 and 1000 can be formed from digit 0, 1, 2, 3, 4, 5 if repetition not allowed. तो अब देखो फ्रॉम 100 to 1000 जितना भी नंबर है दे विल बी अ 3 डिजिट नंबर क्योंकि 1000 का से पहले का जो नंबर दैट्स 999 सो दैट मींस आई हैव टू क्रिएट अ 3 डिजिट नंबर. Right? So number one, you have to think that I have to create a 3-digit number, but you have to also see that 0 cannot come here. क्योंकि अगर यहाँ पे 0 आता है, if 0 comes here, then it will become out to be a 2-digit number. ये एक 2-digit number हो जाएगा. Isn't it? So I cannot have 0 in the first position, right? So we have to first count total permutation कि अगर 6 digit है, what are the total ways? So total ways in which I can create 3-digit numbers out of 6 numbers will be out of 6, I am picking 3. ये total ways of creating numbers है. But if 0 is here, so mathematically it will not make any sense. 0 cannot be in the 100 position क्योंकि फिर mathematically it becomes a 2-digit number. Otherwise there is no problem. 0 यहाँ पे 0, 1, 2 करोगे तो कुछ तो आएगा. But then it will no more be a 3-digit number and we want it to be a 3-digit number. Right? So we have to remove the cases जहाँ पे 0 यहाँ पे आता है. Right? So that means if I remove 0, I cannot have 0. Right? So I need to fill the out of the remaining 5. मुझे बाकी 5 से fill करना पड़ेगा. Right? So it means that I have to remove those cases where 0 is in the 100 position. So I don't want 0 in the 100 position. I don't want 0 here. So I want to fill this with the remaining 5 places. Right? So 5p2. Right? So we fix that this 0 cannot be at the 100th position. Right? So when we go ahead and when we do this, so out of the remaining 5, we need to take 2 at a time. So we will go ahead and we will get that the total number of cases here will be 6p3 minus 5p2. You can solve this. These are the numbers that you will be getting. Okay, so try to understand हमने यहाँ किया क्या है. Every number between 100 and 1000 will be a 3-digit number. जो भी आप number बनाना चाहते हो आपको एक 3-digit number बनाना है. First you count the total permutations possible. Total कितने तरीके से आप बना सकते हो. So you are given 6 digits out of which you have to choose 3 digits. These are the total ways possible. ठीक है. But these ways will also include 0 जहां पे 0 100th position पे आ रहा है. Because you are choosing any 3 number out of 6 number. Any 3. तो वो any 3 में 0 can also come at the 100th position. ठीक है. Like you can create a number 012, 052, 092, कुछ भी ऐसा बन सकता है. जो भी numbers दिए हुए हैं, you can create those numbers also. Right? So out of these numbers 012, 023 ऐसे करके ऐसे numbers भी create हो सकते हैं. Right? Which become a 2-digit number. तो we have to subtract those cases जहां पे वो 2-digit number बन रहा है to get the right number. So we want to remove the cases where we will be creating a 2-digit number. I remove those and we get the remaining answer. Okay, so this is the second kind of question which can be asked to you. ठीक है. एक बहुत basic question है. Sometimes they may ask you. So they may say find R if 5R 5 4PR is equal to 6 5PR minus 1 ऐसा कुछ दे देंगे. So it's a very simple question. आपको बस इसको open करना है. So this will be 4 factorial 4 minus r factorial, 5 factorial, 5 minus r minus 1 factorial, ये है 6 और ये है 5, right? So this will be 5 into 4 factorial upon 4 minus r factorial, 6 into 5 factorial upon 5 minus r plus 1 factorial. तो 5 into 4 factorial मतलब 5 factorial, 6 into 5 factorial मतलब 6 factorial upon 4 minus r factorial, और ये हो जाएगा 5 plus 1. That means we can say that this is going to be 6 minus r factorial. Now you can solve. 6 minus r को open कर दो. इसको और भी थोड़ा सॉल्व कर सकते हो, लाइक यू कुड हैव, इसको चाहते तो यू कुड हैव लेफ्ट अनटच्ड, तो ये 6 into 5 फैक्टोरियल को ही लिख देते, तो दिस वुड हैव कैंसल्ड आउट, राइट? सो यू विल गेट 6 minus r फैक्टोरियल, इसको यहां ले जाओ, अपॉन 4 minus r फैक्टोरियल इक्वल टू 6, एंड जस्ट ओपन दिस अप. सो ये हो जाएगा 6 minus r into 5 minus r into 4 minus r upon 4 minus r equal to 6. ये cancel. So you will be left up with 6 minus r into 5 minus r equal to 6. Right? It's a quadratic equation. Solve it and get the values of r. So this is again another method in which you can go ahead and get the kind of questions. ठीक है? इसमें आपको permutation के लिए solve करना है. So just try a question now. I'm giving you, write the answer in the comment. So you have to find the number of different ways in which daughter alphabets can be arranged if vowels can come together, if vowels should not come together. Give it a try. So there are 8 letters. ठीक है, एंड पहला बोल रहा है वॉवल शुड कम टुगेदर. व्हाट आर वॉवल? ए ई आई ओ यू. इसमें वॉवल क्या है? ए ई यू. So 3 vowels are there. And I want to treat them as one unit. ये जब भी आएंगे वो एक साथ आएंगे. But अपने आप में they can be arranged in different ways. मतलब I can have A E U, I can have A U E, E A U. ये सब possible fine है. Different arrangements are fine, right? But I will be treating them as one unit. So if I will be treating them as one unit, so if I remove them, इसको एक मान के चलो, take them as one. A E U is one. ठीक है? What remaining alphabets are left? 1, 2, 3, 4, 5. So these act as one and remaining 5. So total are 6. These 6 can be arranged in 6 factorial ways. But these 3, जबकि ये एक साथ ही आएंगे, they are one unit, but within them they can be arranged in different ways. You can have AEU, AUE, EAU, UAE. So these in themselves can be arranged in 3 factorial ways. So you will get the answer as 6 factorial into 3 factorial. This is the number of ways in which vowels come together. Now the second question says vowels do not come together. So do not come together matlab it can be total minus coming together. So what are the total ways? Total there are how many alphabets? 1, 2, 3, 4, 5, 6, 7, 8. So in total they can be arranged in 8 factorial ways. तो नॉट कमिंग टुगेदर कितने तरीके की एक साथ नहीं आ सकते? इट विल बी टोटल माइनस कमिंग टुगेदर. दिस विल बी नॉट कमिंग टुगेदर. Right? So this is about permutation. Permutation is always, always, always related to arrangement. Now let's talk about combination. अब जब हम combination का बात करते हैं, when we talk about combination, combination does not concern itself about arrangement. उसको कोई मतलब नहीं है how you're arranging. Combination is only concerned about selection. So combination is always concerned about saying that, okay, there are 10 people, जिसमें there are 5 boys, 5 girls. I want to select a committee of 2 people, 1 girl, 1 boy. Who, कौन सा girl select हुआ, कौन सा boy, it does not matter. Right? So combination is only related to selection, choosing. But वो किस arrangement में आप choose कर रहे हो, it does not matter to it. So the formula of combination becomes NCR is equal to n factorial r factorial n minus r factorial. So इसका बहुत basic example है that there are 52 cards of a deck and you have to select 4 cards, but they must be of same suit. 4 cards, but they have to be of same suit, right? So 4 cards of same suit. Same suit माने either all can be club or all can be spade or all can be diamond or all can be heart. They have to be same. Now or को हम जब replace करते हैं मैथ्स में, then that becomes plus. जब इंग्लिश में और लिखते हैं तो वो प्लस बन जाता है. When we replace and in maths, that becomes multiplication. So all club माने कि out of there are 13 club cards, मेरे को 4 cards choose करने हैं, select करने हैं. और there are 13 spade cards, I have to choose 4. Or there are 13 diamond cards, I have to choose 4. Or there are 13 heart cards, I have to choose 4. So there is an odd or here. कि या ये या ये या ये या ये. Either this or this or this or this. So that is where you're choosing. When you choose, तो वो हो जाता है combination. Right? So एक और example ले लेते हैं, very common example, that there is a group of say 4 girls and 7 boys. ठीक है? In how many ways you can select 5 members such that A, there is no girl, B, there is at least 3 girls. तो देखो, there is no girl, मतलब all have to be boys. तो मतलब मुझे इन 7 boys में से ही 5 चूज करने होंगे. Out of 7 I will have to select 5 क्योंकि there is no girl. So for answer number A, out of 7 I have to choose 5. Done. Out of 7 I have to choose 5. So solve it. This will be 7 factorial, 5 factorial, 7 minus 5, 2 factorial. Second, I have to choose at least 3 girls. At least 3 girls. मतलब I can have 3 girls or 4 girls or 5 girls. 3 girls means कि ये 4 girls में से out of 4 girls I have to choose 3. अब अगर मैंने 4 में से 3 girls choose किया and I need a total how many members? 5 members. So 3 girls will automatically mean 2 boys. 3 girls can automatically mean 2 boys. right? So if I'm out of 4 girls choosing 3 girls, I need and 2 boys, क्योंकि मुझे member of 5 तो बनाना ही है ना. So into, out of कितने boys थे? 7 boys. I need 2 boys. Or means addition. I need 4 girls. अगर 4 girl लूंगी, then I need the remaining 1 to be boy, because I need a team of 5 people. तो 4 girls, कितनी girls थी? There are 4 girls only. So out of 4 I will choose 4. And I need 1 boy. And means multiplication. I need 1 boy. कितनों में से? 7 में से. So out of 7 I need 1 boy. Or I need 5 girls. Not possible क्योंकि total girls ही 4 हैं. So this is not possible. So either I can have 3 girls, 2 boys, at least 3 girls में, या I can have 4 girls, 1 boy. Okay. So you just solve this and get the answer. 4 factorial, 3 factorial, 1 factorial into 7 factorial, 2 factorial, 5 factorial plus 4 factorial, 1 factorial, sorry, 0 factorial, 4 factorial into 7 factorial, 1 factorial, 6 factorial. You remember that 0 factorial is 1, 1 factorial is also 1. So 4C4, which is 4 factorial, 0 factorial, 4 factorial, will simply be 1. This is what is combination. Okay. So I'll give you a question. एक आखिरी question permutation combination का करते हैं. You give it a try. Find the number of ways with or without meaning which can be made using all letters of word again. But I'm adding to it. So I'm saying if these words are written as in dictionary, what will be the 50th word? Give it a try. If these words are written in dictionary, what will be the 50th word? ठीक है. Give it a try. Tell me what will be the answer. पहले total number of ways निकालते हैं. So again, in again there are 2 ways that are getting repeated. So total number of ways means there are 5 alphabet, 5 factorial, 2 is A is getting repeated upon 2 factorial. This will be 60. Now it says if these words are written as in dictionary, right? तो फिर what will be the 50th word? अब ये बड़ा क्वेश्चन है जो ISI टाइप क्वेश्चन हो गया, right? So first of all, whenever we have to write the words, ध्यान से देखना, we understand that there are total 60 words which I can create from this. 60 words total इससे create हो सकते हैं. I also know कि अगर मेरे को डिक्शनरी में चलना है, so first I will see all those words जहां पे A पहले आता है. Then I will see all those words जिसमें G आता है. Then I will see all those words in which A, B, C, D, E, F, G, H, I. And then we will at the end see word which is starting from N. ऐसा ही होगा. If we follow dictionary, first all words will come which start with A. Then all words will come with start with G. Then all words will come with start with I. And then all words will come with start with N. So first of all, if I have to create a 5-letter word, first I will fix all those letters where it starts with A. So I am fixing A. So when I fix A, जब मैंने A को fix कर लिया है, the remaining 4 alphabets, A, next A कहीं पे भी I, does not matter. The word is starting with A na, so it will be first in the dictionary. So next it can be GAIN, it can be AGIN, it can be NIGA, कुछ भी हो सकता है, but it's starting with A, so it will be first in the dictionary, right? So the remaining 4 can be arranged in 4 factorial ways. So 4 factorial ways means 4 into 3 into 2 into 1. That means 24 ways. ठीक है? Then what I will do is कि now I will fix G, क्योंकि उसके बाद डिक्शनरी में वो वर्ड्स आएंगे जो G से स्टार्ट होंगे. So when I will fix with G, then I will be left up with again 4 positions. So again they can be arranged in 4 factorial ways, but now there are 2 A's. तो वो A's will be treated as 1 unit now. क्योंकि अब इन दो A में I cannot distinguish. यहाँ पे I could distinguish because I fixed 1 A. एक A है ही नहीं. But here the 2 A's are still left. So I will divide it by 2 factorial. So this will give me 4 factorial by 2 factorial. That means 12 A's. So I have already covered 36 words. A और G के साथ मैंने 36 words cover कर लिए हैं out of 60 words. I have to get to the 50th word. ठीक है? So I will continue the process. G के बाद next alphabet that will be coming will be I. I के साथ भी same process रहेगा. There will be remaining 4 positions. So 4 factorial ways divided by 2 factorial because दोनों A में I cannot distinguish. So again there will be 12 ways. So that means now I will have 48 words covered. So जो remaining words हैं, the remaining 12 words, they are definitely the words that will start with the alphabet N. Because I've already covered words with alphabet A, covered word with alphabet G, covered word with alphabet I. So now I am left up with alphabet N. So I know कि first alphabet will be N. जो मेरा 49th and 50th word होगा, that will have the first alphabet as N. ठीक है? And now I know कि I have to arrange the remaining words in which order? In alphabetical order. Isn't it? I have to arrange them in alphabetical order. So 49th word के लिए alphabetical order का meaning ये हो गया. It means that I will have A, G and I. यही तो alphabetical order रहेगा. And for 50th word, N is fixed, of course, and I have to arrange in the next alphabetical manner. So A, I, and G. Because A's come first. जब हम dictionary में देखते हैं alphabetically, A come first. So that means the next word will be this. So this will turn out to be your 50th word. ये आपका 50th word होगा.
We have A minus B. If I have to find A minus B, then it's like this. I have this set A, I have this set B, and I have to subtract the part of B from A. So if I just remove what part comes in A from B, that means I have to just remove this part of B from A. So I will be left up only with this part.
This is that part of A which is after B has been removed. So I want those values of X such that it belongs to A, but it should not belong to B. So if you see this, then can I write that this A minus B will be A minus A intersection B? Because A intersection B was the area which was common between A and B, which means it would have belonged to B also. I don't want B, so I just remove this part from A, and the remaining part of A that I get, it's not common with B, so that would be the correct thing to do in that case. So A minus B can also be written as A minus A intersection B. Now in this case, if someone tells you that A and B are disjoint, they don't have anything in common, then I know that this will be A minus 5. There is nothing common between A and B. There are two different sets, so it will simply be A. A minus B will be A. If someone tells you that A and B are independent events, then mathematically speaking, the definition of independence is that A intersection B should be A into B in terms of probability. Probability A intersection B is probability A into probability B. So if someone asks you what is the probability that it occurs in event A and not in B, something like this, I will say it is probability of A minus probability of A intersection B. But if A and B occur independently, then I will simply say probability of A minus probability of A into probability of B. So I will keep altering my answers according to the information given to me in the question. If they tell me that they are independent, then A intersection B will be written as A into B. If they tell me that they're disjoint, mutually exclusive, they don't have anything in common, then I will simply put their intersection as 0. And accordingly, I will get my answer. So that's the next thing, that A minus B is such that it belongs to A, but it does not belong to B. Now, we want to go ahead and do something which is called as complements. For complements, we introduce the concept of sample space. Sample space is all possible outcomes. So, for example, when I just toss my coin once, my sample space can be head or tails. That's my sample space. If I toss it 2 times, then my sample space will be HH, PH, HT, and TT. This will be my sample space. If I toss it 3 times, it will be HHH, HTH, HTT. Are you getting it? There will be 8 such events. That will be my sample space. All possible outcomes together formulate a sample space. When we draw the Venn diagram, a sample space is usually drawn with a rectangle or a square. This is my entire set of possibilities. Now, A is one event. So maybe, if sample space is tossing 3 times, then my A event can be getting hit exactly 2 number of times. That's an event A. This event A will only have some of the part of the sample space. So, this event A, no. What you can say is so basically we can say that the sum of the exhaustive events, that is the sample space. That's how we can define sample space. So sample space is all samples together. Exhaustive events is what exhausts the entire sample space. So sum of exhaustive events is sample space. So we can say that this together are exhaustive events. And if I write it like this, then it is a sample space. That's the only difference. Now, when we go ahead and we say A complement, then A complement is everything in the sample space except A. So it's like this. Everything except A in the sample space. So in a way, what I can go ahead and I can do is I can simply say that A complement would be sample space minus A, or A plus A complement will be sample space. Now it depends. What exactly are you trying to find in your answer? So let's say that A is an event that exactly 2 heads occur. And let's say B is an event that 1 or more head occurs, right? Although this would be a different case altogether. So in this case, if you notice, A is that exact, so this is tossing a coin 3 times. So A is an event that exactly 2 heads occur. So I'm going to have H, H, T, T, H, H, T, H, T, H, like this, 3 events. B is 1 or more heads occur. So this will have 7 out of 8. It will not include T, T, T. Otherwise, it will include all 7 outcomes that at least one time head is coming. So ideally in this is my B. This is either head happens 1 time or 2 times or 3 times. This is my A, that only 2 times. So in this case, A is completely contained within B. So I'm saying A is a subset of B. So if A is a subset of B, then if you want to find B minus A, it would be this. So ideally this says 1 or more head, this says 2 head. So B minus A will have those outcomes which have exactly 1 head or 3 head, right? Okay, if I want to go ahead and find B complement, then it would be this part. But if I want to go ahead and find A complement, it will include some part of B also, because then I'm going to go ahead and subtract from A. But anyways, whether I find A complement or B complement, note that B plus B complement will also be sample space, and A plus A complement will also be sample space. This still remains true, that you have a set A and its complement together, it will always give you sample space. Even if A is contained within B, does not matter. If I find the complement of A, it will be all this region now. So A plus A complement is also the entire sample space. And instead, if I find complement of B, it would still be all the region. So it will be here. Still, it will be all the region. B plus B complement will also be the sample space. So, is it correct that exhaustive events are subsets of the sample space? Ideally, yes, you can say it in a way, because when we talk about exhaustive events, they are the events which exhaust the entire sample space. This is how we usually frame it grammatically. So you can say that all exhaustive events together combine and form the sample space. Okay. So here I was saying that this is one thing, that A is contained within B. But what if someone asks you something like this? This is my sample space. This is event A and this is event B. And I want to find, so I want to go ahead and find out the complement of A intersection B. So I want to find A intersection B complement. It would be, A union B complement. A union B complement, this is going to be this region. Now, by definition of A union B, we said that A union B is that it happens at least 1. So, what will be its reverse? What will be sample space minus A union B? That it happens never, none of the times, because union tells me that it happens at least once. So this is not happening in A, neither is it happening in B, which means it is not happening any time. That will be the complement of A. That will be of A union B. So you have to be very thorough with what the question is going to ask you. There are many laws related to complements also that we will just see. Now just talk about the algebra of sets. The first is called commutative law, very, very simple. Whether I find A union B or B union A, it's the same thing. Whether I find A intersection B or B intersection A, it's the same thing. Whether I first find A union B, then union C, or B union C, then union A, it's the same thing. So it's like this. I have this A, B, and C. So whether I first find B union C, and then I add A to it, or I first find A union B, and then I add C to it, it's the same thing. That's the basic associative law. The same is true for intersection also. Then you have distributive law. This is interesting. See that when I find A intersection B union C, it is equivalent to A intersection B union A intersection C. And how can you see this? So you can go ahead and you can formulate A, B, and C. B intersection C means I have to take common between B and C, which means this area. And if I have, I'm doing this one. B intersection C means I have to take common between B and C. So I took this area. And now I have to take its union with C, with A. So which means that I will include everything of A with it. This means that it happens in both B and C. This means that either it happens in A or it happens both in B and C. So read out the sentence now. Either it happens completely in A or it should be both B and C. So it's like this. If in exam you're given many criteria, suppose the question says that in order to get through the entrance exam, the following must be true. 1, you must have marks plus 60% and you must have top 10 rank, or you must have 90 percentile in undergrad. Something like this. So when I talk about this condition, I have to fulfill both of them. This and this. So B and C or 90%. That is what this means. Now when I open it, I go ahead and I take this union here, this union with A and C, and then I find the common area between the two. I can go ahead and try this here also. So for example, if I have A, B, and C, A union B will be this. And A union C will be this. Let me mark it with a separate color. And now I'm checking what is the area which is common between them, the area which gets colored with both of them. That is going to be the same thing. So you will never get this part. This will not come and this will not come. So it will be the same thing, that either this criteria of A should be satisfied or both B and C together should be satisfied. So this is your distributive law. Then you have your complementary law, that A and A complement together make the sample space. There is nothing common between A and A complement. So their intersection will be null. And then you have that A union with sample space is the sample space, and A's commonality with the sample space, that is going to be your A. So now you can have this difference law. This is A minus B is A intersection B complement. You can just keep proving these things. So you have A, you have B. What is B complement? B complement is everything except B. So it is going to be here. Everything except B. This part. And now I want to find its commonality with A. So what area will I get? Only this part is common with A. And if I go ahead and instead find A minus B, suppose I now just find A minus B and get the same answer. This is entire A, and I'm subtracting the part of B from it, so I will only get this much part. So A minus B can be written as A common with B complement. Similarly, A minus B can be written as A minus A intersection B. And this can also be written as A union B, everything A between A and B, minus you remove the B part. So you will get only that A which is not common with B. Now you have something which is known as De Morgan's law. These two laws are important. So the De Morgan law states that A union B complement is A complement intersection B complement. Again, for us, it is enough to just see through the Venn diagram. So we will try and see that. So this is A, this is B. I find their union, which means the entire area. And then the complement of that, which means everything except A union B. In this part. And the other says A complement. So this is A, this is B. A complement means everything other than A. And B complement means everything other than B. And if you see what's the common between the two where both the colors are coming, you will see exactly this region. Right? So same thing. Either you find A union B complement or A complement intersection B complement, you get the same answer. Now this is the reverse of it. So here what has happened is instead of union, I have taken intersection, and instead of intersection, I have taken union. You can try to prove it yourself through the Venn diagram. Then we have something which is known as the involution law, which says A complement is A. So this is very simple. See, A complement is nothing but what's A complement? Sample space minus A complement. So this is going to be complement of the sample space minus complement of A. Now just think about this. When I go ahead and I find the complement of the sample space, it's like saying that there is nothing left. It's the opposite. Sample space consisted of everything. If I'm going ahead and finding the complement of sample space, I will be left up with a null set. There is nothing left with me. And from that null set, if I subtract the complement of A, I should be only left up with A. So A is just going to be, so in a way, the sample space is consisting of only two parts, A complement and A. So if I just exhaust the entire sample space, I have two parts to it, and I'm subtracting A complement from it. So I should just be getting A from it. In order to prove this using Venn diagram, you can just try it. This is A. The complement of A will be this. It is sample space minus A. And then I am again finding the complement of this. So I will be just left up with whatever is inner to this, which is again A. So this is what the basic rule says. A union A. Everything between A is common with A, so it's A. And A intersection A. Everything is common between the same set, so it will be A. There are two additional definitions that you should know. One is called a ring. A ring is non-empty class of set which is closed under formation of infinite union and differences. So anything is called a ring if it satisfies these two things. If A belongs to ring and B belongs to ring, this is only true if I find their union and it belongs to ring, and I find their difference and that also belongs to ring. Let me give you an example. Suppose A is a set of 1, 2, 3, 4, 5 and B is a set of 4 and 5. So A union B will be 1, 2, 3, 4, 5. A minus B will be 1, 2, 3. If I define a ring, which is first 10 natural numbers. Suppose I say this is defined by first 10 natural numbers. A belongs to that. B also belongs to that. A union B also belongs to that. A minus B also belongs to that. All of them will belong to first 10 natural number set. So then R is called a ring. So it is called a ring if you have union and differences possible. Those union and differences, if they can be found within that set, then it's called a ring. The other definition is a field. Field basically is by forming union and complements. So same, let's define A as 1, 2, 3, 4. Let's define B as 7, 8, 4. So let's define our field as 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. First 10 natural numbers. What will be complement of A? Complement of A will be 5, 6, 7, 8, 9, 10. I have defined my sample space also with first 10 natural numbers. So complement of A will be 5 to 10. A complement will belong to F. A belongs to F. B belongs to F. B complement belongs to F. So if all possible union and complement belongs to a particular set, then it is called a field. It's not very useful for you. You will appreciate field and ring only when you do your masters in economics. In that statistics class, when you will formulate the field, you will understand why they are important. But for now, this definition will suffice. So we have done what is sample spaces, the totality of all possible outcomes of an experiment together constitute the sample space. We did what an event is. So event is just the outcome. Like, you know, I throw a dice, I toss a coin, right? So that's my event. And we have various statements that you may want to understand. The first one is called at least one of the two things. So whenever you see at least, you will find union. At least find the probability of at least one head. Find the probability of at least the sum being 5. Whenever you see at least, it means union. Whenever you see the probability of both, find intersection. Neither nor, find intersection between the complements. So when I say neither A nor B, it's this. This is my sample space. This is A, this is B. I want neither A nor B. So it should be this area. neither A nor B. So I can say that because I want neither A nor B, it is sample minus A union B. But if I find A and B, then the complement of A will be this. Complement of B will be this. And the common area between the two will be this. So this is exactly the same thing. So in terms of probability, you can say that, so neither A nor B, it can be written as probability of sample minus probability of both A and B, either A or B. And probability of sample, all the events together. It's sum of exhaustive events. So probability of sample will always be 1. So it is 1 minus probability of A union B. So if someone says find probability that neither A nor B occurs, it will be 1 minus either A or B occurs, and it will be 1 minus probability A union B. If you want, find this, or simply find the probability of A complement intersection B complement. I find this easier, right? So either A occurs and B doesn't occur. So A is occurring and is represented by intersection. B is not occurring, so complement of B. Not more than one of the events occur. This will also be coming in exam. So they will ask you, find what's the probability that, either A wins and B loses, or B wins and A loses in a gamble. Both cannot win together. So which means at any point of time, one event can occur. If A occurs, then B cannot occur. So I have to put an and in between the two. A occurs and B doesn't occur. So A wins and B doesn't win. Or I can have A intersection common union B. So A doesn't win and B wins. Sometimes they will say that find that not more than one event occurs, which means either one of them occurs or none of them occurs. So sometimes you may want to add that none of them occurs. It depends on the question and the statement. So they may ask you what's the probability that A wins and B loses and B wins, A loses, or what's the probability that not more than one person wins. So not more than one person means both can lose also, but more than one will not win. A will win or B will win or none will win. So accordingly, you will formulate your sentences, right? If A occurs, so does B. So occurrence of A is sufficient to tell us that B will definitely occur, which means A must be a subset of B. It must be included in B. So A is a subset of B. I've tried to include as many sentences as possible. Event A and B are mutually exclusive. It means they have nothing in common. So fine. Now let's talk about some of the properties of a probability function. The first property is that your probability should always be greater than or equal to 0. Probability of sample is 1. And probability of unions. Whenever you see disjoint events, the probability of unions is just the sum of individual events. It's like this. Imagine this is event A, B, C, and they have nothing in common. So if you ask me what is A union B union C, I will say A union B union C, which means I will add A plus B plus C. So if you ask me what is the probability that one of them will occur, but there is nothing common between them, I will simply add the probability of individual events. Probability of A1 plus A2 and so on. Just add them. This is only true if they're disjoint, if there is nothing common between them. So for mutually exclusive event, probability of A union B is probability of A plus probability of B. Otherwise, we will write probability of A union B as A plus B minus A intersection B. So we will subtract the part which is coming common between A and B. Why? Because imagine that I added everything from A. This is everything from A. This is everything from B. But this part, this is getting added twice. So because this came twice, I must subtract it at least once. So I subtract this part once and I get A union B. But if they are disjoint, they have nothing in common, this will be 0. So it will automatically give me PA plus BP. What if they're independent? Then probability of A intersection B will be A into B. So we will have probability of A union B as PA plus PB minus PA PB. Right? So this is what can happen in this case. So now, if B is a subset of B, just correct this. I think this should have been if B is a subset of A. If B is contained within A, then it is asking what is common between A intersection B complement. We know it's this area. So it will be A minus B. Sometimes this may come in exam. This is when A, B, and C, all three are involved. So probability of A union B union C is A plus B plus C minus A intersection B, B intersection C, C intersection A plus A intersection B intersection C. If you want, please try and prove this using Venn diagram. Add A to B, then add C to it. See that these will be coming twice, so we are subtracting it once. But when we subtract, this will be subtracted, so we add this back again.